like, because we don't want to like at the last minute, but loading screen. On the abstract properties, different, right now. I'm gonna post it here. When do you go back? Hurry. And this is our oasis. She's not that good. Famous, but not famous. I know. I don't know her. So, okay. I put a title over what she's doing. She's a there's I saw that. So it's like for also about he is outside of that. So I think it's weekend. He thought it was Friday. When he said yes, he thought it was Friday. I really looked into it. Oops. I really want to be checked. And yeah, I think if we could have like one gap day, Friday, Saturday. That's what I wanted to at the beginning, but I think tomorrow's got the day, right? That is fine. Next year we'll check with the yeah, I think moving this in June. Yes. Oh, Dr. You did. Moving this in June should be. Yeah. Yes. Just before the industry vacation, after the economics of that. And I'm close to the Grand Prix. I don't know about because there's a lot of roads. Yeah, but there were roads. But it's true. I'm in London. Right? So you know yes. Max. So yes. I think we may have met at a conference very quickly. Yeah. Very good. Good night. Yes. I'm officially. You know, what's the lead? I have. You know this. Okay. All right. I see. You know, right? Yes. I think we're okay for now. Yeah, maybe we can see that the front for now. So that's. I think we'll probably stand up. Yeah, we have either USB-C or HDMI. So whichever one was the big one, we have two adapters. This one is very VGA. We have an adapter, like USB-C to VGA. I didn't even know they made VGA. And we have a clicker if they want to use it here. So for your participants, just in case. So if they forget it's not working, it's probably your file. Yeah, right now it's
Yes,
I can promise that because I wouldn't use this. No, I would just use the standalone.
I'll search.
Yes.
It's unlisted.
Try on my computer not to sleep. I think they just sleep.
Okay.
Sorry, my brain.
Yes.
It's very good at it. It will be just this. Like once that when
Yeah,
you plug this, everything should be.
What I'm reading is. In Marlins, my computer starts to run out.
Oh, but okay. Yeah, I know. Mine is very good at sleeping.
Can I say like any rules to the direction for shares the system?
Oh, it is necessary.
There is yes.
Get this out. on research anyway.
She did the opening. She knows.
Because they won't know, right? No one's sitting in the room, will watch. They will make it fun. Yeah, that's how they. I think that's when it's assuming so there's a little bit of a delay, but there's no interactions. As long as nobody in the room watches it, nobody will.
This is upon us. I don't think after that we go we connect the computer. So it's probably tomorrow.
So what I do is I just put this links to
And maybe if you want to, you could have the Twitter person post the links when it starts. Yeah. I'm very bad with things.
so complicated.
Yes, I'm very bad with it.
And I do the years how I used to, because I knew. Yeah, I can make it pretty good.
Yeah, it's that's the.
Yeah.
Mike, there's a mic.
Do I need it?
If you, this is this one, if you speak loudly, you don't need it.
So just to make sure that it doesn't.
So when I started, I assume at a time we started.
Because right now we said that I think it should be at 9 o'clock, so at 9.
Maybe some year, that was part of 15 of the
Okay, so let's see. And then we go to.
They didn't have a chance to. talk
Exactly, you
yesterday.
were like,
So it was very nice to meet you.
very nice to meet you
Thank
as well.
You just arrived.
Yes, I like this. Very close.
Oh, where? What? Oh, Pittsburgh, yeah.
I mean, if there was a direct flight, this would be enough.
Yeah, that's sometimes a problem.
Philadelphia, I went to Philadelphia.
Nice.
That's not the best connection. Right.
Right, and are you going to stay with more or just?
Well, tomorrow afternoon.
Oh, you're leaving.
Yeah.
Okay.
They wanted to be back by Monday.
Right, right. Yeah.
It's not
It's getting colder.
It's actually moves you in the afternoon.
Exactly. Probably less of snow.
Yeah, and there's no snow.
Okay, yeah. And they say, oh, but something very light.
Yeah, but it's like
Okay.
it's a huge
Yes, I joined last. Probably said that she was at Michigan for this fine weather as a postdoc, and then I moved back to Montreal. Started.
Yeah.
But I think. But now I'm learning French more seriously.
I know,
How to
it's like
teach.
that. This was what I would love to. I'm originally sister, so English is my second language, but to get out of very quickly, this English.
Yes, I know. When I came here as an international student, I knew that people speak French here, but it was like.
Where are you?
Iranian.
Iranian.
Now, like 15 years ago, as a master's student.
So then you're working in AI?
No, it's the AI software industry, so more of like human factors. I've used some AI,
Yeah.
for sure, but my research is not direct.
So mine has I work with some architecture, and that's kind of when you have that new.
Exactly. Yeah, it becomes like a tool like math that you can apply.
There's the tool, or there's like reality, right? When class. So how are you enjoying like being the professor?
It's good, yeah, interesting. My daughter is now like 2 months old, so it's a bit difficult.
Yeah.
Sorry. Somehow we're on. So.
Oh, sorry.
I want to come on to my friends.
Yeah.
They want people to stop. She's not water is cool. It's now. I remember when my father was still doing my PhD. And yeah, that's had my. I guess one of the sessions what was the best that happened. And everybody is talking about a paper published. So then I remember thinking, what was the best? And that was a year where the first year that she didn't get us. Everybody was I mean, I think it's also those three cases, and especially now, COVID, it's also like this. Oh, yeah. That was that year's sickness. The only sickness I got that was COVID, which was like they're now 20 and 14, so I got it for my 20-year-old. I somehow I guess I never kept like mothers. Yeah. Yeah. So you were pregnant? Yeah. Oh God. That's two months last year. And I was like, before that they allowed. Oh, that's okay. Thank you. Oh God. Yeah, so like you had it easier, yeah. Oh, that's nice. Close enough. That's nice. Of course, and then she was like, And he gave me that $100. I have two daughters. Like, the older one is, I had to see, she's 21 in January. She's in college, and that's the younger Oh, thank you for calling me a young mother. Doesn't feel like that. But I complex word, like the word in the world that she would say. She wouldn't say, the only time she would say mom was if she was really hungry at night. Ask her, but then she wouldn't. So I enjoy it passing. So I advise her like it was really there. So it's wonderful. Even this was also quite young. Plays a lot of sports. Ever since she we always asked the way she managed stress. Well, this week we find out that she had bored. It's not a serious thing, but like it's like you feel like, oh my God, what kind of an old mom? I know, we all that's the other thing. Yeah.
How are you doing? Nice to actually meet with you face to face. No worries. Thank you for organizing this. This was quite an endeavor. Yeah. I just want I took the last night. I discussed with you. I've taken that flight from Chicago to Montreal. And some delays here, there. So I stayed the whole 3 hours. Yeah, so yeah, we have our major airport at this point. And that's the point you were to Chicago.
Yeah.
How are you doing? I'm good. Hi, how are you? Good. Good. Yes.
Exactly.
How are you doing? It's
Could you tell people to?
yeah, I think we should emphasize it.
Yeah, I'll go.
Volume, thank you very much. So far, so good. So far, so good. I'm not you. Yeah, yes, she's collected valuables. So once I reach all the
So I think I will get in. The director of research, she's doing the next study now.
Yeah, very sorry.
So once I reach the. They just need to.
I checked. Was it? Anyone else?
Okay, so good morning, everyone. Welcome, Polytechnic Montreal. Thank you very much for actually being here on this Saturday. Right, so we're very excited to actually see you friends in person for this event. So that's very much appreciated. I hope everyone has a smooth ride in and could find its way very easily on the campus. Right, we have a very interesting ahead for us. So we will start so that we don't get further delay in the program. So this is actually the 5th edition of SEMLA. So SEMLA started, I would say, starting in 2018, right? And this has been going stronger and stronger thanks to the interest from the community. So for people attending for the first time, maybe just a brief, what is SEMLA, right? Like why we thought it was so important to create this space for discussing this topic, right? So I think there's no secret and it's obvious for everyone that machine learning grew a lot in maturity in the past few years. And machine learning enabled products are being deployed every day at a very fast pace, right? And one thing that is very critical for this is how we ensure that our engineering of this new, I would say somehow new type of product is done in a way that it's safe, trustworthy, responsible, and so on, right? And we thought at the time when this phenomenon was picking up that this required a conversation and skills at the intersection of both, right? Both software engineering and machine learning, right? Because you can figure the maths to actually design very effective learning algorithm, right? Road to that process, but turning that in a product that you can actually deploy in to millions of users require a lot of skills in deploying, designing, testing, architecting, monitoring, tracking the evolution, and so on, right? And that is something that the software engineering community had been focusing on and building practices for 50 plus years, right? And we thought it was very interesting, important that we integrate these two aspects and ensure that we jointly work to build this product instead of starting to reinvent things from one side or the next side. So that was the core idea at the heart of SEMLA. So SEMLA is really a space for experts from both software engineering and machine learning to meet and discuss about these challenges, right? How we build effective solutions going forward. So who is behind? So SEMLA is from the beginning, it's an initiative that's grew within the software engineering department. There have always been a lot of people actually working behind the scene for this. So this is just a snippet of people actually contributing to this. So these are my colleagues. I think most of them are in the room. I think this year's edition specifically, I think big shout out to Max, Hank, and Mo. I think these guys are really, working hard behind the scene to make this work. and Jingwei, Julio, Zore, and to a small extent myself, I would say. But we are trying contributing to make this happen. And I would say our army of volunteers, right? All our student volunteers you see with a SEMLA t-shirt. Please, if you have any question or anything, just reach out to them. They are well organized, well prepared to make sure that you have the best experience at the conference. They are really the people behind the conference. And we have Joanne Lemieux as well. I think she's on the other side, like ensuring that we can have our coffees to keep us away during the event. Okay, so this is the theme, and we can do this with, because we have very strong backer, right? Like the departments and Polytechnic have been putting resources in this, and Ivado, it's from the beginning have been the institution really investing and putting all the effort to ensure that we can make this space something viable on the long run and very interesting for everyone. So we couldn't do this without the support of these institutions. And now I think Annie Gracie agreed to give us some few words of welcome from Polytechnic. So Annie, it's our Deputy Director of Research. She will be online because this is the weekend. We didn't want to really push hard on this, but she actually gracefully agreed very early in the morning to speak to us. So Armstrong, can you pass on? Annie, I think I need to unplug this.
Oui, bonjour, est-ce que vous m'entendez?
Sorry.
Bonjour, vous m'entendez?
Oh boy, there's some sound coming. Can you send the videos? No. So we say crash testing the video earlier in the morning. So Annie is there.
Mhm.
Can you zoom on Annie? Okay. I think that was fun. Just the sound.
Est-ce que vous m'entendez?
Oui, c'est mieux. Bonjour Annie.
Bonjour, bonjour, bonjour tout le monde.
C'est à toi.
Merci beaucoup. Good morning, everyone. I'm really happy to see you all early on a Saturday morning. So you see me from my home, but I'm with you with my heart. So my name is Annie Ross. I am the VP, Deputy VP Research and Innovation at Polytechnique Montréal. And in the name of Polytechnique, I would like to welcome you all to this 5th edition of the SEMLA workshop. The purpose is to let me maybe switch to French. I'm sorry, I had prepared this in French, so maybe I'll switch and I'll give you a few words in English in the course. So, le but de cet atelier est de réunir des experts et des expertes internationaux afin de discuter des défis liés au développement et à la mise en production des applications logicielles intégrant l'intelligence artificielle. Aujourd'hui, vous êtes plus de 180 personnes réunies ici. Bravo. You're more than 180 persons here, as far as I know today. So congratulations to you all. L'apprentissage machine et l'intelligence artificielle font l'objet d'une grande effervescence, tant au sein des communautés de la science et du génie que dans l'espace public. Les exemples d'applications fondées sur ce domaine et cette technique pour l'accomplissement de tâches ou l'aide à la décision se sont multipliés au cours des dernières années, tant à des fins expérimentales que pour une utilisation pratique au quotidien. On peut penser par exemple aux multiples assistants vocaux, Google Home, Siri, Alexa, Cortana, Bixby, So this is also English. So we're talking about vocal assistants, but also in our that are in our day-to-day, and also to numerous software that do integrate deep learning, which are at the heart of the functioning of autonomous vehicles, and perhaps really soon to the urban air mobility, la mobilité aérienne urbaine. Cependant, afin de garantir la fiabilité de ces applications, cela reste un grand défi et je suis très heureuse de constater que le thème principal de cette édition du SEMLA est l'ingénierie responsable de l'IA. Responsible Engineering of AI. L'approche traditionnelle du développement logiciel et déductive consistant. Does it show that I haven't spoken yet this morning? So, consistant à l'écriture de règles qui dictent le comportement du système avec un programme codé. En apprentissage automatique, ces règles sont plutôt inférées de façon inductive à partir de données d'apprentissage. Ceci rend difficile la compréhension et la prédiction du comportement des composantes logicielles et donc aussi leur vérification adéquate. Polytechnique Montréal forme des femmes et des hommes qui seront des acteurs importants de ce domaine en forte croissance. En recherche fondamentale comme en recherche appliquée, la communauté de Polytechnique en génie informatique et en génie logiciel, mais aussi en génie électrique, en génie mécanique, en mathématiques, en génie industriel et en génie civil, géologique et des mines, est résolument engagée envers l'apprentissage machine et l'intelligence artificielle. Our research community is really involved and want to go ahead deeply to deep learning and artificial intelligence. Polytechnique possède aussi la toute première chaire en assurance qualité des logiciels d'apprentissage automatique au Canada et l'une des rares chaires IA Canada CIFAR sur les systèmes logiciels d'apprentissage automatique dignes de confiance, dont le titulaire est le professeur Foutsé Com, que je remercie d'ailleurs de m'avoir invité à prendre part ce matin à votre événement, j'en suis honorée, malgré l'heure active. So Foutsé is our Canada CIFAR AI chair, which is one of the rare chairs of the like in Canada. So I welcome him and you to have invited me this morning. I'm honored to be here. Polytechnique Montréal is also a partner of the project DEAL on AI, fiable, reliable AI in the aerospace domain, and the project ADIMOR, which is ongoing with the GHGSAT. Following its strategic plan, Polytechnique Montréal will continue to support these initiatives to allow researchers, designers, and developers in software engineering to go with their full potential to improve machine learning. Lors de cet atelier SEMLA, vous, les experts et les expertes en génie logiciel et en apprentissage machine, vous avez choisi de vous regrouper et de discuter d'aspects techniques de l'ingénierie d'application logicielle intégrant l'intelligence artificielle. Il sera question de formidables opportunités à saisir, mais également de risques à cerner. Je pense notamment à l'automatisation de nos biais à travers ces logiciels et aussi des défis à relever. En raison des possibles répercussions humaines et financières, les applications fondées sur l'apprentissage machine et sur l'intelligence artificielle requièrent un très haut degré de confiance et une forte acceptabilité de la part de leurs utilisateurs et du grand public. L'assurance de la qualité et la fiabilité s'avèrent aussi cruciales, tout comme le respect des balises établies. So quality assurance and reliability are crucial for acceptability from the users and the public. Je remercie les membres du comité organisateur de l'atelier SEMLA, le professeur Futsekom, Ting-Wei Cheng, Heng Li, Maxime Lamotte, Mohamed Hamdaka, Zoreh Sharafi, du département de génie informatique et de génie logiciel, pour leur implication remarquable dans la préparation de l'événement. Je souligne le soutien de la directrice du département, Nicolas Nicolescu, Gabriela Nicolescu et son équipe du service informatique et du service des finances de Polytechnique, et de toutes les personnes, bien sûr, qui ont contribué à la tenue de cet atelier. Merci à vous, conférenciers et conférencières provenant de Montréal et du monde entier. Thank you, dear speaksperson coming from Montreal and all over the world. Dear participants, I'd like to thank you to be present here at the SEMLA workshop, and with the interest that you're showing in software engineering, you're showing a real will to play a fundamental role in the revolution of machine learning. So, je souhaite que vos échanges soient fructueux. I hope you have really good discussions, which will lead to the development of tools, techniques, methodologies for an adequate engineering of these softwares, and that will allow to find ways for future researches. So, ladies and gentlemen, thank you very much. I wish you a very good workshop and a very nice stay in Montreal. It's a nice day today. I hope you have a chance to go out and catch a bit of sun. Thank you.
Merci beaucoup.
Merci, Futse. Alors, bonne journée.
Merci. Bonne fin. À bientôt. So, thank you everyone for being here. Just a few logistics before we really kick start our day. We have a packed room normally. We may not be packed yet, but in theory it will be very packed today. We have many students, which I think is very important for this type of event, because you are engineers of the future. You will be tasked to design these reliable systems. We have industry participants as well as faculty members in the rooms. I think we have a nice mix. So our program is, we have 4 keynotes that we'll have within the 2 days. We have 2 industry keynotes. In addition to the academic keynotes, we have 3 panels, 2 tutorials. I really strongly encourage the students in particular to attend those tutorials. So we have a very hands-on tutorial testing machine learning and other systems. And we have a regular class. We have a reception today with the partner session. And there will be a prize for Best of Star Wars. So I think this will be very exciting. So some practicality, maybe maths.
So first of all, I'd like to apologize. There was a bit of a misunderstanding with the breakfast situation. So there will be food for breakfast. I know there wasn't any at the beginning, but after the first or during the first break, there will be food. We will be served breakfast. You will just be a little bit hungrier when you eat it. And so the food, breakfast, coffee breaks, including the reception and the posters tonight, will all be in the room where you came in today. So the Galerie Roland, which is right across the hall here. So you don't have to go any further than that. But for the lunch, we will have to go down to the first floor of this building in the cafeteria where we will eat lunch, because we have so many people that we will not be able to sit in the room across from us. So we'll have to go down to the cafeteria. There will be volunteers to help guide you to that area so you don't get lost in the snakes. Very important, we ask that you please not bring any food or drink in this room. I understand some of you may have water bottles. If it's a water bottle that's contained and it's not going to spill, as long as I don't see you, I guess I won't stop you. But everything else is fine. So for the poster sessions, the posters will be in the room across the hall once again with the cocktail. You should have received some little papers to allow you to vote. If you haven't received them yet, some will be available during the poster session so that you can vote. So the best poster award will be given to the poster with the highest number of votes. So please feel free to go around, view all the posters, and vote for the one that you think is the best poster of the session. For the internet, if you are an academic, you can use the EduRoam network with your usual credentials. If you are not an academic, please still use the EduRoam network, but use the username and password. So the username is in blue right there, brgb@eva.eduroam.ca, and the password is the very simple GMFAS. I will get some printouts printed in the gallery as well so that you have this information for the rest of the event. So everyone will have the same username and password if you do not have an EduRoam account already. Finally, and I hope this doesn't happen, if you have an emergency, you can ask for a volunteer, or if you have a cell phone or you see a phone around, a red phone, you can dial 4444, and this will get you the building security to come and help you should you have an emergency. That being said, have a great day.
Thank you very much, Max. So in any case, we have our volunteers around. Really feel free to reach out to them with any queries you may have. Okay, so let's get started. Please. Right, so we have our Twitter account and then we use the hashtag. So we want to amplify the signal of the events. We will be live streaming. So we didn't announce before, but people who couldn't actually register for the event will be able to follow the stream. So we tweet about it. So please contribute to sharing that. And what do we expect? Well, exchange of ideas. So please discuss, reach out. We have a fantastic program, many guest speakers coming from far away across the world. It's a unique opportunity to be close to those experts. So please reach out to them, discuss during the break, cross-fertilize ideas, network, and have fun. Okay, that said, welcome to SEMLA, and we get the business. So our first keynote speaker would be from Madam, and please, I pass you the baton for sharing.
Okay, hello everyone. So thank you so much for coming, and it's so good to see all of you here today. So this is our first session, the Q session, and the Q session theme is sustainable and responsible AI at scale. So we have 3 speakers, keynote speakers in this session, and each speaker will be about 30 minutes, including Q&A. So you may ask a few questions after each talk. Okay. And if you have more questions, you can reuse questions to our next session, which is a panel discussion on the same topic. So I'll introduce our first keynote speaker, Dr. Ipik Oskaya. So Ipik is from College Mellon University, a software engineering institution, and she is the technical director of engineering, intelligent and software systems group. And her main areas of expertise and interest include software architect, software design automation, and managing technical debt in software relying on AI-enabled systems. So I will give the time to Dr. Ipik.
Well, thank you very much, and thanks a lot for inviting me. This is my first conference after the pandemic. Last I was in 2019 FSC, so I'm extra excited to be here, and such a great turnout. So without further ado, I don't have a lot of time. Oh, Mike. Is it better now? Yeah, okay. Better? Now I can. Let's just get into it. I think we all know there's this excitement around AI. There's excitement that it's going to solve all our decision-making problems. There's excitement that it's going to create new products, autonomous systems, all sorts of good and all sorts of responsibility that comes with it. But I would like to challenge us a little bit in terms of where does the intersection between software engineering and AI ML sits, and also a disclaimer when I say AI, and mostly do mean machine learning systems, but there's also some confusion overlap there as well, and I'm looking forward to the discussions afterwards. Thanks for the introduction, but a little bit about me. I did my PhD in computational design at Carnegie Mellon University, and I've been working at the Software Engineering Institute since 2006 after finishing my PhD. My areas of expertise and passion, if you will, managing technical debt, and now more importantly, how we bring in new elements, new design components into systems. Today it's AI, but tomorrow it might be something else. And how does that system and design behavior change? And how do we manage for trade-off analysis and quality? Some of you might also know me because I am the editor-in-chief of the IEEE Software Magazine. Some of you are contributing as authors, as associate editors and reviewers. But I think the point is there's this community of us as software engineers that exist within our organizations as well as within the community. And you will see that there's a lot of interaction that we can take better advantage of. So there are a couple of issues that we featured in AI engineering, software engineering for AI, and more to come, and I encourage you to take a look at that. And then a little bit of personal information. I'm originally from Turkey, and I immigrated to the United States to do my master's and PhD. And the two cities that are near and dear to my heart, Montreal is another great one, but the two cities that I really value and cherish is Istanbul and Pittsburgh. They are both city of bridges. And I think the work we do is about bridging, like bridging software engineering, bridging computer science, algorithms, machine learning. And I think that's important to keep in mind because if we don't bridge them well, we create replication, we create confusion, and we also create less quality in our products. I want to take a very quick minute to talk about where I come from in terms of the organization as well, because I represent different kind of an organization as the Software Engineering Institute. Carnegie Mellon University, I'm pretty sure most of you know about it. It's a global research university. It's a small university, and it's well known for its computer science, engineering, and a lot of the quantitative programs. It's ranked among the top, and in computer science, AI, and some of the engineering disciplines, it's ranked top in the world in terms of research. And I don't mean this to boast, but I mean this in terms of Carnegie Mellon knows the dark ages of AI pretty well, both in terms of funding, in terms of challenges, and in terms of what it needs to get out of those dark ages. And there are multiple campuses. Why I put this is because I'm often confused to be a professor from the Carnegie Mellon side. Naturally, I work at the institute, which is called the Software Engineering Institute, which was established in 1984 by the Department of Defense with the goal of advancing software engineering. That is a pretty cool goal and pretty bold statement to be made by a government that we rely on software and we need a research institute dedicated to understanding research and applying that research with organizations. So we are a research body. We do sometimes work with students, but we hire students. We have interns as students. We sometimes sponsor PhDs with the students, but our goal is to put the research into the hands of people who are going to use that. Currently, we are about 750 people with about 600 researchers, and we operate under 3 divisions: software, more recently established AI division, and the cybersecurity division. Software division was the first, obviously, because it was established for the software. As security arose, the security division was established to focus on the security kinds of challenges. And last year, the AI division was established to focus on some of the algorithmic and other aspects of the AI divisions. So that's the kind of the background that I'm going to be coming to you. I also wanted to draw your attention to some of the body of work that came out of CNU that had started this AI engineering and looking into the AI. You might also all be familiar with the white paper that was published by Andrew Moore and colleagues that defined the AI stack. At Carnegie Mellon, we refer to the AI stack a lot because depending on where you're working, you might be contributing to different aspects of the AI stack. They have relationships with each other, but they're not necessarily all consider the same kind of approaches, and identifying where that is is important. And don't look into this as an architecture diagram, look at it more as a conceptualization of the different layers and the complexities that go into defining the AI systems. And this is publicly available. I would encourage you to take a look at it if you have not come across. And then within the SCI, because we're small compared to some of the other organizations, and because we have multiple charters, software, cyber, and AI, we try to think of these strategically and try to look into the buckets. There's the core AI, right? There's advances that we need to make in terms of algorithms, and that happens across the world in different pockets. And there is ability to develop systems with AI, which is, I think, where our focus is today and tomorrow, software engineering for AI applications, and understanding how you engineer systems with AI and ML elements in it. And then there's the new emerging discipline, subdiscipline, or whatever you would like to call it, trying to hire good people. Therefore, organizations are rebranding some of their positions as AI engineers. There's all sorts of confusion there, but there's also a real engineering challenge in the AI as well, which is how do I put this component together? What are some of the infrastructure needs that I have, and how does that come together? Again, go to our website, and there is quite a lot of information in terms of how we look into different pillars of these. So let's step back, and if we look into the AI-enabled software systems, let's start by defining what I mean here. So I define an AI-enabled system fundamentally as a software system. And there's one or more components that are driven by AI or use AI, and they need to be developed, deployed, and most importantly, sustained. And I don't think we're at the sustained stage of this yet. We're really stuck in the development, and how do we get to the development to the deployment? And that's when we'll start seeing the real challenges. And how do these interact with hardware and software elements? Obviously, discipline software engineering is key. It's not just software, but there's also security challenges and what that come into it. But it's important to recognize it's the interaction between the software, the data, and the AI algorithms that put these systems together. And in the introductions, you heard my passion, my work, my contributions have been in the field of design and software architecture. So I'm going to take that software architecture perspective and look at it in terms of whether can we really predictably design and sustain these systems. So can we design and analyze AI-enabled systems predictably? I'm going to put forward 4 challenges and 4 recommendations and research directions related to that, and just to set the stage for the conversation. So the first is, what are the ML components and their dependencies? Do we really understand them? Second, how do we model and analyze the high priority quality attributes of these AI-enabled systems? And let me put it out there, fairness is not an architectural significant quality attribute. Let's just say it that, and then we'll come back to it. And how can we monitor these systems? Because a key challenge in these kinds of systems, change happens a lot, and change happens in different aspects, and monitoring becomes a high priority concerning these components. And lastly, because monitoring and change go hand in hand, there's a different notion of change that is introduced, and we have the right approaches and techniques to understand, decouple, as well as design for change. So the first challenge, lack of system perspective. One of the things that we see not only in research, but in our organizations that we work with, and we do work with organizations who are, I won't say as far as when they're deploying and sustaining AI-enabled systems, but they're really trying to get these systems into production. And by that, I don't necessarily mean just the information systems. There are different aspects like the image recognition, voice recognition, and whatnot that is used in more constrained environments. And what they focus on is that black box. I think this paper has been so popularized, and I love it because it brings my 2 passions together. It's technical data and machine learning. So the black box is the ML component, correct? However, you really need that ecosystem around it. And what that ecosystem means is, and this is some research work that we have done at the SCI, and you can read some of the findings that came out of this, is there are 3 different life cycles that are in question when we're developing AI-enabled systems. There is the typical software engineering life cycle that is in the middle. There is the operations perspective that we've kind of been more familiar with the infrastructure, the CI/CD and DevOps and all those kinds of developments. But now we need to take into account the data science perspective. So there is the life cycles and the process view, but what's happening as we think through these systems independently is there are components that need to be developed that serve all three. And that brings different kinds of dependencies, different kinds of structure and behavior questions into the picture. And we need to be able to understand how we architect those, how we decouple them and take a systems perspective. What's happening currently is because it's so difficult already to get the data required to be able to create a functioning and high quality ML model, we're stuck there. We don't necessarily think about, all right, if I put that ML model, which life cycle I'm talking about, and what are some of the other elements that need to be taken into account. So the recommendation here is that you're not just managing one, but you're managing these dependencies from multiple perspectives, and dependency analysis might be taking a new perspective of its own. Hidden dependencies might be significantly harder to understand. So planning and designing for these three different components in the ML system requires the teams to be together, but it also requires the software engineers to be able to understand and ask the right questions. And within my team, I do have also data scientists and engineering researchers. And one of the observations they have is data scientists lack the software engineering perspective. Therefore, they ask the questions too late to be able to help software engineers and themselves in some of these questions. For example, what are some of the test-driven approaches that you could use when we're putting that? Well, if I'm going to test this from a particular performance perspective, what does it mean to understand it from an infrastructure perspective? How do I ensure that the environment that I develop the ML model is the same as the environment the model will run in? Therefore, I don't run into these issues in the way. So these are, in retrospect, simple questions, but organizations are struggling with them because they don't know when to ask them in the right way and the right order. And of course, the difference is that you need to be able to monitor, and we're going to get to the monitoring because some of these changes are introduced in the production environment before you were even aware of them. Inability to separate the data and system attributes is a huge, huge challenge when we're thinking about software engineering and the structure and behavior of the software systems. So there are concerns that are related to system level failures, data dependent behavior, for example, because you may not know some of the data dependencies that are related to resources, the shared resource dependencies that may or may not be even due by the ML components, and the misalignment of the runtime and the development time aspect. There are key data concerns as well, all kinds of ethics and the bias and the incorrect outcomes and whatnot. These are critical. They are important. However, it's not always the software engineering that manages them. The software engineering aspects might be designing for them, monitoring for them, exposing the right information. However, if you have corrupted data, that's a different process. So I think we're getting confused within the community between the quality of the data versus the quality of the system, quality of the model, and that needs to be separated. The approach we use when we take a design and architecture perspective is the quality attributes. These are the requirements that define the architectural significant aspects. So one recommendation is to step back and really think through what are the architectural significant requirements, quality attributes that are important for ML-enabled systems. Of course, depending on the system, their priority will change. And this is an eye chart. I don't expect you to look into them and keep it all, but examples. Like, for example, if we're talking about explainability, we're looking into, I don't only understand the output, but also I want it to be human interpretable, and I want to be able to trace it into the system. What that might mean from an architecting perspective might be how you decouple the model changes from the changes for the rest of the system, so you can really encapsulate. What does it mean to introduce observability mechanisms into the system so you can actually log information in the right way? What would it mean to instrument the system so you can actually monitor it? This is different than the explainability that goes into the algorithm, the data, and the model. And I think that confusion is important to resolve because otherwise we'll be replicating the terms, we'll be replicating approaches, and we will not be making progresses. So I guess my call and recommendation to the young researchers, young engineers of tomorrow is to really be critical in terms of not overgeneralizing these terminologies and maybe first thinking there are many existing practices that help me without before assuming this is new, everything is uncertain and everything is not going to be managed. I'm going to come back to the change. I think one of the most difficult worlds within the AI is being able to understand where change happens and how frequently. And I did say architecture allows for improving the predictability of the data and other system components. So some recommendations obviously is take your data very seriously, but that means what you're looking into, how you're architecting the data pipeline versus how does that data get into the system aspects, how we localize uncertainty. One of the big attributes of AI-enabled systems is uncertainty, but again, quite a number of my colleagues who are experts in data science and algorithms say, you know what, there are AI algorithms that uncertainty is not that big of a deal, or you live with that uncertainty because there are ways to manage it. So before we get into this dark zone, let's step back and look into what can be done rather than what cannot be done. And there's the ethics and the incorporating user aspects, which I know we'll be talking about during the panel as well. And the third one is lack of monitorability. This is a key aspect of the AI-enabled systems, and this is where we look into the sustainment aspect. Before even AI and ML was a big challenge or big opportunity for organizations, large organizations, and here think about Google's, Netflix's, all of these web-based organizations, the approach they used into big data systems was observability and monitorability. When we ask how to manage performance and availability, they reflect that we have really, really good instrumentation mechanisms and we observe, and we're able to take the services out of production very quickly, put them, we do A/B testing in production, and that information drives our design perspective and how we manage these systems. This perspective is going to be even more critical when we see AI-enabled systems and AI systems in production in more critical environments. And what I mean by more critical environments are, think of these constrained environments, first responders, where you don't have resources and you might need to work with a lot of different constraints. So when we think about monitoring, we are thinking about monitoring in multiple aspects. There are components responsible of detecting that ML performance degradation happens. So there's that as part of the overall system. There are components that incorporate user feedback so that improve the system. So there's a level of monitoring in terms of the monitoring the environment. And then there are other components that are monitoring and how they're well adjusted, as well as the overall system performance monitoring. So there is a lot of complex layers of monitoring and observability. So if you're passionate about architecture and structure and behavior, this is really scalability and monitorability is a very interesting area. Quite a lot has been done, but I think there's a lot of room for improvement as well. So recommendation is to be savvy enough to decouple these perspectives. There's good work that is coming from others as well, like my colleagues Henry Lucchini and Karthik have looked into some of these, and they recommend 3 different aspects: monitoring of the ML, monitoring for ML, and monitoring by ML. There's the by ML, well, ML does the monitoring and readjusting, then the complexity of that design gets really, really fun, as well as challenging and uncertain. But again, the recommendation here is, and the work to be done is like, how do we know that which part we're talking about, and how do we ensure we're communicating it clearly? Again, this is an area of confusion that I see a lot. I'm going to leave this as an eye chart, but there is also work to be done in terms of the ML ops perspective. And what's happening here is, okay, if we're putting into monitoring, we have all the operation cycles, just throw another ML monitoring and you're done. That turns out not to be the case. And there is some internal research going on within our group and within the SCI that looks into how does the ML ops cycle need to change when we bring a critical data science perspective to it, as well as a structure and behavior monitoring perspective of it. So my colleague Rachel Rouse is doing this body of work, and her observations and her work says is that there's a model operation analysis step and that is missing within some of these ML ops and data science environments, which could provide some of that information for improving the predictability of the ML model aspects. Again, all of this is publicly available in our blog and others, and I'm happy to answer any questions later as well. And the last architectural challenge that I'm going to leave you with is there are different paces of change. When we talk about software architecture and design, we boil it down to really communicate. It's really about change. There is local change, there's non-local change, and there's architectural change. Local change is when you really encapsulate it, you really design the system so well that the change becomes easy to implement. Non-local change is when it affects multiple elements. Architectural change is where you really want to stay away from it because now it affects the entire systems or more of the system. Then you start getting into refactoring and the technical debt and the quality and all of that good stuff that comes into it. So now we have components that we're not entirely sure how they behave. We also have additional components that have to be there to really make that one component do its job properly. So it's like there is this ecosystem within the system that is existing just to make AI work. So there are different rates of change that come into play. Sometimes data changes very quickly. That might introduce different rates of change for the ML model. Sometimes the data is not changing as much, so it actually becomes a really straightforward to design. Sometimes the data doesn't change, but the other elements change. Maybe the user behavior changes or the users change. So there are the aspects of change and how it affects the ML model, the algorithm, the data, as well as the system is an important aspect of the design decision making in terms of the sustain and design as well as the sustainability of these systems. So the recommendation, so there are designing the pipelines in terms of incorporating the change. So your infrastructure should be savvy enough to understand and react to the change. And again, as I said, monitorability and change go hand in hand very quickly. And this is where you take advantage of your software system in support of the ML. How do you monitor and how do you instrument the system so that you know when you need to retrain? You need to retrain. What does retraining mean? Do you take the system entirely out of production or do you create a shadow model? Again, we're thinking a lot in the model aspect. We're not really thinking about an end-to-end life cycle and sustainment aspect of these systems, partly because we don't see them in the wild a lot, partly because those who are doing it successfully have been doing it successfully for a while, and they probably don't know even how to share their experiences because that's part of their vocabulary. And partly also we're not asking the right questions always at the right time. Decoupling change has always and is going to continue to be the key design principle. You want to decouple change and you want to decouple it in a way that you know where the routine changes or how often do you need to revisit some of these components. That's really key, and it's not any different than the ML models. The complexity comes in from the data environment, how you're collecting the data and how you're incorporating that data into your system. And do not forget the changing environment conditions, because you might have done all the right things, but all of a sudden, an earthquake, for example, right? That's typically given as an example in the AI-enabled systems. That really creates a significant change that might change a lot of the assumptions that you might have. So this is an area that is, I think, really ripe for good, new, interesting research. And there are recommendations and there are some starting points that we already have, like managing ML components, architectural dependencies. We can rely on some of the dependency analysis work that already has been established. We know how to ask the right questions in terms of an architectural significant requirements. We can ask those in a more conscious way when we're visiting the ML components and their relationships with the rest of the system. Decoupling different aspects of monitorability will help us design those components correctly, and embracing the change, anything changes everything principle will also help us see where we need to do better, where we need to develop better analysis techniques, because we may not be detecting these all timely and reacting to them timely. I'm going to leave you with importance of connecting communities. I think this is an incredible effort, and it has already been going on for 5 years, whereas many of these new efforts have been established within the past year or two. So I think SEMLA has already been ahead of the curve from that perspective. But The rest of the communities are catching up, and maybe catching up is not the right word, but the rest of the communities are entering this area as well. And I think it's important to be aware and collaborate in the right way, because we don't want to replicate what has already been done. And God forbid, we don't want to create 5 different techniques that does the same thing, but has different names, different approaches, and that creates just confusion. One of the things that I'm observing is confusion with the fear of missing the hype. So with that, I'm going to leave you with what's going on, and some of this which you might already be aware. The next upcoming issue of the IEEE Software magazine will be dedicated to AI engineering, so it will hit your inboxes pretty soon. There are quite a number of interesting articles in there, and in mine, I challenge AI engineer versus software engineer, so we'll be looking forward to feedback in there. We'll be happy to discuss. There's an upcoming issue that is still accepting papers that is looking into explainable AI for software engineering, and I know many of you are doing work in there, so there's still time to submit articles there. There is the CANE conference that is going to be its 2nd edition this year, co-located with ICSI, and this was originally a workshop, but again, it was born from the need where there's a need for software engineers to look into this a lot more critically, and we welcome all your papers. And last but not least, I said that I'm taking a software architecture perspective in this, and one of the ways I know that the community is coming together in a more conscious way and intentional way is there's a doctoral seminar that is going to be dedicated to understanding how we might work together and understanding where the challenges are. And again, that's going to be within 2023. And if you're interested in any of these and want more information, let me know. And with that, I might have maybe a couple minutes for questions. Thank you.
Thank you.
So I think it was around 5 to 8. Quite sure it doesn't matter, but you seem to mention something about data scientists. So I'll ask the question anyway. You mentioned that some data scientists seem to ask the question too late because they're not involved in the actual code, in the actual development. And
thank you. So, and this seemed to be throughout the rest of your presentation when you mentioned, well, so there's data scientists and there's also MLOps, and that was 2 different categories. And at the same time, you seem to mention that we need cross, competences, we'll say. And from what I know, machine learning is based out of 3 things, mostly Python, linear algebra, and probability and statistics, right? And the statistics part is, I guess, is the data science part, and sometimes it's the part that's forgotten. Anyways, I know a lot of computer engineers who seem to just cross-validate and do all possible combinations of choices of learning rates or whatever, instead of just doing one educated guess and not having, 4 parallel experiments. Anyways, I would like to know what's the solution to that?
So let me repeat the question so that
I can also rephrase it.
No, so I think what you're asking is, we're saying data scientists don't understand computer science or don't ask software engineering, but there are computer scientists, software engineers who go into this and rather than asking the targeted question, create experimentation when there is no need to do that, right? Is that the question?
So I'll rephrase it. So basically, I understand that some data scientists might ask the question too late because they're not involved in the programming, but I feel like some computer engineers or software engineers, they just never ask the question.
Oh,
they just,
absolutely,
right?
yes, yes.
Or they just randomly try stuff.
They randomly try.
And it turns out we have good accuracy, it seems to work, but we don't really know why, so it's not really explainable.
Correct, correct. So there's a lot of, I already know algorithms, so I can just crank one and do that perspective as well that is coming from. What is the solution? I think part of the thing that we need to recognize as a community is this is not the first time we're seeing these challenges. I was in a room with a cell phone company, before, I mean, this is going to maybe expose my age, but before iPhone, I was giving a software architecture class to a group of software engineers who were working in a cell phone company. I said, I don't really understand what is going to happen if the usability challenges will all go away in cell phones because next day, Apple has a phone. And there was this dead silence in the room. And it turned out the problem was they weren't asking the right usability questions because usability was very new to software engineers and the organizations. And I went through this again with the security and privacy. So I think it's the hype will settle, but it's important that we recognize these kind of events help because now we know, like I didn't think of bringing in my talk, but you brought a very important point, and I think that's going to help from that perspective. I think the other thing that's going to help is there's a lot of replication. A lot of replication because let's admit it, we're all researchers, research fundings look for new things. This is new, but is it really new? I think we all have the responsibility. Is there an existing technique that I can use from somewhere that is more disciplined, or is there a new challenge? I think that also comes into the education and research ethics. So overall, the challenge.
Okay, so thank you. I think it's time. So
Yep.
maybe
Thank you very
if you
much.
have more questions, we can ask in the next session. So we have a discussion session. Okay. All right. We invite our
Thank you.
Okay, so our next speaker is Dr. Jinghua Lu. So Dr. Jinghua Lu is from CSI Aerospace 61 from Australia, and she leads the responsible AI science and responsible AI science team there, and she's a principal research scientist at CSR Aerospace 61. And then she received her PhD from University of New South Wales in 2013. And her current research interests include responsible AI, software engineering for AI, software architect, and blockchain. Recently, her paper towards a roadmap on software engineering for responsible AI just won ECL Distinguished Paper Award. And welcome, Jinghua, please. Welcome.
Thank you, Gong. And thank you for the invitation. Hello, everyone. My name is Jinghua Lu. I'm a researcher from SEMLA, Australia. So today in my talk, I'm going to share our experience on operationalizing responsible AI from a software engineering perspective. So before I introduce our work, I just want to quickly introduce our organization. So SEMLA is Australia's national science agency, and we have more than 5,000 people based across 58 sites in Australia and also in other countries. And we have 11 business units for different domains like agriculture or energy and water. But one of the business units is called Data 61. And people always ask me why we call ourselves a 61. So if you check the phone number, 61 is our country code. So it represents data and digital innovation center in Australia. And we have more than 1,000 researchers in Data 61, including 300 PhD students. And we have built very strong relationship with local universities and also government and corporates. And currently, we are leading the responsible AI initiative in SEMLA, and we also host Australia's National AI Center. So one of the themes in National AI Center is responsible AI. So why we work on responsible AI? So here I put some headlines about AI instance. So those headlines I found is from a repository called AI instance database. And as we all know, although there are huge interest in AI technology, but I think people still have concerns about AI systems capability, so whether they can make decisions or behave in a responsible way. So that's why we need regular checks and also risk mitigation solutions to address this issue. And for the definition, I put a definition from the responsible AI book we are currently writing. So you can see from the definition, we think responsible AI is about minimizing the negative consequence of the ethical risk through the entire life cycle of AI systems. And in 2018, Australian government funded Data61 to work on the Australian AI ethics framework. Based on that framework, the government released 8 ethics principles to ensure AI's adoption in Australia is secure, safe, and reliable. And those principles are voluntary principles, which are supposed to be followed by the practitioners in AI industry in Australia. But the issue is it's very challenging to turn the high-level principles into practice, especially for people who mainly have a technical background, like developers. And I agree with Deepak. So we also think ethical issues is more about like a system level issue rather than just algorithm level issue. So it can happen at any step of the development life cycle. It can be cross-cutting different components in AI system architecture beyond just AI component or data component. So in this figure, I give some ethical issue examples from the very beginning planning stage to the very end monitoring stage. So there could be ethical issues about AI application type, or ethical issues about user interface design, about the procurement process, and even the test cases and also the API design, because they could have ethical issues. So our focus is on software engineering approaches and to address end-to-end system level challenges. And we treat the whole system risk and also use pattern-oriented approach to mitigate the risk. And we also work on knowledge-based automated tools to help reduce the risk in the development. So our objective is to make both AI solutions and their development process trustworthy and responsible. And in addition, we also look at how to integrate software engineering approaches, solutions with organizations' existing process. And we have set up 3 research teams, including human-centric AI for operationalizing human value, improve human trust in AI systems. And also we work on responsible AI engineering to capture high-level principles in concrete design and development approaches. And the third theme is about knowledge-based responsible AI. So we want to turn the ad hoc and also the broad external knowledge into more structured, more traceable knowledge. So here, this figure shows the research methods we have been working on. So the first 2 boxes and also the last two boxes are for system level ethical issues. So for example, for governance, we have been working on ethical risk assessment frameworks and tools. And to mitigate the risk, we work on, for example, AI pattern catalog. We take a pattern-oriented approach to deal with the risk. And we also have diversity and inclusion team, a requirement engineering team to work on the guidelines for those topics. And for operation stage, we have people working on bill of material to ensure the supply chain of AI system is transparent and also secure. And our core team for responsible AI, we have like 20 to 30 people. But if we count like affiliates in related AI projects, we have around 50 people to support the responsible AI initiative. We have very good diversity numbers. 50% of our colleagues are female, and including Australian AI Standard Chair, we also have former Red Cross CEO in our engagement team to help us understand the market needs, also provide advice to our science team for the solutions. And 2 of the researchers in our team are included in the top 20 SE scientists ranking. And this year, as introduced by Heng, we published the research roadmap paper on software engineering for responsible AI, and we are writing the first book on responsible AI for practitioners. So it will be published by Pearson next year. And as I mentioned, we host National AI Center. So in that center, we have 3 themes. So in addition to responsible AI, we also have AI diversity and inclusion, and also AI at scale. So at the same time, we have like 3 corresponding think tanks, which were made of a group of people to provide advice and also recommendation to AI industry. So we have organized different types of events like listening to talk to industry people and understand their needs to achieve responsible AI or to achieve AI diversity and inclusion. And through the engagement with our clients and also the launch project, we have identified 4 major challenges in operationalizing responsible AI. And the first one is on risk assessment. So when we talk to our clients, we found in their mind, risk-based approach is a main approach to achieve responsible AI. But there can be different stakeholder interests. For example, in our work, we classify the stakeholders into industry level, organization level, and team level. And in industry level, we not only consider like AI users or AI governance, AI regulators, they also as producers and procurers for AI solution and also AI technology. So for AI procurers, they are very interested in like how to verify or test the ethical claims of the AI solution they bought from the third parties. And also they are interested to know how to identify the compatibility or accountability when third parties are involved. And for organization level, the board members and also executive team, they are more care about organization level risk, but for developers at the team level, they are more interested in like the operational level risk. For example, if you think about the principle reliability, maybe the main interest of the developers. And for the current risk analysis method, we found we mainly look at the hazard analysis, like whether there are any data breaches risk or secondary use without consent risk. But we think they didn't consider vulnerability exposure and response risk. For example, vulnerability could be bad architecture or centralized data store. The exposure can be about how widely the system is used in the community, in AI industry or by the users. And the response risk here, we mean mitigation itself, it could bring new risk or there could be some risk residues. For example, when we talk about human in the loop, it usually like turn the humans into the liability sponge. So it will absorb all the legal or ethical responsibility to humans. So to address those challenges, we are working on context-specific risk assessment framework, and we are building up a pattern bank based on 4 dimensions, including ethics principles, life cycle stages, stakeholders who will ask the questions, stakeholders who will answer the questions. So we want to have like top to bottom hierarchical pattern bank and also end-to-end understanding. And to mitigate the risk, we use the patterns from the pattern catalog we are building. So our pattern is not only about architecture pattern, the product design pattern, but also include development process best practices. So we call it development process patterns. And also we have governance level patterns for different levels, industry level, organization level, and team level. And in one of our projects, we are scanning all the AI projects in Xero, like understand their project context, help them identify the potential risks, and also recommend the mitigation strategies using our patterns. So once we all agree on the common risk and also the mitigation strategy, we then assign more resources to work on the new software engineering tools. And the second challenge is how to integrate the risk assessment framework or approach into the existing organization's governance framework. So the organization, they usually have like centralized risk committee, and they already built up the traditional risk framework for example, HID risk or data privacy, cybersecurity risk. But they do not have much expertise on responsible AI or AI. So they rely on expertise for doing traditional risk to do the responsible AI risk assessment. And some organizations, they just like add fairness of human impacts into their responsible AI framework, but they push down the operational level risk to the developers, rely on the technical expert to resolve the problem. And for most of the organization, they cannot afford like examine all the AI projects through their committee. So they rely on self-assessment by the project team. And one of our consumers, they mentioned they found conversations or broken questions more useful than just technical documentation. So in the communication, they ask some questions like what will happen if a prediction is a false positive or false negative. So they need more sophisticated approach for risk assessment and management. So our approach is focused on measurement and also mitigation. As I said, we have summarized a set of patterns based on the grid literature review and also the academic literature review. And we extended the traditional pattern template. So in addition to context, solution, problem, product concept pattern, also related pattern, no uses, we also specify the type of pattern, whether this pattern is a product pattern, process pattern, or governance pattern, whether this pattern is designed for improving trustworthiness or trust, and who will use this pattern, who are the impacted stakeholders for this pattern, and what are the relevant principles. So currently, we are trying to add more quantitative assessment under the benefit and drawbacks. So we think they will be useful to help maintain the risk profile for the AI system. So sometimes maybe it's not always meaningful to reduce the risk. It's better to make the governance people to be aware of the risk of the systems. So for example, here for AI mode feature, under drawbacks, we have like inefficiency and the suitability for real-time system. So we add some pointers to risk measurement metrics and also methods. Also discuss like human accuracy and machine accuracy. So sometimes for high risk category, maybe human accuracy and cost is better, but on average, maybe it's worse than machine accuracy and cost. And the third challenge is communication barrier because of different types of stakeholders. So software engineers or data scientists, they often find it's difficult to explain the risk to their governance people. And in our work, we try to connect the patterns through different levels, through different types. And these three figures, I'm sorry about the private slide. So these three different figures are for different types of patterns. The first one is governance pattern, which has like industry level patterns, organization level patterns, and team level governance patterns. And the left bottom is the development process pattern. So for each stage, we summarize a set of best practice to help developers manage the risk. And the right side is the responsible AI by design reference architecture we have three layers. The first layer is operation infrastructure layer. The second layer is AI system layer. And the third layer is software supply chain layer. So for example, we have a pattern called regulatory sandbox at the industrial level governance patterns. So to meet this pattern, we need to, in the organization, we need to have this risk assessment framework and also build material in the organization. And in the development team, they could have considered to have platforms to share the ethical claims of their AI models or other data sets. And in the process, we could consider to have like a responsible AI governance through the API. For example, in the sandbox, if they define some requirements about use restriction, so we can consider to have the AI model as provided as a service then we can restrict the API use to only approved users. And in the architecture, we can have some components like a continuous monitoring component and the bill of material registry to support the governance pattern and development pattern. And the last challenge we have here is lack of talent and expertise, especially for small companies. And I put some numbers here for Australian companies. So you can see 71% of Australian, they work in small companies which only have like less than 4 employees. So they really need automated tools to help them manage the responsible AI risk. So one of our work is software tool is a risk assessment tool. So it's like a question answering tool based on knowledge graph. So we integrate our question bank and also the framework into the web portal, and we build our knowledge graph based on the patterns based on the AI instance. And so different stakeholders, they can come to our web portal. We ask questions based on their roles, and based on answers, the fine-tune the language model, they can identify the potential risk for these AI projects. And the second tool we have been working on is dark pattern detector. So dark pattern is a type of user interface which is designed to trick users to do things they didn't mean to do or not in their interest. For example, sometimes we see some font size is very small on the agreement details, or they try to provide limited options to get your personal data. So our tool can highlight the help you highlight the dark patterns on the interface design, also with some short explanation, some examples and possible solutions to address this dark pattern. And the last tool I want to introduce here is bill of material generator. So we just did an empirical study on software bill of material, and this concept is from the US government's executive order on software supply chain. So we want to have the use blockchain techniques and also selection disclosure techniques to manage the data sharing for different stakeholders' interests. So they can share the supply chain information, like who is the supplier of this AI component and which version is provided and what are the dependency relationship for this AI component. So that's all about my presentation. If you are interested in the details of our solutions, welcome to our website.
One or two questions.
Thanks for the nice talk. And in order to comply with the request for the first invited speaker, I would like to raise a small concern. You define responsible AI, including techniques of security, fairness, and safety. I think the machine learning community has already started misusing the term safety without really understanding the design principles of current safety critical systems are being designed, and I see this as a growing concern. Daniel Barrow from the university.
Thank you for the comment. I think people have different principles defined, and there are some consensus papers already for the mapping of different principles. And I think one of the other feedback for the principles is we didn't place human autonomy in the principles, which is also important for AI systems.
Other question.
So, you talk about, okay, we have this bank of patterns that we want companies to use to detect these ethics issues. But I think we just talked about in the previous talk that it's difficult for software engineers and researchers, analysts to even be able to talk to each other and understand the right questions to ask to understand their systems. So people you've worked with, do they have an understanding of their own patterns? Because I guess my fear is there's this bank of patterns, but do companies or processes or teams even understand the patterns they're applying? Because it seems like that's dark even to them. So do people understand the patterns they're using in this context?
I think at least based on my conversation with the industry people, for example, for the chatbot application in some companies, they don't have any like guidelines or tools to support the responsible AI implementation. So that's why they come to us. They want to understand how to adapt the pattern, how to tailor the pattern to provide them more detailed or concrete guidelines rather than just some high-level principles. So I think the first step is always like examining the or identify the whole the development process for their application, then understand what could be the potential risk for each step. So that's the reason we want to build up the question bank to help us like understand the risk. Also, in addition to question bank, we also have the corresponding risk registry. So we want to like test. We just started this project this year, so we want to like test this registry with our internal project first. Then we go out to the external projects.
Thank you.
The last question, I think.
It's not a specific question, but it's kind of a comment in response to the last question. Yeah, I think you raised a very important point about patterns, because if you look at patterns are reusable solutions to recurrent problems. Yeah. So there is an aspect of, are they aware of their recurring problems, and how do we as researchers help identify them and bring it back? So I think there will be evolution of these. So do we see it enough? I think at this point we're seeing some of the very easy ones like communication and all of that. But once we resolve them, hopefully we'll be able to get to where the rubber hits the road ones later. And I think from that perspective, I agree with there's a point to start, and then but there's also evolution that we'll see.
That's actually what we are doing now. So we are not finished the complete version of this pattern. So through the communication, we can keep adding more patterns and adding details for implementing these patterns.
Yeah, sorry, we have more questions, but we need to go to the next talk. We have another session. Yeah. So our next speaker is this one. So welcome. Our next speaker is Rehali Rabari. Sorry. So she's an assistant professor from McGill University School of Computer Science, and she's also a core faculty member of MILA and a Canada CFAR AI chair. And before joining McGill, she was a postdoc fellow at the School of Computer Science at Carnegie Mellon University as well. So her interest of research is at the intersection of network science, data mining, and machine learning, with a focus on analyzing real-world interconnected data and social group. Thank you. Rahani, you can start.
Okay. Thank you for the introduction. Very happy to be here. I'm presenting some of the works that we do in my lab. I hope that it's the talk is a little bit different from the first two talks because I come from a different background. It's my first time at a software engineering conference. But I'll talk about applications of AI. So hopefully that part would overlap and there are some interests. So I want to start with emphasizing on the fact that the world around us is interconnected. So wherever you look at, you see these interactions, connections, relationships between different things. And a lot of times looking at these interactions or relations is the key to understand the problem or the data. And because of that, we have researchers from a lot of different fields that look into understanding this interconnected data. In physics, we have complex people that research on complex systems. In sociology, we have people that look into social network analysis.
A lot of the theory comes from graph theory in mathematics. We have graph mining community in data mining. In machine learning, in the more classical works are on relational learning. More recently, you have graph neural networks and graph representation learning that is becoming a really hot topic in machine learning. And sometimes people try to bring all of these researchers under the umbrella of network science. So you can actually get a PhD in network science from some of the universities. And it's related to all these different concepts or algorithms or methods that come from these different fields. And I want to start with a definition of what is a complex system. From the definition is from physics, but it's not specific to physics. It applies to anywhere that we have a complex system. What we define as a complex system is a system that has a lot of different parts that are interconnected. The connections or interactions between these parts are usually time dependent. You cannot explain the behavior of a system as an aggregation of behavior of the individual parts. And you need to look at it as a whole to be able to understand new things or get new insights. And another thing that is often present is the interplay between the state of the parts and the interactions. So what is the state of the parts or characteristics of them impacts the structure or the connections and vice versa. And we'll see some examples in the next slide. And then I want to move to sociology, which is one of the fields that is actually defined around needing to look at the system as a whole. So we have two of the founders of the field of sociology, and from the early on, when the field was defined, there was this emphasis on if you want to understand these systems, the society, you need to look into how individuals interact with each other, how the society is involved, and this evolution and dynamic impacts our lives. So we need to look at the relationships between the individuals instead of focusing on the characteristics of the different individuals. This is one historic example, which is one of the first places that maybe social networks were used to explain a real problem. So we had this a school, and you had more than an average or expected runaways from it. So what the school did to understand or explain why this is happening was hiring Moreno, which was a sociologist, to explain why there is a lot of runaways from the school. So what did Moreno do was interviewing all of the individuals, asking about how they feel towards each other, to map out the channel of influence, social influence, and how people would impact each other's decision. And you can see the first drawings of a social network as these sociograms in his book. And he was able to explain the reason for the runaways is because of how people are positioned in the social networks. And if we fast forward to today, the problems are similar. We still want to explain pandemics of misinformation, fake news, extremism, and also sometimes an actual pathogen like COVID. If you want to explain it, what we need to do is similar. We need to model the channels of social influence or channels that these things could propagate over or spread over. And when we have this model, we can infer how different individuals would behave within the model based on how they are positioned in their network. The difference is that there are a lot of differences, of course, and one of the main ones is that now we have really larger scale data. So these are some statistics from a recent survey, and you can see if you want to model this data, it's not a school with a few hundred students. You would face a 4.6 billion data points for that, which are the social media users. If you look into North America, 82% of people in North America are using some sort of social media. 93% of people that use internet are in some sort of social media. So what it means is that a lot of our interactions in the society is moving to these online platforms. And in order to understand how the society is changing or evolving, it's important to be able to model and analyze this data. On the plus side, we don't need to go and do these surveys with the individuals. We have a lot of digital traces that we can use to get the data. So the data is bigger, but access to it is easier. How do we model this interconnected data? Is usually with a graph. So you have a graph of individuals or vertices or nodes, and the connections between them, we model them as edges, links, or links, so different terminology based on the context. But what it says is simply a simple model for how different individuals are related or interacting. This is often complementary to another way of data representation, which is more common in ML. That is these feature vectors that explain the features or characteristics or a state of the parts or individual data points. So in most cases, we have both of these together. Each of these feature vectors explain properties of a single node, and then the relationship between them would show their interactions or relationships. And there is often an interplay between them. So these two change and evolve together. In sociology, there is these two principles that could explain this change, which are called social selection and social influence. And to give you one example, which is a little bit more tangible, if you look into movies that you like to watch, these and consider them as the features or the features of you, which are your movie liking. These are impacted by movies that your friends like because they would recommend them to you. At the same time, so this would be social influence. At the same time, you're more likely to befriend people that have the same taste in movies as you. So that would be the social selection. And these are not specific to social graphs. These are common underlying, you can call them inductive biases, you can call them assumptions that hold in a lot of different graphs that come from different domains. So this type of data, we started with physics and sociology, but it's present in all natural and applied sciences. In natural sciences, you can look into the bonds between atoms, the interactions between proteins. You can even look into how galaxies are related to each other. In applied sciences, network science has been used to discover a lot of interesting insights. There are a few examples here. For example, how multiple genes are impacting the same disease, how you can uncover criminal activity by mapping the criminal networks, how trading networks are behaving and how that relates to economics, and maybe on a lighter side, you can even understand how to design interesting recipes and pair different ingredients by looking at how different ingredients share compounds. So a lot of different fields, a lot of different applications, but the core is similar. And this gives us a timeline of people that work on related algorithms or models. So we started with the sociogram in 1930s by Moreno, but you can see the timeline of how things are evolving. So with the start, we had a lot of people in sociology, then more from CS and physics. What we see on the plot are the more prominent works. Around 1999, there were two prominent papers that showed the scale-free and power law properties of these graphs, specifically how web pages link to each other, and also how ISPs are routing packages between each other. So the two papers studied the two different networks, showed that if you look at the degree distribution in these graphs has a special property, and this ignited a lot of interest in understanding and analyzing real-world networks, and basically brought in a lot more people from CS. And now these days it's very common, or maybe the most of the works on graph algorithms are coming from the deep learning and machine learning community. So this explains what we do in my group. I have a lot of amazing students that work on different topics. Some of them are more on the theory side, algorithm design, model design. Some of them are more on the applied side, and a lot of them in between. So we work on, given a temporal graph, how can you detect change points where the behavior of the graph changes? How can we do anomaly detection related to that? A lot of times with your data, you don't have labeled data available. So in these regimes, how can we learn? So active learning for graphs, working with weak or noisy labels, and also some classical works on link prediction, node classification for static and temporal graphs. On the application side, which I want to overview quickly, we work on maybe two main applications and one is smaller. And these are in collaboration with people from the related fields. So with people from criminology, we are working to see how these techniques could be applied to counter human trafficking happening in online escort markets. In the second project with people from political science, we are working on understanding polarization on social media and how that impacts politics and major elections. And then in the last one, I have a few students that work and are working on modeling COVID pandemic over contact graphs, or how to consider the population flows between different countries, cities when doing epidemic modeling for better or more accurate models. So I don't think that I have time to go to the three. Maybe we can do a poll, any of these three applications you want to know, and I can go to that one. Which one? The second one? Second one, okay. So how social media and politics intersect? We know that from a lot of studies after the fact often, that social media activity seems to be impacting major elections. So if you look at bot activity in the Brexit, we had content generated by the bots 4 times for the Leave campaign compared to the Remain campaign. So this correlates with the result of the election. If you look at the US election, there were a lot of after the fact, it was clear that there was a troll agency in Russia that was active in the discussions, posing as both Democrats and Republicans, and it seems like, so if you look at this graph, for example, this is the map of discussions around the US election, and the orange ones are confirmed trolls, and you can see they are in both sides, and what they are trying to do, it seems to be fostering division between the people in the two parties. And it seems what they do for that is putting out misinformation and fake news. So because of that, there are a lot of researchers that work on user classification for bot and troll detection, as well as content classification for detecting misinformation, fake news, or rumors. We also did some works here showing that, for example, in this work, that a lot of the state of the art won't outperform a simple language model. Some of them even have a language model as their core. But if the fake news is something that is in distribution, meaning that you already know this is fake news, it's a very easy task. So you just need a language model. But if it's out of distribution, something that is not verified yet as fake news or not, this is very hard to detect. So most of the methods would fail in that system. And then going back to what is the strategy that these trolls or misinformation is trying to do, is some kind of information operation. So they often coming from a farm, troll farm, or a coordinated unit, and what they want to do is to inject division in the network. So this seems to be a strategy that was confirmed in multiple different works. So as a follow-up, we were interested to see, can we detect these coordinated groups directly, and also can we measure polarization or division through the network and what is impacting it? So taking a step back, trying to look into the system as a whole instead of trying to classify the different users or contents one by one. For the coordinated inauthentic activity detection, what we did was looking at the Twitter users that are, so this is a study around 2019 Canadian election. We looked at how people follow each other and the content that they post. So followership would be these interactions between them. What they post would be these feature matrix of individual characteristics. And then we wanted to find blocks that are densely, that are jointly dense between these two matrices. What it means is that these are group of users that amplify each other's voice by following each other. At the same time, the content that they generate seems to be coordinated. So they generate the similar content over time. And what we figured is that there are some suspicious groups. A lot of them are also seem to be related to MAGA movement in the US, which was an interesting finding. It was covered by some news outlets, including CBC, but we didn't go too much into the conclusion because it's not something that a CS person should do. So next, what we did was teaming up with people from political science. So now we have a bigger group with more people involved that bring that expertise that we lack as people from computer science. And what we tried to do next was try to see if we can monitor division directly or polarization of the graph or discussions that are happening. So basically, again, the source of data is Twitter. We have graphs of different relations based on how people are interacting with each other. We also have the text of the tweet. And at the end, what we want to do is get these user embeddings and see between the users that are from Republicans and Democrats, two parties, how divided are they and how that changes over time. Because polarization, you can define it as, are you using the same language? Are you able to talk with each other? Or are you really discussing different topics or in a different way? So the result of this was presented in political science conferences, the top conference in political science last year and this year. And so this involves a lot of different components. One small component of it is, for example, user classification, simply knowing who is left and who is right. So for that, for example, this is one paper that we recently submitted, which just looks at, sorry, it's a little bit blurry. It just looks at different methods for party affiliation detection. What signals do you want to use based on the activity, based on the text, and how is the accuracy of them and how they rank compared to each other. So maybe an interesting point here is that even if you don't declare your party affiliation on Twitter or social media, not only party affiliation, a lot of other user characteristics, these could be inferred based on who you are interacting with. So we have these algorithms that are propagating this information over the graph, and we are able to infer a lot of information about the users based on how they interact with. I think I'm over time, right? I don't want to. How much time do I have?
I think we are running a little bit late.
Yeah, so I think I can wrap up and then yeah. Right. So maybe I'll just go over this and then wrap it up. So you can also look into polarization in spatial and temporal patterns of it. So here we are looking at different states in the US and the polarization of the content and comparing it with the epidemic data. And one interesting thing that we found is that, for example, the states that if you look at the Twitter discussions from that state on Twitter, these are more polarized. They have also, specifically on vaccine-related topics, they also have a lower vaccination rate. So the correlation that we found is minus 0.64, which is a very strong correlation. We can also rank the states in different topics based on how polarized the discussion are in those states. And you can, one interesting pattern is that if you look at vaccine discussions, the red states and blue states, rank them by polarization, they are very separate. So blue states not polarized, red states are very polarized. Whereas if you look at the lockdown, it's more mixed. So even blue states have issues with the lockdown policies. And you can see that these discussions are more polarized. You can also look at the temporal patterns and see what could have impacted it. Again, one interesting thing that we found is that you see a lot of peaks in the polarization over time after increasing conspiracy theory related content. So these are still ongoing research. We're doing a lot of further analysis and including other data sets. So for example, this is on the US. We are now trying to extend the study on Canadian data. But I think this gives a good overview of what we do in that project. And yeah, I hope I had more time, but very happy to be here and present some of our works.
We're gonna take one more questions.
So first, thank you so much for coming and sharing this presentation. I'll try to stay as concise as possible.
Try to stay as concise as possible. My question. I really admire your approach at McGill. I'm currently in the UAV's class of applied machine learning. You probably know it. And I feel like you, McGill, encourage cross. So you mentioned graph theories and graph normals and whatever, and it's in politics, it's in genomics, it's in whatever. And I feel like here with technique, thank God we have Professor come to organize events like this to share. But so I'm from a personal perspective, I started in applied maths, and they're gonna ask me. So I quit that program because I was asked, you know, can you prove these graph theorems, these theoretical theorems? We have a professor here of graph theory, and it wasn't for me. I never did prove, to be honest, personally, even though I did my undergrad here. So I came knocking on the computer engineering door, and now they're not, they don't have doubts about how can if I can prove or not the graphs, but can I code what I have to code? And I'm stuck in the middle, and maybe I'm not in the right school. But how can we encourage that era for the technique? Because many students are international students, even though might look like an international student. I'm not. I'm not an international student, and I had the possibility to say, I'm not gonna pursue research with you, and I'm aware that you're gonna cut my funding. But many international students don't have that opportunity, and they might be miserable for some. They don't get the chance to switch program like I did, like I'm intending to. Anyways, you probably understand that. I would like to have your perspective on this.
I think we are a research community, so all of the different things are important. We were talking about how software engineering is important for AI, how these are different levels and how they work with each other, theory and application. Also, they come hands in hand. So we can't do everything at once. So I think it's important that people work on theory as well and on application. I don't think that there should be a switch between the two. And I would say for how international students should navigate if the first entry point is not their best match. It's a little bit beyond what we have here, but I would invite you to apply to the Canadian AI Graduate Symposium. I'm trying to organize it for this year, and we will have a lot of mentorship sessions for graduate students on how to do research, how to navigate these difficult situations, how to apply for industry and academic jobs. So the page is not up yet, it's just starting, but if anyone thinks that they could benefit from that, I would strongly encourage you to apply to that symposium, and then we have a lot of mentorship sessions and talks for that. Yeah.
But maybe if I can rephrase the question, so more on a personal level, I mean, we had the previous presenter come all the way from Australia here, and I don't know by what means, but she's being asked tough questions, and it's almost like an interrogatory, and it's how is that even how can we even enjoy doing this? And I mean, I'm talking about you know, some are established professors from Carnegie Mellon, but some are not always, and they're going to conferences, and it's not always easy. And for like from a personal perspective, I know you're established professor, but has it always been easy? Thank you.
If I can just, so that we will, so we will have a panel on education later today. I would welcome you to ask your questions about education at that moment. So thank you. It's a very good question, but please reserve it and save it for later. I think it will be very important for our education. So if you can thank our people.
So we will have a coffee break, a breakfast and a coffee. That's the opposite.
Let's come back in 10 minutes. Yeah, so you can go ahead across the hall, get your breakfast, your coffee. Let's come back in 10 minutes.
So, I think, is the entry much or I can just use the one, it's more, reading it directly as well. Is that gonna be okay? You have. Okay, yes. We're getting.
Yeah, I don't
No, that's too many cards, I guess. Very, very good. Very good.
Hey, Thais. Hey. So we'll do adjustment after the panel. Because when the panel is starting, that's we don't need this.
Oh, OK。
This panel is
看直播的人觉得看不清 PPT。
哦，我这地方
那个。
Pour naviguer, je sais que vous avez des c'est inévitable. Il faut juste naviguer pour les
I think for the next hour there. Actually,
So I think that, yes, I would. When I react is the right perception, right? That is to understand how the concept connect to each other and also concepts. You're talking in a very specific way.
Okay.
But there's a lot.
I don't think it would be.
The data aspect. That's data I would. That I would agree, whether I will. I don't know whether that will change the outcome. Because especially if we're looking at ensemble say, right, which one we're looking from, and whether the ensemble are looking from has an impact.
Automatically, it's with arrows, not again.
Within the components or within the system, again, there might be changes within the system. So those are exactly my point. We should be asking those questions rather than just one.
Because just the data, I agree a lot more there. Next side, like we see. Yeah, we see everything. But should we say? I don't have something justice. I don't think we can do much better. We can try. Maybe you look at how that will quite c'est juste au premier, on est bien dans les bonnes. Parce qu'elle n'a pas la partie du temps. C'est mieux que ouais, je vais laisser. Il ne veut pas y avoir. Yes, so we are lunch, right? Normally, one you manage politically. Yes, you can answer first, but I think two questions are we need a more diverse. I actually had a question for her, but yeah, I think we need to encourage people to raise their hands because he was the only one with his hand up, so he could ask the question. But I think more people, if we need a more diverse crowd, we can't always have the same questions. It's not a. That it was a good idea. Directly. I think that's where the question should be asked. But it's just a extreme point is not. Yeah, well, I think particularly the second speaker, the text was very small. I got comments from people in the room that they couldn't see it. They asked me if we could. And also they should put the microphone at the top. Yes, I think we would instruct them. But I don't think we can zoom. Like use more real estate. I think it's the maximum. If there's no. The thing with the stream is if they are not sharing the slide or no. Yeah, the quality is not the quality. That's yeah. I don't think we can do better with the camera. We can put a bit closer, but I mean, if we want to change the setup, we just get people to connect to the Zoom. Yes. Every stick. Yeah, then it takes a It's a bit of extra time. I think. Well, then when they're preparing on their computer, we could do that. We could. Like you can have one of the volunteers. That when people are preparing on their computer, you can set them up on Zoom. I think that's simplified. How do the heck before now? Well, you can ask them for the business. Maybe nothing false. Like when something goes on days, you can ask them. So right now we have a panel. Yeah, right. That's the leader. So when the panel happens, I'll find a few volunteers. You can try to test it with meter. If it works, maybe that. So I mean, you have the link for the Zoom. Yes. Then you like oh, that's true. They can just click on that. Okay, even better. Okay, I will inform that. I think it's the outsourcing the child staff that
the source.
Yes, but he will be sitting there the entire time. I think you can see, I think, who is the source. So the problem will be. Yeah, so Armstrong will need to put a spotlight on the correct speaker.
Yeah. So don't show like something, short slide on just a little bit, maybe. Those slides here. No, I think it's good type of slides.
Yes. Yeah. Yes. Oh, yeah, yeah.
Do you want to fly this on slide, or it's okay. It's on there. That's fine. Or you want me to just connect to some touch and share my screen stuff? It's not a whole screen. Connecting to the top. Okay.
We have all the panelists on the front. Sure, everyone. Yeah. Sit on next.
Hello.
Yeah, I hope
Maybe
maximize it, but they here tomorrow as well.
tomorrow morning I'm not there. I need to leave some. Yeah, yeah.
No micro. I think someone needs to get maybe a microphone. You use this.
Yeah, I did my. Oh. What exclusive? Oh, so it's working.
You guys want to start? I think we should try. Is this on?
Well,
Is it on or not?
We just increase this.
We have like more microphones or
Just use this
I
one.
think this should be very they don't they can't hear. And this was up. We haven't used it yet. You test it.
Test it. Test it. It's okay. It's working. This one.
We tested normally.
But
I think it's working. It's working. This is working.
Okay, okay. People should be able to. I don't hear any change, no?
the echo you
The other side can hear. You cannot. You don't need to hear.
But in the room, if you go on the back, you can. Oh, that's the point, right? There are people in the room. This is good for streaming, maybe.
Okay, then in this case, we need to hand this microphone.
We have two, right?
We have two. Yeah, we have two. Otherwise, it's
So we use it.
You use this microphone.
Yeah.
every two show.
Yeah, I think we can share this one and then
Yes. I think our mic and they have.
there should be a button.
Okay, so welcome back everyone. So we'll have our panel discussion. We have our experts. John just gave a keynote in our section. So I want to ease into this panel discussion by discussing more on the challenges we didn't discuss in the last section, right? So maybe you will start from our AI expert. So basically, what do you think is the biggest challenge, or what do you think is the biggest problem that people need to solve in sustainable, scalable, and responsible AI? Maybe starting from the AI experts.
I can use this one. I think one of the things that we see a lot in machine learning and AI as a challenge is performance in real world. So a lot of different things come in. The fact that the tool that you have developed could have consequences that you haven't thought about it. So that's one thing that comes to play with the researchers that work on bias, responsible AI, interpretability. So all of those things, those are a big challenge. Understanding the potential harms and usages of something that you develop. Another thing on a more technical side is generalization, which is a big challenge. So a lot of the tools or techniques that we have right now works well when the distribution of the data that you apply the model to is similar to what the model has seen in the training. And this doesn't hold in a lot of real world application. The world is evolving, the data is changing, and a lot of times the sample that you use to learn from is limited. It doesn't capture the possibilities that the model could be applied to. So I would say generalization, as well as on the performance side, as well as other important things on when you apply an ML model.
So I think I will address the similar concern, but from a systems perspective. We have not seen or studied yet actual AI ML systems that are in production or who we've seen in action. And that, I think, limits our how we position our research questions, how we position the challenges. we need to really understand how they perform and how they are produced. So production-ready AI ML systems, we don't know how they behave to be able to bring back some of the techniques into our research questions and labs and to ask the right questions. And I think I will repeat the generalizability question from that perspective. This is how we develop. Like when we're talking about information systems, we talk about brokers, we talk about distributed patterns, we talk about publisher subscribers. Everybody understands because we know what kind of environments they are within. And I don't think we have enough examples of these systems to be able to get to that level of specificity. And that results in we don't know what we don't know syndrome. And I think that also is a roadblock in terms of how we will sustain these kinds of systems in the future.
For me, I think sustainability is relevant to, if you consider the principles, it's relevant to environmental, social well-being, and it is part of the principle, like one of the principles in our framework. And I think companies, they already realize like responsible AI is a technical issue, but it's not only about technical issue, it's also a governance issue. So in our work, we are trying to integrate our solutions to like ESG reporting. So how can we make it useful to board members, to executive team to monitor the ESG metrics, including responsible AI metrics. And for scalability AI, I think in our current research team in National AI Center, we talk about risk assessment. A risk assessment is not only like static one-stop risk assessment. It's like they need continuous risk assessment, which we would like to see like embed monitorability for governance to cover this continuous risk assessment. So that's my answer.
Yeah, so thank you. I actually agree with most of the points that have already been raised. I think the current solutions generalization problem, it's a big issue, right? If we want to deploy this model in such a critical system, we need to be able to provide guarantee on their behavior when they will be deployed out of the environment in which they have been trained, out of the distribution from which this model were trained, right? So we really need to make progress on this. And I think another big issue related to sustainability is the fact that the current trend that we're doing with bigger is better, right? We're building large and large model. I think it's a big problem because you just look at the cost that it's really required nowadays to train them. It's just not sustainable, right? So we need, I think this is maybe something that will go back to the machine learning community, the core machine learning community. We need better learning mechanism, right? We need to be able to learn from maybe fewer data sets or in a more efficient way, right? I think we really need to be putting effort to try to understand. Like, I think if you look at the human brain, and that's why I'm excited to see this neuro AI still picking up back, right? Because I think to build efficient technique, we really need to try to understand how we learn so well with so few energy or so few resources, right? So they need to be effort to build better learning practices. But then on the software engineering perspective, since the large models are already providing interesting results and they are being engineers, I think we need to build techniques to optimize the deployment of this, right? To make sure we can efficiently deploy them and reap the resources instead of requiring to train for hours and sort of things. So we need a lot of engineering effort on that side. And going back to responsible AI issues, I think everyone agreed that bias, transparency, all are very valid issues. But currently we only have, how can I say, we have guidelines and so on, but to really be able to enforce this, we need engineering tools allowing to be able to observe these property in systems, right? To monitor these properties over time, right? To be able to track, test for this. So I think on those both fronts, at least for me, I think those are priority. By the time we provide better learning mechanism, but at least to cope with the current one, we need that. So I don't know if my other co-panelists want to react on that.
I guess we have some questions from the audience. So if you want to jump into the discussion, please.
Should I talk from here or?
You can use my.
Hi, can you hear me?
So, great talks, everyone, and I really enjoyed it. I'm a professor at the University of Calgary, but I'm also coming from an industry background. I was a data scientist at the Bank of Canada before I joined the University of Calgary. Even last year, I was managing a team at the Government of Canada on data science. And a couple of the things that I saw over there, and they resonate well with what Bruce mentioned, that we have a lot of guidance on how to use responsible AI engineering. But when we try to apply this within the government or within the different organizations, we found that the tool support is lacking over there. And then we can talk about guidelines, but the moment we try to implement those into policies or something, we need tools. And there is not much guidance on how to do the tools. Also, the learning side, there is not much information on how to use the tools. So probably those are a couple of areas we can look at so that we can learn from how we can apply those tools. That will also inform us about the foundations that we're building, and we can work on them. So that's my concept. So thank you.
Just wanna comment to that? Or?
I do agree, and I think another aspect of the tools is not knowing how to use the tools, and there's so many of them coming out with little variations, and sometimes they interoperate with each other, sometimes they don't interoperate with each other. I think another area of maturity that we need to thrive forward is now it's secondhand to all of us. When we have any spreadsheet or word processors, we're able to pick up the tools. What does that translate in the AI world? What are the classes of tools, and what does it mean to pick up these tools easily, and who are their audiences? I think is not there yet. I agree. Part of it is also how can we automate some of the things that we're talking about? Like, can we automate? I was just talking during the break, the mismatches that happen through these different life cycles, and there are projects going on, but I think the automation will still lag behind a couple more years. But that's a very good point. I think we do observe that a lot as well.
Yeah, I agree. And recently we did a mapping study on software tools for responsible AI. And if you look at the major big technology companies, I think still their focus is on like the model fairness, the privacy, data privacy, or security and explainability, but very few tools on or guidelines on contestability, transparency, some like meta governance principles. And the other finding from that mapping study is like many people talk about their tools is for risk assessment, but it's just like a list of questions for a few principles. But I think stakeholders, they need the specific group of questions, or they need to understand. For example, the board members, it might have some high-level questions, but they don't know who, what they should ask and who they should ask for the operational level people, and how we can divide this question to lower level questions than to answer the high-level questions.
Right, so I think part of what we've discussed a lot is you were just mentioning this idea that, well, we need to optimize this model, we need to optimize the system so that we can kind of get over the stuff in the lab problem, right? We've seen an industry that, you know, we can come up with these AI models, these ideas, these tools, but then because we haven't really thought of the engineering or the DevOps side of it, you know, the end-to-end bit, they kind of get stuck in the lab. It's hard to get out of it. And you were talking about, well, we don't have a lot of observable systems, right? There aren't a lot of places we can go to. Do you sort of feel that's just because you need to be like a massive company with a ton of funding to just basically throw tons of money at this and kind of push something out the door, making sort of AI for other industries sort of infeasible just because there isn't the tooling around it that we were just discussing? So I'm curious what your viewpoints are on how we make AI accessible from an engineering perspective to companies and researchers who don't have massive gauntlets, you know, trying to push that.
Maybe I jump on this one, right? Because it's engineering thing and I'm very interested in. I think
initiatives like what Hugging Face is doing, right? And these other model hubs, it's something that can actually help develop the AI supply chain, right? So there are a lot of companies sharing pre-trained models, right? Maybe to ease the adoption curve for other more modest companies who don't have the resources to pre-train those models. But I think the pitfalls is after those models being shared, right? How do you adopt those models? There are different mechanisms, right, that people leverage, like you can transfer, distill, and you can quantize, adapt. So we have more and more products being developed to ease the adoptions. But I just feel like currently it's still in a kind of ad hoc phase, right? We need sound engineering principle, right? We need to look at it as we did with how the open source movement transforms software development, right? We start having all those packages around, and then we have packaging repository, and people could actually pull out, those packages and try to build their system by composing those packaging engineering. I think we can do the same with these model hubs that is picking up. But then we need, I think self-engineering researcher needs to step in, ensure that vulnerabilities are not sneaking into those things, right? That people actually adopt that in an efficient way, and so on. So I think that could have, in my opinion, leverage this the cost of adoption. I don't know how other
I just wanted to second and agree with what you just said, that there is some concerns that these AI models are only can be come into realization in big companies with a lot of resources, but AI community is very pro open source, and a lot of the questions that they try to tackle is cannot just be answered by scaling up the models and making them more complex and more harder to train and learn. And Hugging Face that you mentioned, this is, for example, one example. So a lot of the models that you see coming out from, for example, OpenAI, you see equivalent of it accessible, posted in few days on Hugging Face. So I think if you haven't seen it, it's a very good resource to look up. And then their goal is to make a model repository for ML. A lot of these state-of-the-art models you can easily access them there.
I think you brought up an important point with the organizations who have resources, but I want to also augment it with what are the AI problems that the existing organizations are solving. I mean, I don't want to diminish that, but ad clicks and movie recommendations, even healthcare analytics, they are more, the data is more available, that's more straightforward, and maybe they're able to scale because it's an AI problem that builds a little delta over the big data problem. I think what we're really looking into is, are we able to solve more complex decision-making problems with AI systems? There's the modeling challenge as well as the production challenge. And I think I'm hoping, and these kinds of initiatives will also push to more democratization, which means small companies could play as well as larger companies. But I want to go back to a point that Forza made over here, infrastructure there, and how you'll be able to scale these with the learning that is involved in to make that reality, that's probably where the challenges will be, where resources will be needed.
Yes, I have a concern regarding the types of applications we apply to AI tools. And I'm wondering regarding the risk level, should we put some weight on the types of applications we're using AI? So, for example, if you have a high risk level, should it be less?
Yeah, one of our pattern is called AI suitability analysis, and also I shared the figure about the AI value chain, the potential ethical issues for each step. I think the very beginning stage. So when the ethics committee they look at the proposal, maybe some proposals will be rejected because of the domains of application type, or because of the high risk. So it depends on like what kind of AI technology you want to use in a software system. And in our organization, I think we had a project about military application. So we had a long discussion about that application, then we rejected. So we don't. So I think just want to use this example to show we do have a different category for application type, and we want to consider it in our risk assessment to make it like having extension points can be extended or adapted for different types of application or culture or country regions.
So in our team, one of the things that we enforce, and I've learned this from my data science colleagues, to be completely honest, is the first question is, do you have an AI problem, right? Because there's a lot of just throwing the AI there because it's cool. But then the next question is, should this problem be solved with AI, even if it can be solved with AI? I don't know whether there's a solution to this because that's people do things. I don't know whether regulation is a solution. I think it goes back to not just responsible AI, responsible engineering, right? There's that responsible engineering aspect, which should be part of our conversations regardless of the technology. So I think that's where the answer to that question is in my perspective.
I certainly second that, right? Because I think one prime principle when you engineer a system is protect the public, the users, right? So there need to be a risk assessment. Depending on the requirement of the solution you're building, there need to be an assessment whether or not the AI component, given what is known about its reliability, would be a good fit for the system, right? But now, on the caveat I want to bring with this is, I think in my opinion, usually when we build a system, it's more like a system of system type of thing. So you can have an imperfect component, but if you understand the behavior of this component and you manage the uncertainty, you can actually wrap around, right? So you can build some control around the component. And as a result, you can have a resulting system that's maybe achieve the level of safety that is required. So I wouldn't say it's a definite no, but I think it needs this assessment and this very precise engineering around to make sure that the resulting product is really what is expected by the requirement.
Hi, this is a food man. I'm a faculty at Western Ontario over there and thanks for coming. So the thing that I was thinking about that when we were talking about the is around, we haven't been talking about these two specific concepts that we certainly talk about in software engineering domain is about software verification and software certifications that are still in the very early stages in this area of AI. And that's where I think between the certification and verification part of AI systems will allow us to deploy these systems in the areas that we mentioned, the safety critical domains. So verification and certification is key. It's a defense act. You cannot do it like we are doing a lot of research. Certainly, there's a lot of funding coming in to develop AI systems for defense, and we apply them. We probably not that. I think that's where I'd love to hear what's your take on the verification and the
Maybe I start. I fully agree, right? I think we need to test, verify, and validate those AI-based components, right? Currently, there's a lot of effort in the community. I think some of people in the audience have been contributing a lot of tools to help in this testing, verification, and validation process, but it's still in the early phase, right? There's still a lot we don't know to do about this component, right? Depending on different learning paradigm, we're still struggling to deal with them, right? But I think as we get to the point that we start having tools on which we can rely to get some reliable signal about the quality of the information produced by this component, then we'll be able to start doing this requirement risk assessment that are necessary to start integrating and deploying those solutions in a safety critical system. That's why I think more research is needed, right? And so it's a call to everyone in the room. I think we need to be working on this.
So from a verification and certification perspective, I think one of the things that existing of AI components are bringing to the system is expectation change from the response. The response is correct 100% of the time to an expectation. The response may be incorrect. And what is my profile of that system? And then if I put it into a defense context, well, maybe I use it when I know that it's correct, but then there's maybe another aspect of the system that takes over, I think it's going to change our approach to defense system or safety critical system development. That doesn't mean sometimes the decision will be not use AI, but sometimes the decision will be heterogeneous systems that have different shadow components that take over and whatnot. I don't think we're thinking in terms of system development as a heterogeneous approach perspective yet, and I think there's probably work to be done there.
I have a follow-up question on the discussion. So we talk a lot about the all these characteristics of AI. Right? So we've been doing engineering for so many decades, right? And the sustainability, responsibility, scalability is always the thing we're aiming for, right? For all the engineering products. Right? So what do you think these days make AI so special that everyone is, starting to look at this characteristic? Why we cannot just learn or borrow some ideas and existing solutions from other engineering fields, especially software engineering, into the AI domain? What do you think is stopping us from doing it? Maybe we'll start from tools.
Oh, okay. Well, I think we should be, right? We should be we should be reusing techniques that works, right? Things that we already know to do, we don't need to reinvent them, right? But I think with AI, there is a caveat. Like if we go back to bias and things like that, I think automations amplify things, right? In traditional software engineering, we didn't have these strong data dependencies, right? And because of that, we had issue in the system, but those issues were not, maybe my colleague will correct, as systematic, as amplified, at scale, as issue that we have when we deal with an AI-based system. If they are biasing the data, and since we're automating things and we have a repeating process that is affecting billions of people, then the impact is probably much more amplified. I think that's what justifies, in my opinion, this focus on this specific property now that AI is being deployed, right? But having said that, I think if the processes, practices, and tools that we have been developed, established for 50+ years, we should adopt them. But I also feel that we need to adapt some of those, right? Because I think the data dependency the nature of the AI component is a bit different, right? Things are not always deterministic, right? We have a level of uncertainty to deal with, and since it's not stationary, even this uncertainty, it's uncertain somehow. Right? So we need to probably adapt some of our techniques.
Yeah, I agree with both. I think in our work, we patented from traditional software engineering approach, and we just had discussion whether fairness should be a quality attribute for AI system architecture. So we do think we have thought about like how to capture the principles as software qualities, how to deal with trade-offs using patterns, what are the pros and cons, like I said. But I think we need more thinking maybe on how to measure the risk, different types of risk in terms of the principles, how to reuse some of the measurement methods from software engineering area. But if you consider the principles, I think explainability is a new quality attribute for AI systems. But I think still we talk more about the model explainability, but we could also think about data provenance, think about the software traceability to make more meaningful explanation for different types of stakeholders in the AI system design.
I don't know the current or previous mechanism from software engineering and why they might not be applied here. So I'm making some assumptions. But one of the reasons that new methods might be needed is that the current AI ML systems have capabilities that we didn't have before. So they are extending to a lot of other applications. They are getting a state of the art, like human level performance in a lot of different tasks. So we weren't applying them like this before. And I also want to second that they are very dependent on the data and having new functionalities, new models. So I would imagine a lot of the things that we had before are not designed for assuming like the new functionality. And maybe I'll go a little bit back to using AI or not using AI for different applications based on the application. I think the question is how, because there is a lot of things to learn from data. We have data in a lot of different applications. And whenever we have large amount of data, it's not possible to look at it manually. So you always get advantage by having access to that data and looking at the patterns in the data. So I think some of it would be helpful to think of an AI system as a pattern discovery or a function mapping system to demystify it, what it's actually doing. And then when we are using it, don't think of it as an exact solution for a problem. It's one component. So going back to having a heterogeneous system, it's one component, one tool that you can have for a system. It can substitute a lot of other things that are happening, but I think the key is how to use them based on the application that we have. So whenever we have data, they could be helpful, but how? It's that's the question that needs to be.
And I think we need to probably be a little honest with ourselves. It's not that existing techniques is not being used. There's a huge funding opportunity that comes with what you can accomplish. And there are a lot of new things, especially like we said, like, can we really change the ML techniques so we get the added mileage? Can we design them so that they're not as resource dependent? I mean, we've talked about a little bit of aspects of this. So I think we are getting to the areas where there are new techniques needed. I think it's just we need to be a little bit more upfront. Here are existing techniques that I think are helpful. Here's what I'm challenged. And I think that will also change the confusion around.
Maybe.
There is a question.
So I have a question about the issue, online issues that are like we don't know about using software and just the software companies, but we know that if you're going to use a large scale AI in production, those issues and problems can show up. And on the other side, we know that all the companies in different stages of AI, they have like research community that they are like new. How to apply, for example, AI in their production. But for example, for larger scale AI, they still have fear because of the cost and because also all the like problems to use this model in the where that they face their customers and also the region. So my question is like how we can attract the trust of companies to really use the AI in the production, mostly not AI, so like you can find this issue online.
I think the afternoon session will touch upon this more in depth, but I think we're underestimating the skill set need that goes into that. I think companies are not just shy away from it, they are struggling in terms of hiring the talent that makes this happen. So I think it's here, in my opinion. And don't underestimate that challenge. You will only know this if you're trying to hire the next generation, which we have open positions if you're US citizens. So that is a huge challenge, and I think it's an even more of a challenge in the AI domain. So I think there's that multiple levels of dependencies. There's technology, there's acceptance, there's policy, there's responsible AI aspects, but do we have the right skill set to make it happen, even if all the technologies are there and everybody is competing for the same skills? I think that's part of, we shouldn't overlook that aspect.
I just want to maybe compliment a bit on that. I totally agree, right? I think one part of the problem also is that there are not clear established practices, right, that they can follow for adopting these techniques, which is why I think research in this space is really needed. And works that try to establish recurrent solution like design patterns are really needed, right? Because I think if we model, we design specified patterns, we establish best validated practices, we document them, and then we train, so availability of talent, then we'll be on the path of like speeding the adoption, right? So I think all these components, in my opinion, are critical. We're, in my opinion, in the early phase of this process, and we need more effort, I think, in this direction.
So what I wanted to add is that what you mentioned is a challenge, but to me, another side of it is not having everyone jumping to AI solution for a company and using that, assuming that, not considering all the consequences. I feel like that's a bigger danger than people not using it. And we have a lot of examples, like horror stories of how things could go wrong when you try to automate something that shouldn't be automated, or you automate it wrong and apply something that is not explainable, and then it has real consequences on people. So I'm pretty sure that you've seen some of the news, but there's some of the examples, but there are a lot of them and a lot more coming out. So to me, that's a bigger danger, or bigger thing that needs to be addressed on having some. So it goes a little bit on the policy and laws, which are lacking because they are trying to catch up with the speed of the technology. But I think that that's also like an issue that is related on the other side, but maybe it could be complemented, the discussions that we have.
So I just want to add something on the question that just asked. So I'm Jenny. So a PhD student working with SEMLA in the University of Alberta, and my personal interest in neural network application. So regarding why not directly using the perspectives from software engineering to AI component is. I think one of the biggest reasons is that the AI component is not really explainable to us at this stage. So for code or software, usually, or if else statement or loop that are engineering right that we can understand. So if there's a problem, we can localize it and debug it. But for AI, as you just mentioned, it's learned from the data, and it's just some away from the neuron and some exploration. We don't really know why it generates a data like this. So the footstep is in other tools from software engineering. It cannot be directly applicable to the AI component. I think that's maybe one of the.
Yeah, I think you bring up an important overgeneralization we're doing in these kind of conversations. We just use AI in general, but depending on what is your approach, like deep learning neural nets and different kinds of algorithms, they all have their own unique perspectives and challenges. And I think by generalizing AI and you're not borrowing practices, or you are borrowing practices, we're probably not being very detailed enough in terms of, so maybe that's something that we all can improve when we're talking about AI ML. Is there a particular technique that we're using that is possible or not possible to challenge? I think that's an important observation.
Yeah, I certainly agree on that, right? And I think if going back to the specific example that you pointed out, it's one of the cases in which current debugging techniques that we have been using for 50 years are just not useful, right? For finding root cause of issues in a deep neural network. So we need to develop new techniques, right? So we need to improve our understanding of the decision mechanism of these models. And it's not impossible. I mean, we are starting having techniques that have been proposed to help guide, but maybe we have to tackle the problem in an innovative way, different ways, right? So that's why more research is needed. for this. Or maybe also at some point we need to maybe step back and look at the different level of abstractions and try to tackle this problem. But we need to expand on the knowledge that I think we have on the engineering part and try to also deepen our understanding on the learning mechanism of this new model, new architecture. And from this cross-fertilization, I think we can be a more effective technique as we started to see in the community, people proposing different approaches to tackle the problem.
So thank you for this very interesting topic. This is Arioni from Montreal. So I think we all need kind of sustainable and responsible AI systems. And in talks in the morning, we have approached that from different angles, like from engineering, different parts, from the society, from the operations. And I think we have many young developers here, and they might, need to know, they might want to know the best practices to develop sustainable and responsible AI. But they might also need to know what kind of mistakes they want to avoid or past services. Maybe ask you what are the top three mistakes you think we should avoid or we should be aware of. How would be the response? Thank you.
That's a very good question. I would say maybe a bit of difficult ones. I think there are many mistakes. I think maybe the first thing I would single out is regarding the adoption. If you can compute an exact solution to your problem, I think don't use the model, don't use AI. Like try to approximate it, even if it sounds very fancy. Right? So I think it's what that connect to is a good understanding of the requirement, right, that you need for your system. And then based on the requirement, making sure that you're adopting the adequate solution to it, right? And then if you're deciding that you need to adopt some kind of machine learning techniques, because AI will mostly referring to machine learning, I think make sure you understand exactly how that works, right? Like the pitfalls around it, right? So that you can reflect on how that will impact the system, right? So I think not understanding that it's a kind of a bad practice. It's like using as a black box and just being too happy with the recorded performance. I think that's the ultimate anti-pattern, I think. So you definitely should not do that. And I think looking at performance of this component in a more holistic way, right? So I think improvement in precision could sound very interesting, but if the model cannot generalize, if the model is very brittle to like very small perturbations and so on, it may have adverse effects. So making sure to have a very holistic understanding of the impact of the system, the techniques that you're adopting, I think is very, very critical. Yeah, we'll leave my colleague for more anti-patterns.
I think in addition to requirements, maybe we also need to define outcomes and also develop assurance mechanisms. Sometimes the AI systems, you cannot have a complete list of requirements in the maybe training process, identify new requirements for the problems. And I think it's also about explainability, like you need, like I said, you need to have new techniques to make to incorporate different knowledge. Like for example, in our work, we incorporate indigenous knowledge into the model training to make it more diverse and inclusive.
So you asked the top 3 mistakes to avoid. I think it comes back to asking the questions as early as possible. Do you have an AI problem? Should you develop it with AI? And then the last one is, do you have ownership rights to the data? And I had to live through this firsthand when a couple of weeks ago, an organization wanted to engage with us. We went through it, they want to engage with us, we want to engage with them, everything is falling in place. They find out as we were about to sign the agreement, they don't have the ownership rights to the data. They do have an AI problem, they just can't do the AI.
So to me, the 3 worst thing or mistakes that you could do. The number one is assuming that you know everything. So a lot of times when we want to apply AI, it's in a domain that needs expertise. And you can see a lot of AI solutions which are designed without the experts from the particular domain involved. So I think just acknowledging and understanding that there is a lot of science outside computer science, that when you try to address a problem, it's important to bring those expertise, knowing the domain, knowing the stakeholders that are involved, taking the time to do that research. I think that would be the number one. And number two is not doing proper evaluation of third-party tools or tools that you apply. For example, you can have something that is based on face recognition. You get the face recognition from Amazon or something, some other company, third party, and you trust the performance and apply it, and then it has consequences because it's not performing on some of the users as you wanted it to, as you assumed it would perform. So not verifying the performance or accuracy of the tools that you're using based on the data that you have. And I think the third one is trusting the system that you built and not letting it be basically, so if you make an AI decision, there should also always be a mechanism for accepting that it could be wrong and a mechanism to look into the result. And also the user should know that this is the AI generated result and has the option to appeal or try to figure out what is happening. Again, this is something that sometimes is overlooked and it has real harm. So that would be the three from my point.
There's a question at the bottom.
Well, in terms of responsibility, like when we say responsible AI, well, responsible toward who? So is it and who enforces this responsibility? So I mean, maybe part of the organization, but like we don't have also people like from law now and enforcement like that they're here, and how they should be involved in this, and if they want to be involved in this, what is the skill set that is needed for people to be able to come up with this kind of enforcement regulations and policies that we can get, and maybe this maybe open for the next kind of for terms of education, how this can be involved with the non-code.
Yeah, I think responsible is does not only mean just responsibility in responsible AI. So it covers accountability, transparency. But it's different from accountability. Responsibility means who is responsible for this task in the AI pipeline or in the software development process. But accountability could be or can be like who should be held accountable for this task, like the team leaders or the company's CEO. So yeah, I think we can, for example, we can achieve accountability or responsibility through some other principles, like we can have some functionality in the user interface design, like track who trained this model, use where is the data from, or who collected this data, and which version we are using, which company provided this model. So I think through the transparent information, and also when we, I think some regulation, they ask if AI is engaging users, they need to make sure that they put the information on the user interface to make people be aware of this AI engagement. So I think it's also relevant to responsibility.
Yeah, so just if I complement a bit on what have been said, I think if we want to achieve responsible adoption of AI, we need auditing, right? I think we can't just rely on the goodwill of engineers and developers to follow best practices and ensure that they are using it in a way that will not cause harm, right? So we need to have independent, in my opinion, we need an independent auditing mechanism. And I think that requires colleagues from the legal part and others to be able to understand all the risks around these solutions. And also, I think some kind of understanding of how the solution works. So you were asking about the skill set. I think it's inevitable that they need to understand a bit. And I think part of the reason the registration is lacking is because the technology is going so fast that people who are trying to regulate, they're struggling to understand how it works. Right? But I think we need to upskill on this, right? But I think that would not be enough. I just go back to tooling because I'm a tool person. I think we need to be tools, reliable tools, to extract the relevant signal from the applications in a way that the signal can be used by these third-party auditors to make sense of what the application is doing, how the different properties are evolving, because a software system by nature is non-stationary. You can comply today, and 10 minutes later, you can actually fail the compliance, right? So we need to have this mechanism in place. And I think that's why more research is needed on it, because we don't have those tools today, right? We need to build those tools. And we need to train those colleagues from the legal part. They need to start increasing their interest in this. And I think in Montreal, we're already having a lot of effort in this direction. We have people from the legal department like pushing on this initiative. I think it's a good start. We need to upskill this.
Yeah, let me ask a quick question. So, this is late and Alberta. So, yeah, thank you very much for the very nice, good question. So, actually, I have two questions. One is regarding the responsibility. So, because most data-driven AI, the data are actually from the end user, and then they are approved somewhere and by the company. So, and there are opportunities that the data may be used or sell to another company, and the data might have some issues. So that can bring or transmit this potential issue here and there. So eventually, the model having some kind of accident or something, then I'm just wondering from your opinion, who should be the person that should be responsible for this kind of thing? Another question is about the survey, because I think the data is actually, I think you can mention about ownership. I think it's pretty important because that would be actually the core of that decide the power of the AI. And the big company is small company, and from the research point of view, you don't have at one point we don't have the equilibrium with this kind of ecosystem. So from your point of view, from the researcher, we don't have much access of the data. And from the small company, the startup, we don't have the that much quality of data. And how can we continue to involve in this kind of challenge where this type of all the data in the hand?
A lot of layers to your question. So data is an important problem. And I think as we learn to develop and use these systems, we're already seeing increased control over the person or the entity who creates and has the ownership of the data. Like if I'm as a user do not want my data to be used, I do have, there are cases where I can have control over not exposing that data. That then creates the other problem because the data you have is only partial because not everybody allowed that data. So there is, I think, going to be, there are questions and not answers in that regard. There are aspects of whether the data is accessible to the researchers. That's a whole different question. And I think there are the whole area of synthetic learning and synthetic data generation and whatnot. I think that research area maybe is going to grow and try to see whether that mimics the real data as reasonably so that there can be some progress done. And there's a policy aspect of the question that you have. Just because the data is available, should I use it, or what does that mean? And again, this is not necessarily an AI question. I don't know if you've observed or are within that community, but open source community had that. Just because open source developers are exposing their email addresses and the identity in those open source systems, should the researchers keep contacting them or make correlations? So I think those questions are not necessarily only AI questions, they're about ethics and responsibility around data-driven research questions. So I don't unfortunately have answers, but maybe separating which one we're asking might be a good place to start.
I think your first question is also relevant to responsible AI regulation. So it depends on which country's regulation. So AI system is like usually developed based on data from like different companies. So those companies could be from different countries, and even for the technologies, they could be from different countries. So they might have different regulatory requirements on data or AI component. So that's the interoperability issue for the regulation. So I think that's also the motivation to have like responsible AI standards, international standard to address this issue.
Maybe I'll add to that you were talking about how data could go to different entities and who basically something along the line of who is accountable for if there are issues come up with that data. I wanted to add to that it's not just the data, it's also the model. So let's say these ML models that a lot of them are now they could also contain data, but you can also think of just the model design. If you design a model and then it's used in a harmful way, who is accountable? So I think this is not something that is addressed fully or discussed fully, and there are a lot of discussions or debate around it. But to me personally, I think if you are an entity that are designing ML models that could be harmful, you would be accountable. And if you have a lot of resources, you can't simply focus on model design and developing the next model without budgeting anything for responsible AI and understanding the harms of them. So to give you an example, for example, these are these large language models or foundation models that are coming from different groups, but a lot of them are coming from Stanford as well. And then there was this recent example that you might have seen of training one of those models on the tweets in 4chan, which is a social media for very extreme content, and then it's able to generate very racist, all those different toxic language that you don't want to be generated, and then you can use that to deploy a lot of bots on social media. So the response from, for example, a Stanford group was, I don't know if anyone is from Stanford here, sorry, but was just attacking the person that showed this is a potential harm on Twitter, saying that this was not a responsible use of what we're doing, which is just shaking off the responsibility and attacking someone that is showing this is something that could happen, and people that were exposed to the output of that bot couldn't understand or figure out without a lot of debates if it's a human or a bot. So that was the level of realistic information that the bot was generating. And I think if you are an institute that are putting a lot of resource, to me personally, on model design, you need to have equal or same amount of focus or resources put towards countering the harms that that system could develop.
I totally agree with this, and maybe because I know maybe a bit over time, maybe to complement it, I want to point to a recent study that I found very interesting. I think it's from CMU actually. They study the perception of open source developers that were working on deepfake application, right? Regarding their responsibility, right? So they actually, those people are perfecting the art of building deepfakes, right, models. And this deepfake model, of course, are used downstream to potentially cause harm to people. And the researcher wanted to understand how the developer perceived their role in this, their responsibility. And interesting, or I don't know if it's very interesting, but those developers actually seems to be considered themselves as artists, right? So for them, the way it's actually a large community of people interested in this. They say the genie is out of the bottle anyway, so if they don't do it, someone else will do it. So they are not necessarily responsible for how people use the tools, but them, they are striving to create the ultimate effect, right? So, and knowing the potential harm that people can do with those, right? So I think there is an ethic perception issue in the community that needs to be addressed. And we can only do this collectively, in my opinion, right? Because I think since it takes it fall into values and people's values seems to be different from one person to the next, we need to solve this, right? You can't just build something and throw it out there and say, I didn't use it for harm, so I'm not responsible for different use cases in which people use it for harm. So it's an open question. I don't have an answer, but I just wanted to point to this.
The last thing. Last call.
Really on.
Just to comment on this, because I agree with you, just to say that as engineer here in Quebec, we have the code of the college, and I don't know if all the computer scientists are the same thing, but it binds us to make sure that we are good for the society. So maybe we should think about something like that.
I agree. I totally agree.
Unfortunately, I have to close the line, so let's take all the others. I think there will be more panels in the coming day, and also we can continue with the discussion. Do you have a break?
Maybe there's a 5 minutes break, and then we come back for another talk and the notes.
Okay, so see you in 5 minutes.
Thank you. Nice discussions.
What's next for you?
Wasn't there too long, 1 year and a half?
Thank you for the discussion.
This is a bring this. It's very complex. But there is still.
If you want to present the board, yeah, again, you can first do that. I think actually it's sent you.
My role.
Yeah, I'll have this.
Good now. You still want me to be in the share of share my screen. Right. Good. Okay. Now I'll share my screen. Oh, it's not allowing.
And you can use pointers.
Yeah. So high level,
Just have to make me a cohort, and that will work. Yeah. You know, let's just use like simple instead of worrying about. Let me turn off my view here. It's fine. Oh, okay, yes, it's fine. Yeah. Yeah, that's great. Is that good? Is it going up over there? Yeah. Is that good? Very good. Very good. Let's see. So you are introducing me? Yes. Don't read the whole thing. No, that's quite a bit. Just so everybody. The confidence that we're going to go to find out. I don't know how long it's going to take. How long is that time there? 5 months in the US. No, I don't think it's long. My flight is not 4. that I should probably leave by 1 year. I think if you want to arrive at the airport 12 minutes, we're done. It's like, I mean, we're like 150. I like that. Loving a bunch. Maybe order. I will order for any. Very good. Are we ready to get started? Yeah, I think discussion is also important. I'll go through. I'll watch the clock here. We only have 1 hour for this. Sure.
Ready?
I'm ready whenever you are ready. Thank you very much for introducing and Anthony.
Okay, so we'll start now. Go back to your seats and please. And maybe close the door, maybe so that. Okay, so we'll come back. We have today with us, joining us in this session, our next distinguished speaker, Professor Hitesh Rajan, who will be telling us more about modular deep learning. So Professor Rajan is a Kingsland professor and the chair of the department in Iowa State University. He's distinguished speaker with long-term research experience in data science, programming languages, and software engineering. He is distinguished AAA fellow, the American Association for Advanced Science, and ACM distinguished scientist. And he's associate editor in the IEEE Transaction, and he has long-term experience telling us about dependable software and modular software, and he will tell us more about modular deep learning. So the floor is yours. Thank you.
Thank you. And can you everybody hear me in the back? Good. Very good. So today I will tell you how to design deep neural networks in a more modular way by breaking network into pieces and then putting that together. But before we get to that, let me just give you a very brief overview of my interests. So I started my research in the software engineering area. For those of you who are that I know for many years, many decades, I was working in the software engineering area, and then I worked a little bit in the programming language area for a little bit in the Bootstrap community, for those of you who know that area. And then I also did some work in the data science community. But now I have started to really work at the intersection of these 3 fields. And in particular, my research as it relates to SEMLA is essentially on these 2 major topics. I do a lot of work on AI machine learning design and architecture. So we look at modularity related issues. We look at what are the architectures of data science pipelines. We think a little bit about technical depth in these systems. We also do a lot of work on the other end of this, which is our AI machine learning verification. So we wrote the first paper on comprehensive study of what kind of bugs are present in deep learning programs. We also did the first paper what kind of repair strategies are utilized. We also proposed localization strategies for networks, and this was also the first paper in this area, and subsequent work has come out. So a lot of that, my work today falls into these two categories. I also do some work on software repository mining. For those of you who are interested in that area, talk to me afterward. So today I'm going to talk about the deep neural network and how to make them more modular. That's the goal of this talk today. So let's begin with a problem. Yes, anybody has seen this? Raise your hand if you are aware of this. Okay, very good, very good. So what, those of you who are not, what happened? Google had an image labeling technique that was a model, and it started labeling all the black people as gorillas. That's what it started with, right? And so that became a PR nightmare, as you can imagine, right? Very quickly. And so what Google did was it removed gorilla from its image labeling to fix that problem. In fact, Facebook had a similar problem, now a different label with a primate label. And the way they solved it also is to, by fixing the labels. So how was this problem solved? They took the faulty model and they suppressed the output class gorilla. Okay. So now you have the model that doesn't really output that class because somehow it has been suppressed. What should have been done? The model itself should have been fixed so that it doesn't have the problem. And the question is, why wasn't it done? The reason why it wasn't done is because the cost of training is significant, right? The reason why it wasn't done because the cost of training and the environmental cost of training is significant. And really what they would have needed to do is to throw away their model, retrain the model, and then use that retrained model again. And some folks have pointed out about the cost of typical model retraining that is a similar scale and how it has been rising over the years. So we have a problem here, right? We have a working system. The system had a bug. And in order to fix the bug, what we really need to do is to throw away the system and create the system from fresh. And that's how we are solving the problem. And that's not satisfactory. At least to software engineering researcher like me, it wasn't a satisfactory way to proceed forward. So this kind of sums it up. There are bugs in trained DNN models. And if I put on my software engineering hat, in traditional software engineering, we don't throw away software with bugs or that needs new model and redo it. We don't do that. We fix that. We fix pieces of it, and we deploy it. So naturally, I have done a lot of work that has been inspired by David Parnas's work. So I went back to this paragraph that has inspired a lot of my work and says, can we design DNNs in a way that allow a model to be written with little knowledge of the code in another module, and allow modules to be reassembled, replaced, if we find faults in that. So I went back to this paragraph from David Parnas's 1972 paper, which is still quite relevant. If you haven't read it, I would encourage you to read as a graduate student as one of the exercises here. So what is decomposition? So let's do a decomposition 101. If you have a program, and that is monolithic as shown on this side, decomposition is essentially taking pieces of the program that can sit as its own function, such as that you see on the other side. So then you can modify and reuse and replace those functions as needed. So that and it's useful for a variety of reasons that you can now reuse these modules. You can replace them. You can do independent testing of the modules. You can do independent development of the modules. So due to a variety of these reasons, decomposition and modularity are really important concepts in software engineering. So in this work, we are gonna stick to reuse and replacement. That's really what we're gonna focus first on, and look at what do we do in the current world of deep learning models. So imagine that you have a model that has that learns an English data set. Traditional learning technique would be that you have an untrained model, you train it, and you get a trained model. And if you need to solve a problem with that trained model, you retrain it again. That's one approach. That's a traditional learning approach. There is another approach, which is also called transfer learning. So let's suppose you want to take that old model, and now you want to use that model in a new context. How do you reuse it? The way you do that is that you change the last layer to match your new context, and then you retrain it, and then that's how you get your new model. In both cases, the complexity is high and scalability isn't as well as we would have liked. Here's another solution, and this is a very, very nice idea that from the AI and machine learning community on how do we do deep learning models. So this is called a neural module network, and the way this works, think about it like this: you start off by coming up with some example things modules that you're going to need. So for example, I might say that, okay, for solving this problem, I'm going to need a count, I'm going to need a where, I'm going to need a color, and a dog, cat, and so on. And you train smaller models that do exactly that. Okay, so you come up with these concepts that you might need, and then you train models that do exactly that. And then if you have a new problem that you need to solve, your task is to come up with a composition of these little things that you have. That the training is then reduced to a composition of these smaller modules. Okay, so you come up with a composition of that. So this work is really, I really like this work a lot. The difficulty that has been faced by this work is that because human beings come up with these smaller modules, their accuracy is not really as good as when a module is trained from scratch. Because then when the module is trained from scratch, you have all permutations and combinations available for a model to work with. So this has been a problem with the uptake of this particular approach. Here's another work, and it's called capsule network. And so in the capsule network, you create a capsule for different features. And this work has also faced the same difficulty, that the accuracy isn't really where one needs to be. It's not as competitive as traditional network. So we look at it from a different perspective. We think of this problem as, okay, why don't we let the traditional techniques create the network, and then once the network is created, we split it into modules. So we're not thinking about creating smaller modules from scratch. We let the traditional techniques create the monolithic network, And once that network is there, we try to create a module out of it so that in future, we can modify those modules to fix difficulties. So what does that mean in practice? So let's go to this example here. So we had a faulty model. And imagine that we had a working module somewhere. What we can do is we can split the faulty modules into modules, one for each class. And if we can do the same here for this other model, split that into class, maybe we can then combine these to form the intended software that we are really interested in. Okay. So I will stop here and see if anybody has any questions. Okay. No question. Well, carrying on. So here's another way we can do it. We can, again, start from the faulty models and an appropriate model. We can decompose them both, and we can compose using the new model. Here's a third way we can do. Start with the faulty model, decompose, and just remove the faulty module altogether. These are a variety of ways, variety of decomposition and composition strategies that become available to us if we are able to do this, right? And so, yeah, this is a very nice dream and a wonderful, and so on and so forth. But our main contribution was showing that it can be done, and showing that it can be done for a non-trivial set of models. Okay? Because as any software engineer can realize these benefits, right? We don't have to be convinced about these benefits. The question is, can we really do this? So we wrote 2 papers on this so far. One was at ESEC-FOC 2020 that looked into fully connected neural network and looked into decomposing that fully connected neural network into modules. But this work didn't had some difficulties in the sense it didn't support convolutional layers. Modules were created based on one-on-one relation and so on. So we addressed these difficulties in a subsequent paper, which I think this is a typo here. This should be the correct paper. So this looked at the CNNs and showed a way to decompose CNNs into reusable and replaceable modules. And I will browse through these results very briefly, and look at the paper if you're interested in more detail. And I will start with the fully connected version because that's a little bit easier to understand than the CNN version. So the overall idea had 3 steps. Step 1 is the concern identification. Step 2 is the tangling identification, and step 3 is the concern modularization. And so for those of you who may or may not be familiar with the idea of concern is a term from software engineering community, and it has to deal with an aspect or feature of a software. Think of that. That's approximately what you can understand it as. So here, what are concerns? So concerns that we have here is the ability to identify 0, ability to identify 1, and ability to identify 2. So we consider these 3 as concerns. So in the original model, these concerns are all tangled here in one model. So they are all, if you look at the graphical representation of this network, the logic for how to identify 0, how to identify 1, how to identify 2 is all tangled in these nodes. Okay? So the first step is to take this tangled representation and determine which parts of this tangled representation represent 0, represent 1, represent 2. So that's what concern identification is all about. Looking at this tangled representation of various concerns that are implemented by that network and trying to identify which pieces belong to which concern. Okay? So if you just took that, this bit on the right, that would recognize 0, that would recognize 1, that would recognize 2, but it wouldn't distinguish with other concerns. So that's our first step. Take a tangled module, feed it the inputs related to particular concern, identify edges, and then remove the edges that are coming from inactive nodes, and then get this smaller model. For those of you who are familiar with the idea of program slicing, this is very much, you can think of this as a slice of the network, right? Tangle identification recognizes the part where the other modules are playing a role, or other concerns are playing a role, because network is not just about a given concern, but also about how it interacts with other concerns. So here, for example, for tangle identification, what we do is, for this particular example, 0 is the dominant class, but we look at what is the impact of non-dominant classes on this network. And those impacts help you identify what are the places where the representation of this dominant concern is tangled with the representation of other concerns. Okay. And we have techniques on that, and I'm sensitive of the time, not going to go into the details of that, but two main ones that we are interested in is one called punishing a negative example, and I'm going to get this one is really the most useful one, and in which we give the edges that result from these negative example a higher clarity compared to other edges, and that's what leads to this final representation. Okay. Let's see if I could. So the final step is to do concern modularization. Essentially, the way you can think of it as taking this representation that you have just seen and building a full-fledged working network out of it. That's really the summary of it. And the way that we do that is by removing the relevant nodes and then connecting so in this particular example, you have the node, this node that is only connected to non-dominant node. So we will remove that, and then we will remove the incident edge, and finally we will connect the edges together to the output class to get us this module here. And what this module will be able to do is to determine if an input is 1 or if it is not 1. Because that's the overall goal, right? Because we want a final representation of a concern. So as a result, what you get now is a different representation of a deep learning network, which has a collection of modules that are each focusing on a given concern. Now the question is, what do you do with it? So let's suppose now you have a problem with a concern. You fix the module that has to deal with it. right? And so this ability becomes available. So what you get, you started off with this tangled representation, and through this process, you end up with these three modules, one for each concern. Now, software engineering 101, multiple dimensions of separation of concern, right? This is a very famous paper from Carr and Osher and so on. And what does it say? It says that for different tasks in software engineering, we need different kinds of separation in order for that decomposition to be useful for that task, right? This particular decomposition that you are seeing is useful if you're fixing things for 0, if you're fixing things for 1, if you're fixing things for 2. It may not be useful for other kinds of fixes. Like for other kinds of fixes, you might need a different decomposition. And that's an exercise that I leave you with and for potentially future papers to see if there are different use cases for which different decomposition strategy will be useful. So we tried this for CNNs as well. And the reason why CNNs are a little bit complicated is because you don't have a nice, neat graph that you saw in the fully connected networks. So here you have CNN 101, you have convolution layers, you have pooling, merge, and other layers, and finally you have a graph-like structure. For this structure, our previous techniques work, but for these two, they don't. So now, so this next work looked at, how do you do tangling identification and modularization for this class? Again, for technical details, I'm not going to go into those, but they are in our paper. But what this work showed is that for CNNs as well, this technique of decomposing CNNs into modules has the potential to be successful. See, there's some technical difficulty here that's causing me to not have to. So next question is, yes, you decompose things. What is the performance like? This is in early days of modularization. This was one of the common questions that early software engineering researchers got asked. Yes, you are showing all these ideas on how to build software in a more modular way, but what does it mean? Is my software now going to run slowly? And I sympathize with my colleagues in the early era who were coming up with these ideas of abstract data types and so on and so forth, because they really had to address. So the question is here as well. Performance here isn't really runtime as much now. Performance is accuracy. That's what people are more concerned about. Right? But the ideas are still there. So to test the ideas, we looked at a collection of data sets, and some of these are state-of-the-art model, and we asked these three questions. Does decomposition involve cost? Can reuse and replacement be done in a cheaper way compared to retraining? And does reusing and replacing emit less carbon dioxide, which is good for the environment? Right. So I am going to, I'm looking at my post and not exceeding the allocated time, give you the summary, the gist of this all. So there is a cost of decomposition. But that is relatively trivial. Average cost is about a little less than 1.77%. for top 1 and top 5 accuracy. Can reuse and replacement be done? It has a cost. So there are two kinds of reuse that we tried. One where we tried the intra reuse in the both all the modules were from related data sets, and there we saw a slight uptick in accuracy. But when we tried to reuse one module from one data set to a very different kind of data set altogether, there was accuracy loss. So I think that's something we need to continue to work on. Does reusing and replacing emit less CO2? And here the answer is very impressive. We saw a 37 times reduction in environmental impact. And that's something I think is worth looking at. Because if you are training larger and larger things, if you can change them more readily without incurring a significant environmental cost, that to me is a worthwhile direction to think about. There is a lot of future work in this area, and it generally falls under these three categories. The reuse and replacement needs a little more work. So we need to think about different techniques for reducing the cost of replacement. We believe that decomposition also has the potential to help open up these black boxes. So if you have a collection, if you have a black box and now you're thinking about that black box as a composition of smaller things, you are naturally know a little bit more about the black box. So we believe that this is an important area. And then, of course, we need to really show this all in an industrial environment to show whether it makes development and maintenance more flexible and manageable. So with that, I will stop and I will take your questions. Go ahead.
We have two questions. A fantastic presentation, Dave. Just maybe a thought that I have in my mind is, how does this modularization of the AI system open vulnerabilities in the AI system? How does it change? So, I mean, coming from an adversarial attack perspective, right, when you're dealing with a full network, then even these small perturbations can cause differences in the classification between these models. So how does modularization affect that? Because now I think that each of these modules is not as robust as the system. Did you guys do any studies on this or empirically?
We have done a little bit of work on it, but I'm not necessarily, I don't consider myself as an expert in adversarial learning. My initial intuition is that modularization now makes it possible to inject techniques that can detect against perturbation as part of the composition. But this is just a blue sky thought at the moment. But I'm really happy to talk with you, and maybe we can even discuss some collaborative effort. But essentially, the idea is that can the composition mechanism also be used as a way of making the composition more robust, so to speak.
This is a really good work, and there's a lot of evidence that you can do.
Yeah, and I'm happy to collaborate on this. Yeah, we had more questions.
Clarification question. If you go one slide back. So by cost, you mean the penalty you get in terms of the prediction? What is that measurement? One like the
Yes, that's the penalty that you get for accuracy, and 1.77%. Means if the penalty is positive, that means the resulting thing is a little bit better than the old, and if the penalty is negative, which is the case in the inter data set, then you see a negative accuracy.
And the question related to that is, are there more than one approach to modularizing? Like there's not one size fits all, right? You can modularize in different ways.
Right, so there could be multiple dimensions of separating these concerns into modules, correct? The one that we have explored and then one that we have pursued concerns itself with considering output class as a concern.
Okay. I see.
That is one so that's one dimension that we, but I can tell you that there are multiple other dimensions.
But now it makes sense.
Yeah.
Thank you.
I have a related, maybe a good question.
Yeah.
Like, how do you anticipate based on a regression task instead of a classification task? Sorry, on a regression task instead of a classification task? How do you intuitively?
What are the implications for testing would be my next question.
Right. And you know, a different way of decomposing would need to be conceived for different kinds of tasks. But going back to the testing question, we haven't tested this. I'm not a testing researcher, but I would love for testing researchers to pick up and do something with it. Is the good. So the question is, you know, now is the module easier to test compared to the whole thing? And what does it mean? So things like coverage and so on. What do they mean in this setting compared to the big network setting? So there is a lot of opportunity for doing follow-up work. You know, there are multiple advantages to modules. One of them specifically realized in testing literature. And can all of those advantages translate here in some way, shape or form? Good. Yes, go ahead. Okay.
Yeah, it's very interesting and
Thank you.
especially like someone who's working on like deep learning systems. So I understand that with these type of things, it's gonna like reduce the training time and how the researchers can understand what's actually happening in these neural networks. So my question is like, it's more about the diagrams you were showing. So when this decomposition into the modules, this happens. So when the network is fully trained and then on the results or output of the network of the training, then these modules are formed. Like at what stage these modules are actually formed?
Yes, so that's the main difference between the way previous work has taken the task of creating modular networks and the approach that we have taken. Previous work tries to create modules from the beginning and then train the composition of modules. What we try to do is we say, let's have the traditional techniques to train the network. Okay. And once the network is fully trained, we look at the structure of the network. Because the model is just a network, right? So we can look at the structure of the network, and based on that structure, we can do this decomposition. So to answer your question, when does decomposition happen? It happens after the initial training has been completed.
Right. So I have another follow-up question.
Because the reason why it happens at that time, because there is a significant penalty if you try to decompose in advance and then try.
Right.
Go ahead.
So because this is also like when we develop solutions, we have to be careful that the solution is expandable as well, right? For example, when we have new data sets. So for example, similar number, I was developing a system for 20 projects, but as my project grows, I have 40 projects or even more and like even more data. So in that case, now I want to, previously we don't do the decomposition, we used to train the full model, right? But now we have the modules. So isn't it going to be like more tasks that we retrain again and then again the cost associated with the composing into modules as well?
So let me answer this. So let's suppose let's take a very concrete example in your setting. So imagine that you are trying to assign labels. One label being this is an engineered system that we really love in software engineering. This is an engineered system versus this is a toy example, right? We would love to have a quantifier that takes software projects and puts these two labels on, right? So if your question is, if your engineered system classifier is not working very well, then you could maybe train that module a little bit with more data. You don't really have to muck with other labels, modules that are corresponding to other labels. So that I don't know whether that makes sense. But if your evolution task is to implement a different kind of feature, this particular decomposition style that I talked to you about would not work. Some other decomposition style will have to be created, which is the standard, this is why Perry Carr and Harold Rocher and so on and so forth wrote this dimension of decomposition paper that we should, I would encourage you to go read that. It's a little bit, you will have to, look at the paper and it's a very nice paper. So take a look. Okay. Yeah. Okay.
Okay. I think, we're running out of time, so.
But I'm here for a few minutes. If you,
You can like ask your questions and, yeah, I know that this is very exciting talk and I mean, there's many, burning questions there that people want to ask. I think for now we can, thank you.
Thank you very much.
And thank you. And please, yeah, you can.
I'm just here. I'm gonna be here for a little bit. So please come by, we can discuss.
And then announce the lunch.
Very exciting. Thank you. A lot of questions.
I don't work. So it's lunchtime, so you can go down to the first floor and go to the cafeteria and serve everything. So there should be volunteers to help you find your way if you become failure. We'll be back at 2.
No, ideally not. Ideally, you would. So imagine that you have a data that you don't just add data for a subsystem. So let's suppose the reason why you are adding data is because one of your classifiers is not working. Okay, so you are saying, oh, I got stuff. So you would add interface that allow you to classify. And so you could take that module, all that particular file. That's once you're done with the initial decomposition, would ideally not.
Right? And then you want to have we just that I think that is doing the work as well that they would have with that and then.
Okay, very good. Thank you. Thank you. So I'm just at the end of the application model. Yeah, or like in a particular decomposition.
Let's say we have a problem with other. How do you build the data set? Like, do you give like example of this, like so this lab and this lab and we use train this?
No, the way that you construct the training for that one module is that you give it all the data that you have for that class, and then you give some pieces of data from other class, so that it not just learns how to
give them negative.
Give some negativity. That's what we call negative example.
How do you select those negatives?
You, so far, so far, what we have done is we essentially just randomly pick those. No. We just randomly. but I think there might be opportunity to do a little bit more, more on that. This is.
And you did the actual architecture. Because you expressed some no.
Repeat that for us. Hello. Thank you.
So. Yeah, this one. This
Oh,
one.
it's okay.
Yeah, okay, yeah. I can give you a USB to USB-C to.
Maybe this one? Oh, it's okay. Yeah.
Maybe wait. Yeah, I just see. Think it would be better. Oh, yeah, problem solving, I know, the only way I know is turning off the computer, but I don't, if we turn off the computer. If we turn off the computer, then we have a big problem.
We also lose the summer.
Yeah.
Yes.
This. Yeah, I don't think you should touch the others. I don't think there's an easy way.
Can we put something up like SEMLA's?
Yeah, I think that's what we'll do.
The thing is, they cannot. Without, if we cannot, create a preview. See, you want to share one screen with your streaming.
Yeah, but this computer could, like, we could just plug in a computer that has a SEMLA slide.
We have, yeah, I've done that. I put things in my USB, I forgot it's money. I want to do this. I'm putting this computer.
Yeah, but right now it's his. We can do it during the break. It's at the bottom.
Yeah, remind me to do
Yes.
I have a slide here.
Okay, perfect.
Plugging.
Then we can just have the SEMLA slide in the background.
Yeah.
It will still like line the presenters, but at least it'll make sense.
Yeah, I was thinking, you guys say good luck with your session. I think that's.
Try to get first. Yeah, that's.
Once you're asking for. We should avoid.
Yeah, I think we should give the opportunity to everyone. Let's phrase it that way.
Okay, everyone, welcome back. Can you hear me in the back as well? Excellent. So I hope you all had a great lunch. For this session, I'm quite excited about it. As a software engineer and software researcher, we are going to have interesting talks about software engineering and AI. And we're going to have three fantastic presentations. Just to remind you that we're going to have like 30 minutes for each presentation, 20 to 25 minutes for the talk, followed by Q&A. So if you don't get a chance to answer your question, don't be disappointed. We're going to have time throughout the session today and tomorrow to talk to our presenters. So we'll start with Leima. He is an associate professor with a shared appointment between University of Alberta in Canada and Kyushu University in Japan. And he's also Canada CFAR AI chair and a fellow at Alberta Machine Intelligence Institute. So his research is in interdisciplinary field of software engineering and trustworthy AI with a special focus on safety and security. So without further ado, I'll pass it on to Lei.
Yeah, thank you very much for the introduction. Yeah, I need to, sorry, I think I need to quit this sharing. How about now? Okay, perfect. Yeah. Thank you very much for the introduction and the invitation. It's a great pleasure to be here. And this is actually the first time since COVID-19 that I re-attend the seminar event. The last time is before the COVID-19, so it's really exciting to see the old friends and the new friends here. So, in this talk, I will give a very high-level introduction on the from my personal point of view that the challenges we have for data-driven AI system engineering at this particular point in time, because things changed quite fast in the last several years. And in our lab in Alberta, so what we are doing, there are two very big goals. One is trying to propose a foundational methodology and engineer support to build the intelligent software system. So we consider both foundational software and also the data-driven intelligent software as well. And with that, we hope that these techniques can be applied to different application domains. So we're mostly focusing on like cyber systems, cyber physical systems, and also we hope that these techniques can break the boundaries of different application domains so that we can have a better application scenario. So at the University of Kyushu, so actually I also working with Jianjun mostly, and joint work with Fuyuki, Paulo, and Yoshio professor. So mostly in Japan, the activities of EAI is to providing the engineering support with a special focus on engineering to provide better support for building the trustworthy AI systems. And Paulo, I think in his talk will give more detailed introduction on the activities in Japan. So here, I will start with a thing that I think is who you don't love. Because the software is deep in the world. This is from Mark Anderson, actually 10 years ago. I really like this because when we look at all the history, so how the human understand our physical environment, how we can, from our human intelligence to build the solutions, shaping the different science domains. And yeah, from the macro, the space, from the macro point of view, bioinformatics, so on and so forth. So all these kind of things have been built for many, many years. But since the last decades, evolution of the digital transformation, all these kind of things are bringing into the digital world, and we have a way that we can reason or quantify from that point of view. So, for example, in these days, I think the digital twin is really, really important terminology mentioned time and time, so that we mirror physical world into the digital world. And it's actually quite going very fast in the last several years. And also in the other way around, so we have created this kind of mirroring in the digital world, and then in the cyber world we can do actually more and more, like in the metaverse, using AR, VR, these kind of techniques. And if you look at the landscape of metaverse Web3 these days, like a lot of exciting new world is building, and they are citing the new like shops like in Tukushvaya, just like the normal land. They just build and buy the new land in the digital world with a similar amount of money. So we see that a lot of these kind of things happens in the last several years, and the digitalization is super important. That's actually what I want to stress in the first part. But actually, in the last decades, there's a special focus that the data give us new power that we can actually redesign and rethink how we can leverage this large amount of data to create a solution that we cannot do it in a rule-based way that we have done that for many years. And in particular, machine learning, deep learning, that has been widely adopted in many industrial domains so far, like manufacture, autonomous vehicles, machines, manufacturing, audio systems, so on and so forth, and even in art, there's a lot of generative AI models everywhere nowadays, and also in the scientific field. So it's really exciting from my point of view. And what I want to stress here, this is a quote from Jason from the NVIDIA. So I think we are entering a data-driven world, and the data-driven AI is trying to eat software in some part, because that can be part of the software world as well. And this is a recent survey by IBC Japan that he did a survey on more than 400 companies like using AI and in the last several years. And you can see from this graph that the more and more companies are passing the POC stage of using AI and showing that the AI can indeed create the values at other companies. And with more and more application in the next several years, definitely a lot of the quantities are really important in safety. But in the real world systems, the AI is not a standalone model. It's built by both fundamental software component and the AI component together. So often very complex in practice. So this is an example of Apollo autonomous driving system. This joint work actually with Mitchell. He will give a talk on this in more details. But here we found that actually there are more than 30 models in the perception part only in this Apollo perception for perception of LiDAR, radar, and camera sensor signals. And also in a very typical audio system like Siri Alexa, the system actually composed quite a few very actually big modules like speech recognition, natural language processing, and understanding. And with that, we have the text-to-speech simplified. That's also a really big part of AI. So we see that this is, we use it for many days and nights at our mobile devices, but it's really complex in some sense. And this is another example from the DeepMind's AlphaStar. So here we see that the goal is to have players to play in a good way and to compete with each other. And the following is actually the workflow of the whole solutions. And again, this is not actually individual model, but actually it's designed piece by piece and eventually composed in a very complex way. And each piece actually have a lot of curious and tricks that part. And that's the reason why it's so hard to make a whole system work so well. So I will give these examples to show that the engineering aspect of AI is really important. And it's not actually so stressed and receive attention in the AI community. And but I think this is a really important topic, actually in the next several years, because we think that we already entered into the stage that engineering play and should play an important role to fulfilling, especially the complex systems in some way. And where this is coming from is the data-driven approaches redefine program paradigms, both in the ways how this software is built and also the understanding of the whole processes, like the training process, the data management, and the model management, so on and so forth. And in our current state, a lot of actually guidelines, international standards are being built at this moment, but it still lacks those kind of well understanding and establishment as we have for traditional software in the last several years, 30 years, for example. So for example, we have systematic quantity reliability assurance technique. We don't have the standard pipelines in the company, and every company has its own, but it's really hard to know whether they share a common part of it. And we also have a rigorous quality control in different stages and for different artifacts and assets of our AI systems, like the data, model, source code, so on and so forth. So that's actually not surprising. In the last several years, we see a lot of these news on the negative parts and the impact from these misuse and accident brought by AI. And with more and more, again, the importance of, especially this is a survey by GST in Japan's domestic market. If the AI wants to be used in that particular domain, at least a medium to high reliability is really important necessary. So that's actually, I actually want to motivate more on the importance of engineering aspect of this. So, but for typically for the AI system, we not only need to consider the software of traditional part, but also the AI part, and that's actually where we rise a new part of it. So, so traditional software part, I think many of the participants are from the software engineering background. I think I don't have to say too much because we already have a lot of quantity and safety assurance standard ways and pipelines and other tools there. But for AI component, again, the data-driven approach, that's actually a very active research area these days. But one big thing is that the traditional software techniques, especially in terms of quality assurance, cannot be directly applied in a data-driven context. And we have to rethink, rebuild all these kind of tools in some sense. Okay, so and my students in our lab actually do a quick study on how this field grows in the last several years, and we actually search the engineering aspect of AI in different fields like in software engineering, in software system and formal method, cybersecurity, and also the big scope of AI conferences. And eventually, we found that there are actually so far already more than actually 200 papers so far. So it's actually growing very, very fast. And yeah, the students are sitting here, they are helping to do this survey. So, but with that kind of understanding, what should we do? So we have to think this for quite a while. And in the last several years, we mostly focusing on these kind of different aspects. One is, again, because the data-driven AI model is the new thing that impacts the whole system. So we have to think about how we analyze and understand the model's behavior in some sense, and then how we understand the model's role in the system in some sense. And with that, with the system level, we also need to consider the vertical way that the AI stack, how it's support and how well it support the AI system at top level, and whether we can break the boundaries across different domains and with a human-centered way in some sense. So here I would like to more pose the questions and give us a very, very early stage exploratory study and hope that could be interesting in some sense. So again, on the AI model level, we think about the from the requirement to the development building, just like the traditional software engineering, we have typically follow this kind of a cycle. And in actually each stage, for the data of the model and for the model evolution maintenance, actually we need to propose new techniques as well. And we have indeed proposed a bunch of techniques so far, but this idea is that we try to understand and approximate the behaviors of the models in some kind of ways. And with that kind of abstraction, we can do some quantification because measurement, I believe, is really important for either risk assessment, quantum measurement, and so on and so forth. So quantum measurement is really important. And with that kind of a quantum measurement, we can use it as a goal to drive us to optimize and target to do the optimization in some sense. And in a very early stage, because I do software testing and analysis in my early career, so my first cutting point is whether we can do some kind of understanding analysis on the model level kind of understanding from the models unit. So like the neurons, neural interactions, so on and so forth. So we would like to propose some kind of like criteria for us to understand this internal behavior. And that's actually the very early work engaged is trying to do things that are using the training data that follow some kind of distribution we want to solve. And then we use this kind of thing to profile the neural network and to understand the statistical behaviors of each neuron. And with that understanding, we can understand the like major function regions that where the neuron mostly active in that particular geometric space, or the corner case that is rarely activated in that particular sense. And with that kind of understanding, we can divide this kind of thing as like a major functional region and corner case region of each neuron, as well as their combination. For us as a guidance to know that whether we, for example, testing point of view, whether we test or cover the internal logic of this neural network well or not. So, for example, that we do the like neuron level, we do neuron interaction level, and we also, yeah, this is actually very similar to Rajesh just mentioned whether we can do modularization, but here we consider the like the activation path of bind to a particular semantics like of the classification 0 and 1. For example, in that path, usually it's classified in that area, and with that kind of semantic guidance, we can do the first thing we can do is like we can do coverage guided testing. So we use this coverage criteria we propose as a typical indicator and feedback to design a fuzzing framework to test the deep neural network, for example, for the image processing and object detection, so on and so forth. And this shows to be very useful. And the next thing is whether we can further to handle more complex deep neural networks like the recurrent neural network and transformer. Usually these neural networks have internal states inside. So, and we'll also propose similar techniques like using the abstraction. So we try to extract equivalent white box model from the original black model of recurrent neural network or transformer. And with that kind of thing, we can do some kind of quantitative metrics proposal, like the corner state, major state. So it's very similar idea. And with that kind of thing, we can use it for different applications like testing, analysis, understanding, so on and so forth. And we actually also apply these techniques to the real world speech recognition system for large volumes of data selection and how and which part of the data could be useful for training and which part could be suspicious or the blind spot of the model that the model is not actually good at handling that. So we can automatically do the selection, identification, and analysis in a large way. And yeah, with that kind of understanding on the model level, so our next goal is trying to see what's the role of the model in the system. So that's the next step. And that's the reason why we do the large scale early stage improvement analysis on the autonomous driving systems. But again, when we analyze the roles of the model in the system, still need to understand the roles of the model. So what's the capability boundary and the risk one can make a decision. So we do this from 2 points of view. One is from the data distribution, because the data-driven approach, I think this data distribution is still really, really important. And another is from the uncertainty perspective, because that is helpful for us to know how confident that model can handle a particular input. So with this kind of 2 point of view understanding, we inject this idea to analyze this kind of error propagation in a whole system. So this joint work with Fujitsu. So this idea is that we, from the data distribution point of view or uncertainty point of view, to see how this error information can propagate from like large scale AI systems like speech recognition or for others. And yeah, again, in the next part, we definitely will be very interested in how well the AI stack can support AI applications. So in our early stage, we actually do some kind of improved study and find that currently landscape of the AI stack is in particular the framework, AI compilers are actually highly diverse. It's really strong fragmentation, and that is the reason that makes the model developing on one platform or framework hard to be transferred or deployed on another one. And we found a lot of issues during this kind of stage. So these are kind of work, yeah. And one thing we are currently working on is to take a special focus on the AI compilers, because we think that is really important. That could be helpful for AI model deployment in a large scale. And we are working on to test and analyze the kind of issues inside. And indeed, there's a lot of issues we have found. So the next goal is, okay, so we have some of these techniques, but they are already in the command line tools. Nobody is might be interested in using it. So our next step is trying to make it alive. So we actually think about whether we can do some kind of human interactive design of these tools for debugging, analyzing the model behavior, visualize it, and similar for the data as well, and similar for the source code and training process. So this actually the work actually done by the student GDS and Yuan. So the idea is that we try to actually we adapt the idea of SEMLA. So we actually extract the approximate white box model of the original model, and with that we can do the visualization, analyze, and this connection with the data, so they can play around to debug the model in some sense to see what is going wrong and where is the blind spot of the model. So similar idea, we can also do the data side, only the data. So, and see how it impacts the training process in some sense. And with this kind of technique, so next thing we are thinking whether we can apply these things into different application domains. So we take a special focus on the cyber physical systems. This is actually I'm really interested in, and the other cyber systems. So in the cyber physical part, so our next first thing is that we need to find some kind of AI-enabled cyber physical systems we want to analyze. But we found that in the research field, we don't have that much or many the existing subjects we can use. So our first step is trying to build the AI-enabled cyber physical systems. So we do actually 9 from different application domains, like autonomous driving, like aerospace, powertrain. So actually, this is from a large scale of actually the cyber physical systems available that we can do, and then we include the AI inside, and we found that it's really interesting. But actually, how to do the safety and the quality assurance on these systems is very different from the classic or traditional cyber physical systems because of the introduction of AI. So with this, our first work is trying to see whether we can propose some kind of new testing, or we say classification in cyber physical system to detect the potential issues in this kind of system, to find the vulnerability point in it. And then after detecting the potential issues, whether we can to repair in some sense for these kind of techniques. And our more recent work, we are thinking go beyond one step further, whether we can do a benchmarking of the AI-enabled cyber physical systems to do a universal systems. So this is actually a recent joint work with India on the Omniverse framework. What we're trying to do is that we try to build an AI-enabled cyber physical system inside this kind of platform. And we take a special focus first on the ARM, robot arm manipulation, because this is a very general task for the system that is also really difficult for traditional, like either in control of cyber physical systems. That's where the learning-based AI can be helpful with. So on the other side, I think cyber is also really important field that we have one cyber agent that interacts in another environment and might interact with other cyber agents as well. So and again, from this cyber point of view, they are quite complicated. But from our point of view, the cyber part might be crafted and constructed by the source code. So whether we can use AI for better robust system analysis and enhancement of the AI for source code processing. So this is actually our first work on the bottom part. And on the next part is on the protocol level, because the smart contract could be a really important protocol in the next generation web applications. So we see whether we can use the AI for this kind of next protocol layer. And with this kind of protocol, we see whether using AI can be for like web applications or for testing and analysis of video games that's on the application layers. So we see whether we can build this kind of AI-enabled like a cyber physical system and cyber system framework and platform and benchmark, so that the research community can benefit and use it for proposing, analyzing these kind of AI proposed techniques in a more controlled way in some sense. So actually, the last thing I would like to mention is that when we have a system built and deployed, in the software is a really important milestone. But from my point of view, AI systems, the deployment is only a very baby step, because the external environment is moving so fast and very frequently. So this is actually the graph that can summarize these kind of things. So data-driven approach, external environment changes can impact it quite a lot. For example, we need to monitor the data healthiness all the time. We need to monitor the model healthiness stack healthiness and also the post healthiness. So in all different kind of point of view. So example, the data may have some kind of distribution drift, concept drift, then the model can completely broke in some sense. So basically, these are the main point I would like to bring up for today's presentation. And here is a graph that summarizes the whole machine learning system engineering lifecycle from my point of view. So we have the model here, model building process, then in a system way, and then deployment, evolution, maintenance, application, and how we can actually, from the engineering point of view, to propose novel techniques, method, tool chain that can support this to make it more democratized AI, that even a person that don't have enough knowledge of AI can still easily use these tools to build AI solutions. I think this is really important next step for us to think about. So basically, I think the AI theory is still developing. There are more than 100,000 papers here submitted to the AI community. But from the engineering point of view, I think it's a really important step that and a thing that can actually eventually make the AI theories into practice in some sense. Just we don't have enough theories in doing the architecture in several hundred years ago. But actually, it doesn't impact us. We build these systems or the buildings in a very complicated way. So this is actually the recap. That we take a very brief through of this AI building process and some kind of challenges and potential opportunities in the six point of view. But this is definitely not a comprehensive angle, and it's not maybe an updated one in the next several years because things change so fast. So yeah, overall, so we have some tools, and we have also resource. We have a tutorial tomorrow afternoon. So if you are interested in, for example, the testing analysis tools, definitely welcome to join that session. Yeah. So basically, this is what we like to present. Thank you very much.
Thank you very much for the interesting talk. I'll open the podium to the participants.
Hey, great talk, and so many intelligent ways of doing things. And I was just wondering from software development perspective, several people, all these testing approaches. Now, in software development lifecycle, we have these approaches where we say testing, and then in testing we have unit testing, functional testing, regression testing, and everything. With all these new ways of approaching AI system, where do you think those testing approaches will fall into the testing phase or into some other phases in the software development?
Okay, so yeah, let me try to understand the question. So what you ask is where these testing techniques can fit into the development lifecycle. So okay, so I think in like AI testing, or I would say AI system testing, I think it would be similar, high level methodology point of view to training software. So we need to do it at a unit level, integration level, and system level. And it definitely it needs to do, for example, white box setting for development team when they develop the models, but also the black box setting that the external third party team may test whether the thing works in this environment. I think these kind of things are very similar. But I think the challenge here is that how can we test it? For example, the testing techniques, what's a good testing criteria, testing strategy, and how we develop these kind of testing materials or artifacts in a systematic way. And more importantly, how can we measure? I think this is really important because I think in the financial software, the testing, we have the measurement, for example, like different cover criteria, standardization, those kind of be very important to help the development team or product team to understand how well that thing is to be shipped. But here we don't have that kind of thing. A lot of standardization are still in progress, but I think there's a gap here with the technical level because the thing we want to achieve, yeah, maybe the standardization, but it might be hard on the level in some sense or at current stage. So I think that's the thing we need to say. Thank you.
So that would be presentation and having some great. And so I have a question about the benchmarking that you mentioned for the regulatory funding. So I have two questions. One is that the first slide you put the benchmarking how many current and for AI enabled systems seems to be various domains. And then you mentioned that we want to move it to omniverse and media omniverse. So but it seems to be why that movement you're moving to more specific global situations. So that's why you're taking this move that way, because I think having various domains might be more useful. Another thing is that I'm benchmarking can be very useful for people to compare their techniques and have challenges competition. Are you considering something like that with your benchmark, something to have challenges that can have people compare actually more systematically their work?
Yeah. Thank you very much for this question. I think this is very, very important. We also consider this quite a lot. So for the first one, actually, because we entered this field not in a very long time. I know you don't have done a lot of work on this. So we entered here mostly starting from the simulating models in the math world, because I think that is a very common platform that the company is using. So we try to collect actually more than 60 these kind of supercomputer systems in that system. That's co-developed by MathWork and the partner of that particular domain, for example, like the ACC, that domain. So so here we want to see which of these systems is possible to using AI or using AI can be portable in some sense. And then eventually we filter out these 9 applications eventually, and we propose different techniques here. And then you ask the question why we shifted to the omniverse environment. So during we do this, we found that in the real world there are some big companies like BMW, they indeed using the simulating models at their early design stages. But in more general robotic companies, they actually use more like the ROS, and there's a big gap here. So we have a model tested, but it's on design level. It cannot be directly translated into the ROS environment. So that's actually the reason we shifted the platform a bit. And then by chance, because we have a partnership with NVIDIA, and they are trying to promoting the platform of Omniverse, and that's actually a very we shift that.
Thank you. I think unfortunately we don't have time, so I think the discussion is long.
Thank you very much.
So let's have our excellent. So for the next slide, we have Jinchu Yang. She's an assistant professor at Concordia University here in Montreal. And her work includes software quality assurance and automated program repair. So she has worked in many collaborations with industry, and her research work includes testing autonomous driving systems and helping developers build more responsible and robust AI systems. So without further ado, thank you. Over.
Everyone, it's a great. I'm very excited to be here, and it's a great honor to be invited to this wonderful event. And I would like to thank all the chairs and organizers for organizing with so much effort to organizing this great event for us to be here and discuss the future of engineering AI software systems. My name is Jinchu Yan. I'm an assistant professor from Concordia University. So today I will talk about some of the work that my student and I and my collaborators are doing on understanding and testing the complexities of autonomous driving systems. So first of all, a big shout out to the wonderful collaborators I'm having. Three of them are my students, Pengzi, Bo, and Jun, and also Dr. Chen from Concordia University, and also Dr. Lei Ma, who is the first speaker here. So we have been working together on the work that I'm going to introduce today. And also, I'd like to share a very exciting program that I'm part of it. It's under Create SE for AI, which fits perfect to today's topic. And that's why it's no surprising that you see folks as one of the key PI here. And it's a cross-university collaboration to train the next generation of AI software engineers. And it's concerned, it includes Concordia, Poly, and also Queens and Alberta. So the trend, I believe many of the trainees of the programs are here today for the poster session, and so please join the poster session and give comments to our wonderful trainees. So I come here with good news. So if you are like me, who does not really enjoy driving that much, you will be very excited to notice the recent survey by McKinsey highlights that there was a strong belief from industry leaders in autonomous driving car systems that there will be a high-level autonomous L4 highway pilots is possible to be hitting the road in the next 2 or 3 years, which means in L4 is the level of autonomous, which means that you no longer have require a driver in the driver's seat, but however, you still have the wheels and the steel and the breakers. And also there is so we also highlight a significant effort investment required to L4 and L5 level of autonomous self-driving car system. And with the rise of more autonomous, like less human intervention, the survey highlights that there is a significant amount of investment on validation costs. So where you see from the left to the right that we see a higher level of autonomous, and then you see the higher portion of investment required on validation cost, which is much higher compared to the software development and also the hardware development. So that's because the safety of ADS is extremely important. So this is a bit common knowledge, but I'd like to share a few news articles from 3 years ago that the pedestrian was hit and killed by a self-driving car system from Uber, and also recent events, crashes and tragedies caused by the autonomous driving component in Tesla. So after all, when we talk about testing, applying quality assurance to autonomous driving system, there are 3 keywords I would like to emphasize here. Is that ADS is a complex AI software. So complex AI and software. So first of all, after all, it's a large scale and complex software. And among that, there is an AI component which is making critical decisions. So we on one hand, we are thinking about how can we apply decades of research in software quality assurance to this new type of software, which has AI component unit. And also we see rising research on testing machine learning models and how to plot those research in the domain of testing and quality assurance on autonomous driving systems. And in this talk, I want to focus on looking at one keyword is complexities. So first of all, it's a large scale and complex software. So for any, just like any other large scale complex software, applying quality assurance on those softwares are not easy job. And there are ongoing research, and they still we see crashes and production failure every day from those. We consider them mature software. And also the unique complex in the ADS is that it has complex integrations. So integration is not just limited to code and AI models, but also within the AI components, complex integration involve multiple machine learning models, since it's a very complex AI system. And also complex integration concerns code and machine learning models together. So not just machine learning models is making decisions, but with the infusion of code and the infusion of the code and multiple machine learning models. So it's quite complex as we just think about it. So in this talk, I will organize two types of my work. So first, I'm going to present you the study that we performed to understand the complexity, as I mentioned. I mentioned it could be complexity come with integration of machine learning models, and also complexity come with integration of code and machine learning model. But I'm going to show you the evidences of such complexities in a real-world industry-grade ADS system. And second, I'm going to briefly introduce our ongoing work that to target such complexities by perform whole system level kind of testing to ADS. So let's begin to the first part. So we started this idea with we all know like ADS is such a complex system with all these reasons I just described. But we were looking to actually look into detail into the code base and try to reveal what are the real complications coming from. And so we decided to perform a case study on one of the most popular open source autonomous driving system out there. So this is not a few individual models in perception, but this is a whole ADS system, and it's developed by a tech giant company in China, Baidu, and it was open source back in 2017. And it has the entire complete system, and you can download it, compile it, and run it in a simulator. So you can actually drive that ultimate, drive the system, drive the ADS system to various different cities scenarios. And these are the breakdowns of the version in terms of how large scale it is. It has almost 5 million lines of code in C and C++. And also it has a portion of Python code and also protobot, which is the main component that used by the CyberRT, which is used to serialize the data streams and the communications inside of the ADS in terms of between different components, between different machine learning models, and between the code and the model, so which is in charge of the whole communication purpose. So we do a bit of qualitative studies on two aspects. So first, we set out to understand really in Apollo how are the machine learning models integrated with code. And then we run the existing test cases and also run the simulations we can find, see how well tested is the current status of testing quality assurance activities on such a machine learning related code. So a brief, just talk about how we did it. So we have the code base, and then we look at the documents and find out these are the frameworks that Apollo is using. So it's not surprising that it's using more than one framework. And then we are looking for the model files, and then based on the extensions, then trying to analyze them to really build this architecture of Apollo system in terms of machine learning models and the code. Okay, so this is a simplified overview of Apollo machine learning components. So it's an ADS, so it has all these sensors, cameras, LiDAR, cameras. This input will be, from the cameras will be processed by the different traffic light modules, traffic light recognition and land detection. And the LiDAR and the camera LiDAR together, and also the radar. So three types of sensors. Their inputs to the module called obstacle detection, which is a machine learning module employs a few machine learning models. And this module is responsible for identify what type of obstacles it is. It's a pedestrian, cyclist, or a car. And altogether from these traffic light recognition, land detection, and obstacle detection, model code trajectory prediction is going to make the decision and give a route via the contributor. So we analyze each of the module, among that module, and then we identify different ways that machine learning models are working together, collaborating together, and as well as how they interact with the code. So for example, in traffic light recognition, we find there are 4 different machine learning models, but they are actually end up into 2 types. So the first type is the model that is actually detect a region of the camera picture which corresponding to traffic lights. And the second type of model, which takes an output from the first model and predicts what kind of color is the traffic light. And to do that, there are 3 different models to detect traffic light colors, depending on different type of traffic light. Their arrangement could be vertical or horizontal. So that's we see kind of 2 different integrations in traffic light recognition. And in land detection, we also find 4 machine learning models, and they are actually from 3 machine learning frameworks. So this relationship is much easier. They are interchangeable because developers might think they are different. They are trying out different type of machine learning models. So it's kind of interchangeable, and then developers can decide based on the configuration files. So also detection. So it actually involves every different sensors. There are a few models that are processing the sensors, making sense of the sensor data. And then they are using a fusion code, which is making decisions based on each of the models that corresponding to each of the sensors. And among, for example, LiDAR, for the LiDAR inputs, there are a few models, each corresponding to each type of different LiDARs. So there are varieties coming from different sensors, and there are also varieties coming from different sensors with different resolution type, for example. And the last in trajectory prediction. So this is another unique aspect. This is different from all the previous modules. In trajectory prediction, the models are working together in a way that different models will be utilized based on the type of status, the obstacle in. So for example, when a car is making turns, or a car is at the intersection versus a car is moving, there will be different type of models, which is to process that kind of input and make decisions. So far, so there are also machine learning models may have configurable threshold, which allows developers to easily configure that. So a quick take home is that Apollo used different type of sensors, different to interact with the real world. And they also have very different type of machine learning models together, and also very different type of integration models, which further complicates the quality assurance or testing we want to do on ADS. So leave that busy figure alone. And if we a quick summarize is that there are various type integrations of models and code and among models. So sometimes the machine learning models as the output will be input of the next machine learning models in the pipeline. And so often there will be code logic to integrate and process the output from various machine learning models. And also there could be dynamic configuration of the machine learning models based on the scenario when the car is in. We also find some interesting insights like about the concept we call safety nets. So the existence of safety nets make sure that we are not at a merely complete mercy of machine learning. We also have the more trustful code logic to protect the results from machine learning. So in case the machine learning are making ridiculous results or terrible results, and there are conflicts in the machine learning results among different models, there are code logic that is to serve as a safety net. For example, in traffic light detection, code is used to do some filtering based on the output of different machine learning models. And there are also algorithms to correct outputs of machine learning models as well. So this brings us to pay attention to this research gap. So while most of existing research focus on the unit testing of individual machine learning models, more research are definitely needed to testing at the module level with multiple consideration of multiple model or at the whole system level to do the quality assurance of model integration. Okay, so as I show you the different ways that machine learning models are working together in the ADS, and I'm going to briefly show you that how under-tested machine related code is in an ADS. So we have two sets of we did two experiments. So first one is do a performance simulation run. So simulation is the software high fidelity simulation. It takes data that somebody else recorded from a real test drive, and then use that to simulate, test the ADS in the simulator. And that's the first thing we did. And we find out that although, as I said, in ADS is a large-scale complex system, and we do not really expect the method level coverage or the function line level coverage is that outstanding. But comparatively speaking, the machine learning related components are much more tested than the other components in the system, which is some good news, some bad news. But overall, the test coverage is still considered low. And then we also try run the CI test come with Apollo. Which here is the branch, line, and the function coverage. As you may expect, it's always line function coverage is the highest, then come with line coverage and branch coverage. So overall, the machine learning related code is less tested, less executed by the test cases, and we are disposed for more testing efforts in that regard. Okay, so the simple conclusion we have is that there is room for improvement, although it is relatively much more tested region compared to non-machine learning related code in the 80s. So the next we spend a few minutes to briefly talk about our ongoing work on testing ADS. So we perform whole system testing of ADS, and we utilize the high fidelity simulator to generate the driving scenes for us. And then we just put ADS, which is Apollo, in the simulator, and we are testing, see how Apollo behaves, and we are trying to find collisions and crashes and all other bad consequences. So we apply fast testing to do this. And so fast testing will help us to really iteratively generate the driving scenes and based on some feedback. So feedback is the key of applying fast testing. And in this current status, we utilize various types of feedback, such as the coverage of the machine learning models in the obstacle detection module, which I explained earlier. It has crazy number 9 machine learning models from various different frameworks and how they work together. And then we also try different kind of metrics. We also try using the perception accuracy, which is something we calculate based on how Apollo behaves inside the simulator, and then compare with the Oracle, which is from the simulator directly. So I'm not going to dive more in detail in it, but I would like to share a few findings we have. So we find the collisions and other type of unexpected results. So collisions, one of the biggest category, first, as you may see, is that the model inside of the objects detection is not sufficient. They fail to detect pedestrians. So if you cannot see, then of course collision would happen. So this type is not really surprising, but we do find them. And the second I would like to share is often the business logic and the safety requirements in driving system like ADS is complicated. And although they have all type of safety nets, code logic inside to guarantee the safety, there still can have very bad consequences because it's a chain of failures, a sequence of failures happening. So one particular interesting case we find is that we find in the simulator, so there is somehow encoded requirement that the ADS would fail to when ADS failed to detect pedestrian when it's 15 meters away, ADS will plan the trajectory anyway. So if ADS is able to detect the pedestrian, so the planned trajectory were taken into consideration of the position of the pedestrian. However, in this case, we find that when it's over 15 meters away, the ADS failed to detect the pedestrian. And so as the trajectory plans may lead to a collision with the pedestrian. Then we find that within 15 meters, the action ADS, the logic, the action ADS would take when suddenly it detects the pedestrian is to stop. So it stops instead of replanning the trajectory. I think it makes sense. Instead of replanning the trajectory, it actually stops and waiting until ADS thinks the pedestrian is out of scope, is not on the way of the trajectory. So this leads to the ADS can be dangerous. So sometimes the ADS will tell the pedestrian and stop, and then tell again and stop. So these weird behaviors lead to the ADS is keeping a dangerous distance with the pedestrian. So in some cases, not every single scenario, but in some cases, like 10%, 1 out of 10, that the ADS may hit the pedestrian when actually doing the left turn. So it's like it's when we find these issues, we need to do a bit of diagnosis and debugging, and then we also combine the documents to understand under what scenarios that ADS is making such a decision. And together, this is what we find, what our diagnosis based on the collision we find. It's really represent a sequence of failures that sometimes so one single failure may not necessarily lead to collision, but all of them together may actually cause some severe consequences. So roll ahead. This is some just my experience sharing that we did on our current testing work. So even we tried apply fast testing to ADS, we still using coverage driven, for example, we still in overall the coverage is very low. So it calls for more coverage driven specialized technique for ADS. And also, as I show you 2 cases of collision we find, just doing diagnosis and understanding what is ADS behaving and whether it's behaving because defect in the code or it's insufficient of the models, it's very time consuming and it requires a lot of manual effort to go through the code and the logs, analyze logs, adding logs, and also read the documents come with ADS. Of course, in the process, we realized that logs are very helpful in that regard. Unfortunately, they are very lacking in the system. So whenever new problems come around and the new code in new modules, we might need to insert new logs to help us understand. So this definitely calls more comprehensive tool support for ADS development, for localization, diagnosis, and quality assurance. I just sum up a bit. So I explained to you that why we considered ADS is such a complicated system and also where the complication may come from. And after all, we show you the overview of the model interactions, model integrations inside of ADS, which is one industry-grade ADS system. And we show you the current testing effort is not enough, and we need to add a bit more extra support. And some cases we find with our developed testing techniques. Thank you for your attention and
Thank you so much for the interesting thought, questions. Thank you. So I have a question because as you said that you use machine learning models and one of the concerns for the researchers is the data set as well on which we train our models. So based on like you said that we have the problem with the collisions as well and in case of the faults as well in the model. So do you think that it's also because of the data you use to train? And if that's so, do you do any techniques to like clean your data or pre-process your data? Or these collisions or these errors are because of the problems within the ADS system? Or it can have something to do with the data set as well that you use because most of the researchers we use open source data. So like my question is, what do you think that what is the cause of the failure? More in the system or the data you use to train your system?
That's a very good question. So just to clarify, when I say one of the initial collisions we find is model insufficient, we already narrow down to make sure it's we do diagnosis ourselves and we make sure it's a model issues. And but to answer your question, we do not. Well, it's definitely come with data quality and how model is trained. Maybe that model architecture is not optimal, but we don't. I do not have first-hand knowledge of that data, unfortunately, because even it's an open source ADS, the Baidu release Apollo, they release the model, but we do not have access to the data sets, which is used to train the model. So we take them and analyze the input of output and make sure that it's the model problem for our analysis cases.
Okay, thank you so much.
Out of curiosity, why are you using like multiple different frameworks? Is it because of the usage of some pre-trained models and you're kind of using different off-the-shelf things plus custom things?
That's a very good question. So I did not choose which frameworks I want to work on. So the ADS developers, they choose adapt multiple frameworks. And most of the one of the major reasons we see after analyzing their commits and history is that it's a natural process in the project involvement. So I think one of the framework they actually use is Paddle. We know that's developed by the company itself. And before they start with Cafe, then they slowly migrate to TensorRT and Paddle. So it's more like their choice and with the up and down of the different type of frameworks. And also they see the model that's best developed by that framework. So it's a developer's choice. But we do have in that snapshot we analyze, for example, we do see the coexistence of multiple frameworks as well. But I mean, it could be a problem in terms of technical depth, which I think is another.
Right. So part of it is kind of used to be just like software engineering life cycle and
yes,
like that. But
yeah,
because I can imagine there's a lot of like pre-trained models that people can rely on. So I figured maybe that would be.
Yeah, it could be.
Thank you so much. I think we don't have more time, so we can pick up this chapter later. So let's thank you.
If you use this. Okay, I think this time. Yeah,
Okay, so the last session would be by Paulo Argini, who's an associate professor at National Institute of Informatics in Japan. His main research interests are related to research-based testing, fault-based testing, and automated repair. So he works on the fault localization and automated repair for deep neural networks. Oh.
Thank you. So sorry, it's a little bit loud, but I hope that doesn't cut too much. So yeah, I'm Paulo, and I'm from NII in Japan, and I'm going to present a joint work with Matthias. You hear me? With Matthias, my colleagues Matthias, Shawi, and Kuyuki. Yeah, I'm involved in the AI project that Lei already mentioned. So I will briefly introduce the project, and then I do an empirical study we did at the beginning of this project on fault localization for DNN, and then I show how we use this in our ongoing work. So yeah, this is the overall project. So AI stands for engineerable AI, and so that explains the E. And that's because there are, we have put a lot of emphasis on the engineering part. There are some people are here, so they will talk also here. And we have two main application domains. One is the medical domain. I cannot say too much on that, but if you have a question, I can. I'm not too much involved. And the other is instead autonomous driving. And yeah, this is a picture that you already saw from Lei before. So this is JST, is the Japanese grant agency, putting that AI can provide a lot of benefits, but putting different domains in terms of criticality and dependency. That is the why. We see the transportation is at top, and also healthcare is going in that direction. So that's why these are considered two of the main application domains of our project. But yeah, as I said, in my work and in our work, I focus on ADS, or transportation. So the original motivation of the project was this very general consideration. So if we look at what is considered as quality or quality assurance in machine learning in this case, usually we have some very overall assessment, like for example, total accuracy of test data. So you get 90% of accuracy. And usually, okay, you get an improvement, I get 90, 91, and 2, and so on. But if you check at traditional safety, usually we have in software engineering, usually faults are differentiated. And when you do safety assessment, you consider the different fault you may have. This is not even software, but you say, okay, if the wire, the break length is broken, okay, you have a given hazard, so there is a possible consequence of the fault, and for example, in this case, being hit, and there is a what you have an evaluation, so you can say, is this risk acceptable, or to what extent is acceptable, and okay, which should be the countermeasure. And so these were so the initial motivation of those who proposed the project. And what they did in the project is exactly doing this type of risk assessment also for machine learning, in particular in the autonomous driving domain. So what is a type of fault or error mode in machine learning? We are considering classification, so classification task in object recognition. So a different it's cut, but probably you can see. So different type of error modes are a different type of misclassification. So for example, you may misclassify a pedestrian for a cyclist, or the other way around, you may misclassify a cyclist for a pedestrian. And this occurs in particular scenes, usually when the pedestrian and the cyclist are in front of the car. And but which is the other in the two cases. So in one case, if you misclassify a pedestrian for a cyclist, you usually you don't brake. I mean, the car will apply not a strong brake because it's assumed a given behavior from the cyclist, and the consequence to the pedestrian. On the other hand, misclassifying a cyclist for a pedestrian leads to a braking that is not necessary. And yeah, what they did, this type of analysis was done with a consortium of industry. They assign what they call risk level, or some kind of severity of this type of misclassification. Where, of course, if in the pedestrian considered most critical, while unnecessary braking is still critical, but somehow a little bit less. Because, of course, can still lead to a collision, maybe with a car from behind, but if you need to decide, the first one is definitely more critical. So this is somehow what we are giving as requirements. The next step and what we are working on is how to improve our network based on this type of requirement, considering that we also have risk levels among the specification. So yeah, what we are given is input is a table like this with some assessment in which we have some misclassification rate and also some threshold that are considered somehow acceptable. And how we do this? We do using two classical software engineering techniques. Particularly, the first one is it says fault localization. So what we do is first we do fault localization on the network, and then given the result of fault localization, result of fault localization is a set of components of your network that are, let's say, suspicious, that are possibly responsible for the different misclassification. And then just based on those components, we freeze them and we try to do automated repair. And so try not to change all the network, but only try to change those particular components. Because this should avoid the fact that when you do retraining, everything changes, so you don't have fine grain control of your change. And yeah, as someone asked this morning, so are we applying classical software engineering techniques to machine learning? Yes, we are doing. But this is not novel to us because so there are recent papers also from Shinyu, or you know, on repair. And we are, so fault localization and automated repair are software engineering techniques, but when we apply them to a new domain, we need to be careful. We need to adapt and consider the peculiarities of the new domain. And so, yeah, I will, our initial study is particularly on the fault localization. And yeah, what we consider in our study, consider deep fault. Deep fault is not so recent anymore, but one of the first approaches to do fault localization for neural network. I will just try to explain also what is fault localization, just using this slide. So the idea that we take an input, a pre-trained network, and what we do is neuron spectrum analysis. So I will explain what is the spectrum. So for each neuron, we get the spectrum that tells how often a neuron is activated or not activated when you have a misclassification. So somehow characterizes the involvement of a neuron in the correct or non-correct behavior of the network. And so what you get as output is a list for all the neurons. You have a list of suspicious values, and usually what you take the topmost elements, and those are those that you want to repair, for example. And yeah, okay, this basically summarizes what I said. So that is a little cut, but basically you have all these components, AF, AN, they count basically every time the neuron is activated, not activated in a correct and non-correct classification, and they are aggregated with this measure. These are come from classic. This is spectrum-based localization in code, and yeah, this is Tarantula, OCI, star, and they are applied as they are basically in this context. Okay, that was what was proposed, but and this comes back to the original observation. So now we want to apply fault localization to DNN, but we should consider the peculiarities of DNN. And unfortunately, it's cut, but I can use this example. So here we have two misclassifications for the same data set. And here the default, so usually the way the default is applied to a given class, so two horses. And okay, here we have the misclassification of horse to a sheep and horse to a car. But if we check, then if the neurons are actually activated, we notice that in the misclassification from horse to a sheep, the suspicious neurons are activated while they're not activated in the misclassification to horse to a car. And so what does it mean? It means that when we did fault localization, somehow the first misclassification hide the second misclassification. So in the end, you have two types of faults in your data set, but you're mixing together, and your fault localization result only show one type of fault. And this occurs also in classical software, but there is a little bit less problematic. So there they can better somehow discriminate between the two. Here instead, you may simply miss one type of fault. So our idea of the study was, okay, is this masking effect, so the granularity with which we do fault localization, does it matter? Because, I mean, for us, fault localization is the input of our repair. So we want to check the quality of our result. And yeah, we designed a study. Yeah, you can see, but we took MNIST and Cipher and 6 network. And what we did, we given all the data, we divided the data in for each class. And we consider all the misclassification. So all the way that you can misclassify one particular class. And you apply default in 2 ways. Either in the classical way, in which you consider each class individually. So you all together. So I check all the results of class 3, for example. I take all the data of class 3, of class 2. Or default granular, that is the top, in which you take each type of misclassification individually. So you consider to do photolization for 1 to 2, 1 to 3, and so on. Of course, it's a much more expensive way of doing photolization because you need to do 90 times against 10. But yeah, we want to see to what extent we have this problem of masking, and if we need to consider this in our repair. And yeah, okay, then I will show how we check the quality of our result. And yeah, here we can take different. So when you do photolization, you can decide how many neurons to consider. So we consider a different number of top neurons in the suspicious list. Yeah, we had 3 questions. Basically, the first question is that I will call the techniques deep fold and deep fold GR, default granular. So do they find the same neurons or different neurons? So is there really a difference in the photolization result? And yeah, this is just visualized, but basically what we do is we consider all the identified neurons by deep fold. That is, deep fold is each of these lines because for all this classification, while deep fold granular is each cell because it's done for each combination. And 8 of this is the site of intersection. So the higher is the weight, the more they found the same neurons. And yeah, this we did for the 2. So we found that there are 2 problems. So we have the masking effect occurs, but occurs in 2 ways. In the first way, you have there that you have a high intersection for one misclassification. For example, there 1 to 5. So for 1 to 5, default was able to find the same neurons of default granular. But for the other, the intersection is low, meaning that default just disregards those misclassifications. So if you use default as it is, you will not consider those type of faults. So there will be a mask in your result. And that is problematic, but also the second is somehow problematic, in which actually the intersection is low for all the misclassification, meaning that to some extent, default was able to identify suspicious neurons, but these are somehow distributed across the different classes. So you don't have a precise characterization of each fault of each misclassification. And are these, the second question is that are these neurons really faulty? How to do this? Yeah, we took, basically we applied the same technique applied in the original paper. We took the neurons identified as suspicious and we synthesized images by trying to maximize, increase the activation function of the suspicious neuron. So this is the same technique explained in the paper. And yeah, we use the technique plus random. So we randomly generated modified images. And indeed, we see that both default and granular, they actually identify 40 neurons because they can generate images having higher loss and lower accuracy. So they are really those responsible for this classification. And the third research question was, but is it true that deep photogranular find more granular fault? Because we saw that the results are different. So the fault localization results are different, but does it really mean that they are different faults? Yes, because here, basically, those hash maps, so they show how many images for each misclassification we can generate starting from deep fault and deep fault granular. And yeah, we see that in deep fault, we somehow miss some misclassification. So really, not finding those neurons means that we couldn't then generate fault images of that misclassification. So that in the end really confirms that doing fault localization at the granular level is better. And yeah, this was confirmed by the statistical. Okay, that was somehow our original initial study to basically say how we should do fault localization. And our answer that okay, we need to do fault localization for each type of misclassification that somehow introduce new problems. Because now what we have is that there on your left, you have our requirements. So we have all the misclassification given by our industry partner. And yeah, we do fault localization for each of them. And what we get different groups of suspicious components. But now the question is how to repair. So, because there are already techniques doing repair for just a single set of suspicious components, but how to consider all these suspicious components together. Yeah, luckily, part is still visible. So, because the fact that these set of suspicious components could be either disjoint or that they could have some intersection. And this creates different issues. So this is our ongoing work. But the problem that when we have a shared component, like yeah, that one is shared by 2 misclassification or by 3, how to modify it? Because okay, here when I talk about components, I be more specific. Now for us are weights. So I have a specific weight that I need to change to fix a misclassification. But the fact that in order to fix the weight for a misclassification, I may, I don't know, bring it to 2 or increase it. For fixing another misclassification, I should decrease it, for example. And that clearly shows the trade-off existing between the 2 misclassifications. So in the end, maybe you cannot repair both misclassification and you need to decide. But sometimes, even if the weights are not shared, but maybe one is suspicious for one misclassification, so I need to change it, but it's already optimal for another misclassification. So changing that introduces some degradation in another class. So these are actually, I'm not giving any answers. So okay, we are working on this, but the idea is that there is a trade-off. So in the end, you cannot repair the mode, but we have the risk levels. So if you remember at the beginning, so our requirement of the different misclassification, they come with different type of risk levels. And so when we need to decide in the repair which one to prioritize, yeah, we will resort to the risk level. So we will give higher priority to misclassification having higher risk. Of course, if we can repair the more, it's better, but if really we find some point that we cannot do, we will try to follow the risk level. And yeah, actually we have now some experiments showing that it's quite, we can do it. So yeah, to conclude, we saw that yeah, photoization is used to identify the suspicion neuron to repair, but blindly applying photoization from code it may not work, and this maybe can apply to other transfer that we do from software engineering to machine learning. So we need to consider how to do it, and we show that we should do it in a granular way to get better results. And yeah, our ongoing work and what we are working now is to repair the DNN considering the granular result. And let's conclude my talk. Sorry for the cut.
So thank you, Paolo, for the interesting talk.
So question from audience, maybe not decide, okay.
Just validating my understanding, this analysis happens post-training, is that correct? Yes, and so based on, the evaluation that you do on the neuron, it's like given a certain class, we're seeing the misclassification as a result of the activity of a set of neurons or neuron that you're localizing fault. I was wondering if that could be real during training, and that could be integrated as part of the training process. So you're imposing like sort of prior that you're learning, kind of meta learning, and you improve the training process at one point.
Yeah, actually, it's a very great question because I actually am not the expert here of photovision, but yeah, my colleague showed this. And I think actually it did, I mean, he was trying to do exactly this, like do photorealization during training, trying to somehow identify which neurons are somehow responsible for PJ. And the fact that doesn't really scale, it's kind of expensive. So right now, yeah, we just do it as a kind of study. We still need to prepare a bunch of data. Basically, we have this photorealization result of each photo. But yeah, that would be the first step to understand whether these patterns already occurs during the training. Because then, I mean, you may do, I don't know, dropping or something on these neurons already during the training. That would be, yeah, that's exactly what. But at the current stage, it's kind of expensive. I mean, we should also understand when to do it, on which layers to do. Because another thing there, where to do. Now, usually, when you do repair, you do on the last layer. But yeah, maybe you can also do some hidden layers. So there are, but yeah, definitely that. Now, exactly, we're doing more or less a study because it's too costly. But if we see some interesting results, then we're going to try to integrate it with it.
Yep, that's very exciting. Thanks.
So to follow up on this, right? Like during training, you may put some specification with one batch. But then if you repair, then we send the next batch. Normally the weight keeps being updated in the training process. So how do you repair in this case? Okay, are you modifying the structure of the networks? Or are you just freezing some of it? What would you like?
No, I mean, the short answer that they are, yeah, I mean, no, in the sense that it's not, but I think that there was also more to see, like there is some neuron that keeps on remaining among the fault, no matter, for example, which way you can use, or, but I mean,
So you can look at the distribution.
It's more than like the 10, so maybe doing, I don't know, every 10 or whatever. So now the study was not to see, because now we are not at the level of doing anything with the community, what happens. And if you see that something happens, that's really doing things, photorealization result are stable, or either maybe are unstable, because maybe we see that I don't know, there are two, I mean, there are two neurons that keep on switching. I mean, either one is faulty or the other, meaning there is some kind of development. But yeah, this, given the result, then we should try to understand how to do during training. Yeah, the answer, I really don't know how we can.
Yeah, so right now, this method included in the quality assurance workflow? How does the cost compare to the training cost? And my question is very related to that. How do you foresee this moving into more debugging or training?
Do you mean these work or? Sorry?
No, but right now, just the cost, how does the cost in terms of compute time compare? Or is that does compare to the cost of training?
I'm doing all these repair. No, it's yeah, it's more expensive. You know, I don't have. It's more not the full duration part. The project is relatively fast. It's more the repair part because the repair part. Yeah. In the end, we do repair with search. So we apply search algorithm like genetic algorithm, but it's in the order of some tens of millions. But the fact actually exploiting in particular since it is we freeze the network and usually we just modify the last layer. Or what we can do, we can like remove this part of the network, so save. So actually, I don't know technical idea, but the student basically just made a slice of the network and only apply the part that we are changing with the weight. And that saves a lot of time during the search. So but yeah.
Any other questions you have?
Hi. So probably this question is already similar to what everyone's asking. So you know that from these some neurons are bad and some neurons are good. And this is a multi-label classification problem. So say for a given label, you already know these are the bad neurons. And most of the time, there is already a problem. And if you know that, then would it have been better if you, from your cognitive repair perspective, you just freeze those neurons for that given label? Say that, well, if I see, if I'm expecting this kind of labels for these test cases, let me see how I can freeze these neurons and put that in the better performance. So thinking of that problem.
Yeah, I think correctly, and because I didn't say too much about what we are doing now, but so actually what we are doing now is for each of these sets, basically we are doing different repairs. And what we get, basically we have a network specializing for each of these. So we call it PH. And that, okay, then we have the problem that we have a set of 10 networks or whatever for all these classification. And okay, at first we were thinking to try some voting mechanism. So because we know that one network is like yes step of that classification for that particular class. So, but what we do now is more, we have the 10 networks, and we know the single repairs that are necessary, and then we have another phase later trying to merge these single fix. So somehow I know what is the best for each of them, but then I try to find a single fix that somehow takes into account all these fix without degrading one. And that is exactly the point in which we consider the risk level. So when I fix for each of them, I discard the risk level. I find the best network I can get for that particular specification. But when I put them together, that is when the trade-off occurs. Because I need to decide, okay, which network matters more. And that we consider risk level. In the end, I will try to favor those with higher risk level, if we need to. But that,
thank you.
So we're going to have a coffee break, right? And So those feel again as trees, yeah. So probably we say down the hall.
Okay. Yeah, then. We'll see what happens. Yeah. We have one. Historically, yes. Yes, we're. It was very warm. Yeah, I just. Yeah, I just. Oh. Thank you.
I was stuck. Okay, so that is going to be the background. How blinding is this? So Melanie will speak in French.
She can.
So she will. I spoke to her.
So you can
So,
interpret.
so if needed, I roles such as team leads, entrepreneurs, policymakers, and professors. After him, we have Gabriela Nicolescu, which is the director of the Department of Computer Software Engineering at Polytechnique Montreal, otherwise known as GEJL. She has been working at Polytechnique since 2003. And her research interests are in the field of design methodology, programming, and security for systems with advanced technologies such as 3D multiprocessor, system on chip, integrating liquid cooling optical networks. She's published 5 books, and she's the author of more than 100 articles in journals, international conferences, and book chapters. We have next to her Melanie Buss, who holds a diploma in training engineering from the University of Paris 1 Pantheon-Sorbonne and a DESS in training management from the University of Sherbrooke. She developed her training expertise through her career at the National Institute of Agricultural Research in France, then working for organizations in the banking and university. In this regard, she held a position of Director of Continuing Education at the Faculty of Continuing Education at the University of Montreal, and she's worked to promote the ICT sector and its workforce, as well as the digital transformation of the Quebec economy in general. She is currently the Training Director at IVADO, a Montreal institute that is heavily centered around data and its users. And finally, but not least, Philippe Mollaret, who is VP Research and Technology at Thales Digital Solutions, which is a center to support the Thales Group digital transformation on the backbone of Montreal's digital intelligence ecosystem. He's a co-founder of the Cort AIX AI Research Lab at CBS. Occasionally, he teaches technology and innovation management at Polytechnique right here in Montreal. And he's also a member of IVADO's Technology Transfer Committee and Prompt Board of Directors. Without further ado, I propose that we start the panel with a small question from myself, and then if you have any questions as follow-up or anything else, feel free to raise your hand, and the panelists will try to answer your questions and give their perspectives on their view of what the future for SE4AI represents. So my first question would be, have you noticed or do you foresee any gaps between training, schooling, or otherwise, depending if you're taking an industrial perspective or academic perspective, between the practice and the world in the world of SE4AI, between the practice and what is currently being trained? So have you noticed current gaps, or do you foresee future gaps coming between training and SE4AI? So whichever one of you wants to start, feel free to take your mics and go.
I can start, but I'm going to switch in French. I'm sorry, because I'm more confident in French. But oui, on m'entend bien? Il faut que je le prenne. Ok. Oui, en fait, ce qu'on observe du point de vue chez Ivado, plutôt du point de vue industriel, ce qui est important, je pense, c'est que va y avoir probablement des gaps à combler, du rehaussement de compétences à faire pour les ingénieurs qui sont déjà sur le marché du travail depuis quelques temps. Et pour lesquels, c'est ça, va y avoir des programmes de upskilling à développer. Et c'est typiquement ce qu'on est en train de commencer à réfléchir avec SEMLA. Mais je vous dirais, c'est ça, je pense qu'au niveau de la relève, il y a déjà pas mal de choses. La relève étant les étudiants, on voit que, et puis ma collègue pourra en parler, il y a déjà beaucoup de choses qui vont être prises en charge. Mais la question va notamment se poser, c'est ça, pour les ingénieurs déjà sur le marché du travail.
I'm going to do a quick translation, live translation. I'm sorry if I don't get exactly anything right, but what was proposed here is that current generations of engineers that are undergoing training right now may be at the point of technology when they graduate, but current engineers in the field will likely need to upscale their current education. And so programs will be offered by places such as IVADO to help these engineers proceed further.
Yes, I think it's a very valid point. We are like in a transition. We are forming continuously engineers, and yeah, we make efforts at Polytechnique. We collaborate together and to be able to fulfill these gaps and to decrease gradually this actual concern. I think the research projects are also a way to
to collaborate between academia and industrials. And this is a way to understand better how we form the students, and we discuss continuously with the industrial, with the market, and we understand the needs and what are the preoccupations. So this is also a way to make the transition and form. We are forming in this way the future employees or researchers in the company. So yeah, the gap is here, there, but we have several efforts. We will make together some programs. We opened also a professional master in AI and Polytechnic in this perspective, because it's a professional master. So during this master, the students have 1 trimester at least to have an industrial internship. So this helps to understand better, and they are taught in this direction.
So yeah, maybe I'll just add, and maybe just to start, I'll reframe your question slightly, or what I will answer will be slightly different. Is maybe not so much about the gaps, but I think about the needs, right? So Quebec just recently, this past year in their budget, announced some $2.4 billion for training in engineering. Part of this, for those who don't know, amongst many disciplines, but engineering students, undergraduate students now in Quebec will be paid to do their degree, right? So 3-year degrees will, people who complete a 3-year engineering degree will be paid $15,000, and 4-year degrees will be $20,000. And they're also investing another 500 positions, faculty positions across Quebec over the next 5 years. So, what does that mean? I mean, obviously, this is not a spiel for the government. I don't work for the government, the Quebec government either, but I think it's showing that the government is noticing, society is noticing that we really need engineers, right? And I don't think that the traditional engineer that we think of, right, somebody who's wearing the iron ring and, just did their math studies, is really what society needs today. I think there's a lot more to that. There is, whether it is about use, it's about how these systems interact with users, whether there are social implications. I think we're hearing a lot of talks today about responsible AI, explainable AI. I think these concepts go well beyond just the technicals, right? So if you think, very simply about explainable AI, well, who are you explaining it to, right? And I doubt that it's engineers on the other side that will be just explaining this to. So I think it's not so much about, I don't want to speak about the gaps, but I think what are the needs? And I think the future, whether it be engineers or trainees, they need to be well-rounded. They need to think about all aspects, including the engineering piece, because I think we're seeing governments and society expecting more from us as well. And I'm happy to talk a little bit about the SE for AI, but I won't do it now. But I'm happy to talk about that program, because I think that program, although it's led by us, it's really a program where we try to instill these things at the heart of it. And I think we see a lot of support from industry for such programs. Maybe over to Philippe.
I want to approach this a different way than from the academic stand, meaning that most engineering that we have today, and you alluded to it, is I would call it deterministic engineering, where whatever you design, you know the outcome. Where with AI, we have the black box concept. And the gap for me is between the two. How do you transform the engineering approach from deterministic, where everything can be tested, proven, demonstrated, and everything? And we've seen some presentation today about getting there. And that's where the biggest gap is for me, to be able to hire future engineers. I don't want masters and PhDs in the engineering development. I want engineers. Hire engineers that have the tools, the means to perform or demonstrate the same way or close to the same way we were doing in deterministic engineering, to be able to show to the future user, to the future authorities of approval, to the future clients, that whatever they get, whatever they buy, they can trust, they have confidence in it, and they can demonstrate to whoever it applies to, because Thales is designing a critical system in aircrafts, in ships, and whatever. So the standard user, you and me, we don't see the solution, but we get the impact of the solution when we board an airplane. Okay, and we trust it's going to fly safe. Today, we can demonstrate that to 10⁻⁹ per flight hours. With an AI on board, we don't know how to do that. So for me, the gap is there.
Do you have any questions from the audience?
So I guess to put on what both of you just sort of alluded to, this idea from an industrial perspective that people finish their bachelor's in engineering, but that they have a new tool set to be able to tackle this, how AI gets integrated into systems. Same time, the government's putting a lot of money in, we're trying to get initiatives to figure out how we teach this in an ethical way. Do you feel that as analysts that the sphere of machine learning, working with machine learning is going to become an engineering discipline onto itself? You know, sort of the same way that software engineering has exploded since I did my bachelor's. Do we feel that there'll be like a niche of AI engineers and we'll all understand what that is the same way we understand what a chemical engineer is, you know, in the future compared to now? Like we're cutting a new path.
If you want, I can take a first crack at
Yeah,
it.
yeah, go.
So maybe the short answer is no, because I don't think it's very vertical, right? I think if you look today, whether it's in chemical engineering, whether it's in mechanical engineering, whether it's in, of course, computer science or software engineering, or any engineering discipline that you want to, building engineering, civil engineering, you see machine learning there, you see AI there. So I don't think it's a vertical, you know, I really think it's more of a cross-cutting horizontal. Yeah, and maybe just to add to that, right? I think if you think at the undergraduate level, what I see is I see the need and the proliferation of different aspects related to machine learning throughout the curriculum, right? So even now, I would say most students in their fourth year want to do an AI course. That's by far our most oversubscribed course, or a machine learning course, but it's honestly, it's not enough at that stage, and it's almost too late. So we're starting to introduce, you know, courses about data and about different aspects, and we need the requirements need to take these, you know, our requirements courses need to think about machine learning systems and AI systems much earlier and throughout the program, so people can really reinforce the concepts, right? It's not something that you're going to see as a course like probably a lot of us did in our last year, and that's it.
And I think it's going to go along what my colleague just said, is that in the industry, more and more what we develop is not data-driven AI or machine learning AI. We're designing hybrid AI. It's between what we call symbolic AI, which is what engineering already know how to do, and data-driven AI, and you combine the two. You do the training to apply to a symbolic model. So specializing into AI engineering, like my colleague said, won't answer that, because hybrid AI is a mix of whatever engineering can do. You just have to add the AI component to it.
Thank you for your fantastic comments on this, and I really appreciate how the Quebec government is investing in this kind of initiative for undergraduate education. So we do in Ontario, especially in a lot of universities, we do have this collaborative specialization programs, both for at the graduate level as well as the graduate level now beginning to show up. How do you see this ecosystem scaling up from just Quebec to either Ontario and the nearby provinces, or Canada in general, the federal level? Any thoughts on this?
Since I made the comment, I guess I have to answer. So as I said, I don't, you know, represent the government or anything like that. I think it's an excellent initiative, and I'm a big fan of it. But I mean, I think all provinces are trying to scale up, right? I don't think it's a Quebec specific problem or solution or whatever you want to call it. However, I think whenever you talk about AI, Montreal is sort of a center of gravity, or it has a very strong magnetic forces. And I think this is why the investment is not just in AI, but in all of engineering, because now we've moved from the stage where, okay, we have the AI presence, we are the center, or we have strong magnetic forces in Quebec, to how can we actually apply this, right? And I think when it comes to application, you need engineers across all disciplines. Now, how does this affect other provinces? I don't know, honestly, but I think it's an excellent move. I think it's a very necessary move. And I hope that other governments will do the same, right? Now, every province has their own priorities, their own realities. I don't know, maybe in Ontario, I know the investment is not as large in education as we are here, so we're sort of lucky in Quebec. But I hope that this will serve as an example for other provinces as well.
Thanks, panel, for all the discussion. So I have a question about how do we add in the AI component into the current curriculum for engineering? Should we introduce the AI component into each of the software engineering courses? Like, how do we do software testing and then AI as a special kind of software, or should it be in the machine learning course that introduces the engineering rigorous guidelines into it? Thank you.
Before the academics answer to that, because it's a tough question for academics to answer. As far as the industry need to introduce new training, new knowledge in the engineering courses, it is important to understand for what hand we do that. And I've done it already in Quebec with Concordia, with Polytechnique, ETS, where I introduced a specialization in aerospace engineering for onboard systems, not for the structural, not for the engine part, but for everything else that is digitally driven or electrically driven. So I think we can do something similar to that, where bringing AI on board, because a lot of solutions will not be just AI from top to bottom. There will be AI integrated, or solutions integrated with AI. So you need a system engineering with AI. And I would appreciate if somebody can generate a cursus where onboarding AI would be part of mechanical engineering, electrical engineering, software engineering, because that's where new hires in the companies are lacking the most. They have the basic understanding, but the fact that everything, all what they design goes into a system and needs to apply to a system, it's a difficult step to grow into.
Yeah, to complete as an academic vision, AI is, as it was said, and is right, AI is integrated with other disciplines. And this is, I think, is the thing that it's very important, and we notice. So the way we can do it, and of course, it's a continuous evolution. We have kind of what we call integration projects, where in the only project, the students at engineering degree, they will integrate the knowledge from other classes, even from other disciplines. So I think if we collaborate with the industrials and researchers, we are able to, if we set up these projects in a right way, this may be a possibility to form better students, and they are more exposed to the applicability, and they saw the theory in classes. Ideally, we can make integration projects between departments. We are in reflection at Polytechnique, but I think this can help. I agree with this multidisciplinarity, important components in AI.
Maybe if I can just add something, because I think this is such an excellent question. So I think the way that we see it, at least at the university level, is slightly different, and it really is context sort of, or degree specific. So when we look at our undergraduate students, I think, you have students who are trying to specialize. They're not necessarily computer scientists, but maybe they're trying to specialize, let's say in building engineering. Okay, so well, most buildings today are smart buildings, right? And you have a bunch of sensors and everybody's, looking at flow and trying to optimize energy use, et cetera, right? So I think these students are not necessarily interested in having, AI throughout their entire degree. They're really building engineering students, but they would like to know, the conversation, they would like to understand the conversations that are happening. So I think, at that level, it really depends on your degree or your specialization, right? Then you have the professional masters or our master's students, and they're typically students who have already gone through, their degrees. They're really looking for, courses in the area. They want probably their next step is to go out into the job market. So they want to make sure that they're able to work in that area, right? And then you have our research-based students who are the PhDs and the masters, who I think have a different concentration. So they would really like to probably specialize, right? And so such students not only want courses, but they also want to be able to do research in that area, maybe advance the state of the art, whatever their field is, right? So I think it really, depends on this, the degree level, and then there's another axis to it, which is what you're studying. And I want to loop back to a comment that was made by Melanie earlier on. I think a lot of industry now is looking at this retraining of their workforce, right? So this is just a sample that I'm aware of, right? But at Concordia, we did a training program with Ericsson, where they brought 140 of their employees, I think. They received AI training, but all the problems, Ericsson did not want problems that we brought to the table. All the problems came from the employees, right? Because they wanted to make sure that whatever these students or employees were being taught was actually applicable to Ericsson, right? They didn't care that, it is a data set from GitHub that we give them, right? And I feel like there's more and more of that. Companies want more, their employee force to be trained, but they want it to be specific to their domain or their company. At least that's one example. I'm sure there's, other examples there, but that's one example that we're seeing. So really varied, I don't think these employees have time to spend and to go through an entire degree. So that's what the companies are doing, that we're seeing.
It's true. And
No. Go ahead.
Just to complete, that is true. And another example is a certificate prepared at the university. These certificates are kind of programs that are lighter. You don't obtain an engineering degree, but you have a number of classes that help you to integrate the field, and it can be in AI. We had a very successful example in other fields, but probably certificates in AI.
Yeah.
Sorry.
Non, it's okay. Oui, en fait, pour rebondir aussi sur ce que disait Emad, je pense que chez Ivado, on a vraiment cette préoccupation, comme n'importe qui aujourd'hui dans la salle, de faciliter l'adoption de l'IA. Puis on sait bien que ça va passer par différents aspects. Mais ce que je voulais partager aussi par rapport à ça, c'est qu'on réfléchit beaucoup par rapport à des programmes ou des modules complémentaires, justement, de formation en IA pour des gens qui sont dans d'autres domaines que l'IA, que des étudiants en IA. On pense ici à des biologistes notamment. Puis notre approche, c'est de se dire, OK, et ça rejoint la question que vous posiez tout à l'heure, c'est de se dire quel complément de formation on peut donner au cursus académique, justement, qui permettrait à ces personnes-là d'être finalement la relève, d'être les ambassadeurs de l'IA dans le marché du travail de demain. Puis, effectivement, ce qu'on voit aussi beaucoup, c'est que ça prend des compétences de traducteur, finalement. Je pense qu'aujourd'hui, c'est des types de postes qui nécessitent d'avoir comme vraiment un double cerveau, j'ai envie de dire, même si on est bicéphale, là, mais de vraiment se dire, j'ai une compétence technique, mais je suis aussi capable d'avoir comme une expertise métier ou autre aussi. Bref, on réfléchit beaucoup à des programmes de traducteurs analytiques bien souvent.
Thank you so much for that. I totally agree with Moses. And is taking the approach where computer science took in the recent past, where we see journalists writing complex code programs to do certain research, investigative journalism. Lawyers are writing programs, doctors are doing it for themselves. But this multidisciplinarity also brings in complexity, because who takes responsible, like accountability? Would there be an engineering board, as we have an engineering board for software engineers, for mechanical engineers, that can put regulations, that can coordinate activities in multidisciplinarity? We cannot limit the knowledge because it's meant for everyone. But then we still need a kind of coordination. So who takes that role of coordination?
Why should it be any different than what's being applied today to all the different standard engineering disciplines? When you are training from work into AI, anyway, you have to follow the company standard of development, design, and ownership and responsibility toward the public. And when you have already, when you went through your engineering degree, you're also committed to that. So I'm not too scared about people getting AI training and abusing it the way you suggest, becoming not responsible or whatever, but they are professional to start with. Of course, there will be always people that are, trying to fraud or whatever, do something else with AI, but that exists with any other technology. So I don't think we're in any different situation with AI.
Hi, here's the Zhi from the of our product. My question is about what the IT can do for compute. As we know, AI is driven by data, algorithm, and the power. As you have mentioned that we have to do something in algorithm and the data-driven method by some SE method. But for the compute, since we are controlled by compute companies, 90% of us will use CUDA, or on other level, 90% of us will use the flow or code or something else, Anyway, what can we do about the CUDA, the flow, the code, use some SE method to do that? What can we do to affect them if we found some problem? We are not the employee of these companies. On the other hand, as a student or engineer, not working in that companies, do we need to learn about how to use them and how to study them to improve us, or we just need to know how to use them to realize our algorithm and our data?
You like to, if you ask the students, you just need to know how to use them to get the grade. That's all. No, jokes aside, yeah, I don't know. That's a very complex question. The only thing I can say perhaps is you always need to be reliable or at least handle failure, right? And yeah, we depend on a lot of software in the AI world, but I don't think we're unique, right? So if you look at any other software-driven industry, whatever it is, hydroelectricity, anything, right? Rogers, we all know the example, right? That's a telecommunication company that heavily depends on software. So I think these things happen and are expected, whether it's AI or not. I think the key is just that we need to be able to handle these failures. And we're seeing this more and more, and I think this is becoming more and more important in the software engineering world, not just the AI world. You've probably heard the term supply chain, right? The software supply chain. This is becoming more and more important, and it's because of exactly what you've mentioned, right? So I don't think it's specifically an AI problem. I think it's really maybe a core software engineering problem. But the only thing you can really do is just try to handle for failure, right? I think that's what you were asking. Did I at least attempt to answer your question? Okay. Okay, good.
I have a question for all of you. It's pointed differently at each of you. So I would like for each of you to, in this case, I would like you to take the SC for AI position and not the director of the department position, because I think we can have that with Gabriella. But how do you see each of your specific domains furthering the future of students? So how can each of your industries or academic circles further educate students in the next 5 years? What do you see as being needed in the next 5 years? And for the industry, what do you see being needed in the next 5 years that students will need to know and the students in the room should aim to at least be knowledgeable about that time they graduate?
Would you like to start? I talked a lot already.
Okay, so yeah, as trainers and teachers in our department, I think we have an important role because we form the future engineers, we form the future highly qualified personnel. So yeah, it's important to teach to the students all the technical aspects, of course, and to stay continuously informed, up to date, to search about the society needs, the industry needs, and to form for the right objective and in the right direction. And for this, we have to be in continuously in communication and in collaboration with all the ecosystem that is there. So we have to be open and to work together for sure. And doing this, I think we have to teach also the students to work together and to be in teams, because we talk so much today about multidisciplinarity and how to work between different fields. So I think teaching them also about this reality that today all the systems, as we know, all the systems integrate so many aspects, from the security to the software to the hardware to the supply chain, which is very important, confidence. So to be able to teach them about all these concerns and these new perspectives that we have, and yeah, that's I think collaboration and opening is very important. Of course, aside the very strong technical skills.
Dans la continuité de ce qui a été dit, je pense que c'est ça au niveau des compétences techniques, elles vont être bien couvertes, mais ça va être toutes justement les soft skills. On pense ici aussi à bien connaître les aspects, les impacts sociaux, les aspects légaux. Puis je pense que oui, la collaboration, ça va être, on sait que c'est déjà une compétence importante, mais plus que jamais aussi pour les raisons qu'on a déjà évoquées, ça va être très important de garder ça, puis de développer sans doute un esprit de se former tout au long de la vie. On sait que on est dans des systèmes quand même assez complexes qui évoluent peut-être plus rapidement que ceux qu'on connaissait jusque-là. Donc, ça va être vraiment de développer aussi cette habitude d'aller se former de manière continue. Donc, voilà.
I'm going to give you the last talk. I have two answers from the industry point of view. The first answer is not a 5-year outlook, it's the 15-20-year outlook, where we need to instill more science and technology teaching earlier on at school, such that these people can move on to the engineering training. I think we have to reverse a little bit the tendency today where this is not happening enough. The second point is that especially in Quebec, and my colleague at the other end of the table mentioned that Quebec is different in many ways. We tend to form an industry consortium around a given problem. So we have the aerospace consortium, you have the same thing for agriculture and so on, but we're creating one around what we call trusted AI and trusted AI for industry adoption. And with that, we make the claim that we will use a specific MyTax program that will allow young graduates from master and PhD to be exposed to industry problem in the Confiance AI consortium for at least 2 years. And that will bring them to understanding that you can do fundamental research, but you can also do industrial research. And having gone through the Confiance AI program, you have something to put on your resume that the industry that of your choice will understand what you've done. And that's my answer for this part of the question.
So, so maybe I'll take like 30 seconds just to tell you about the SE for AI kind of CREATE program. So 2 years ago, a group of troublemakers, Jinchi was one of them up here, myself, Foods, and a few others got together and put together this NSERC CREATE proposal. And the goal was very simple. We have software engineers who are great. We have people who are amazing at machine learning or AI, but what we really wanted to create was this intersection. So this is why it's called SE for AI. And so there were some core components in this training program. One of them is sort of the base, the bread and butter kind of course on engineering AI systems. So this was really a lens, or this is a lens from a software engineering perspective on these AI systems. So they learn about the requirements and many topics that you've heard about today. So I'll save you the details. But the other course, which is super interesting, I think, is a course that's taught by a social scientist on the social aspects of AI systems. And so our software engineering students were forced to take this course. It's a core mandatory course in the program. And I think it's been really an eye-opener. I know there's some students here. I don't want to put you on the spot, but if you want to speak about it, I would welcome you to do that. So this is a program that we put together. There's of course many other components. One of them was a collaboration with Ivado to put some of our students in industry and collaborate with industry. But I think the other part that I'm most excited about is there is what we call professional development modules. And one of these modules is on innovation and entrepreneurship. And I think the blessing and the curse of software engineering and AI is the fact that we're very applied, right? Yet we do a lot of research, we do a lot of papers, maybe we build tools, but how those tools actually turn into spin-off companies. Can we turn Montreal into the next Silicon Valley? Can we lure VCs to come here and invest in companies? And I don't think we do enough of that, right? So this is a piece that, I personally would like to focus on a lot because I think we do a great job on the research side. Now we're doing a great job even on the multidisciplinary side. But how can we get the young generation, how can we get VCs to come here and invest in our companies? That's the hard part. I think that's the part that we don't do in so well yet. We really have a very good ground, right? We have a lot of top universities. We have a lot of experts here. We have a lot of companies that come and set up labs here, right? Google, Microsoft, the whole slew, they're all here. So this is, I think, a piece that I would like to see in the next, let's say, 5 to 10 years. Philippe says we need to work on the high school students. I say we need to work on the university students and get them, into startups.
Do you have any last questions? We have time for one more question. Do you have someone else with a new question? Okay.
Nice story, so I think you alluded to the interesting social science aspect, that there's this need and you talked about two things. There's this need to talk about the ethics, to talk about all that this morning. Do you think that the ethics of AI becomes sort of a central tenet of what we teach engineers, the same way we teach like civil engineers not to design bridges that fall down? Do you think that's going to become a central tenet of our education, both for retraining existing engineers, the way industry puts into practice, and the way we teach it? Are we heading in that direction? Or are we doing that?
I don't know if any of the students want to try and take a crack at this. I don't want to put you on the spot, but the short answer is, of course, and I think it's beyond just ethics, right? So now we're thinking about human rights. We're talking about social equity. There's so much that goes on in that course. I wish Tanya was here because she's the one who teaches that, and she's much more elaborate than I am. But I don't know if any of the students want to say a word about that. Pierre Olivier, I'm looking at you. Sure, or Antonio, yeah, I'm going to say a word about that.
But before we get there, in the Confiance AI program that we're putting up together, we're putting together to start up next year, we not only want to address ethical AI, we want to address sustainable AI, responsible AI, safe and secure AI. And it's not a soft skill we want to address. We want to address the engineering tools that will allow the engineer to develop meeting ethical concerns and sustainable concerns. Because right now it's all the Montreal AI Charter, it's all philosophical understanding, soft understanding where we need to go. How do you put it in practice for the engineers to develop alongside with that? And that's what one of our aim, and Futsu and his team are excellent at trying to drive that into the technology elements that are needed to drive ethical AI and the rest.
Yeah, I will say that in example, one of the courses in social aspect, we discussed about the integration of artificial intelligence in politics. So how a government can use artificial intelligence for the benefits and control population that happen in some societies. But this kind of discussion we don't usually see in other courses. So this is also we discussed the artificial intelligence as a tool for manipulated people, a tool for election. So it's not only giving solutions from the point of view of computer science, it's also from the point of view of society, politics.
So thanks for the discussion. I agree with everything that was discussed. I just want to maybe do a cheap plug because you guys gave the opportunity to, and we have the student is that we are starting a SEMLA residency program, right? It's like it's a 12 weeks program for students. The program is designed to provide them in a very short period of time access to experts to work on a very target project over the course of those weeks, from the ideation to the research solving part, and there will be some connection as well with potential and potential ideas and so on. So that's coming, stay tuned. And so it's just a cheap plug advertisement, but yeah, it's coming, and I think it will be awesome.
It's okay if we'll talk to the organizer to charge you for this advertisement.
All right, so I would like to thank our panelists. Thank you for the great questions. So we'll take, I think, a 10-minute break. We'll come back at 5 p.m. for our next session.
Super bien, merci pour les réponses. Super bonnes réponses. On a des petits cadeaux pour vous. I think it is. I think it is. I've never met him in person.
So. Oh.
Yeah. Okay. Good. So welcome back, everyone. I know we have been going through a long day with very exciting and interesting discussion. I hope you are enjoying this as much as I'm doing so far. So we still have one session to go before we can have our reception night with the first session. So in this session, we have two very exciting talks. I'm very excited about what's coming in this session. And the first talk will be given by Professor Haijovi from ETS. I'm a big fan of the work of Philip. Like, he knows every time I keep inviting him, forever. He really touched on something that I think is been a bit underexplored so far, the privacy and security issues of machine learning systems, right? So Rich will be talking about hiccups on the road of explainable AI, and I'm very much looking forward to it.
Thank you. Thank you, and thank you everyone for inviting me here. Okay, so my talk today will be about discussing some challenge related to the deployment of explainable technique in machine learning systems, at least in real world decision-making scenario. So I think it's fair to say that when we are deploying machine learning in high-stake decision system, we need transparency, right? And those systems can include anything related to finance, hiring, or in healthcare, for example. So what do we mean when we say we need transparency? So there is different stakeholder from which transparency can mean different kind of things. So with respect to regulatory agency, now we're having a lot of regulation already upcoming that are requiring some form of transparency in machine learning. So also we also need transparency to debug those models that you are building. In this case, the transparency will be more used by different engineers that are using the system or doing research. We also need transparency for other reasons like fairness for end users, but also providing recourse for end users when they are affected by an automated decision. So to achieve transparency in current literature, there have been a lot of work. Mainly, there are like two main approaches to do that. Either transparency by design, where you start your system from scratch, the system should be transparent. Like here I'm talking about linear models or other kind of rule-based model, or any type of model where the transparency constraints are considered from the start of the model. But you have another philosophy and another approach that will be, let's first build the models and then explain it in a post-hoc manner. So here you have different post-hoc explanation whose goal is to, giving the models and its prediction, we want some form of transparency that can say something between the relation between the inputs and the output or the behavior of the models. So then we have this huge field that is that has emerged in recent years called explainable AI. So the real question is it like some technology you can say that are really mature now that we can use to assess transparency in real world scenario, or is it just the hype we are observing? So according to Gartner Hype Cycle, it is the second one. So we are right in the middle of what is known in the Gartner Hype Cycle as the peak of inflated expectation. So right now we like hoping that explainability will be the key to solve all the issue of transparency, right? There is a lot of techniques that are promising this. But from the research point of view, we have different approaches that have emerged to answer the question, either by explaining the model from a global perspective. So here we don't care about individual decision. We want to more understand how the model is operating. So here we will more focus on global explanation. The other one is outcome or local explanation, where individual decision will be explained with some form of with different kind of model. It can be like feature importance, it can be anything like providing counterfactual explanation, this kind of also. My talk will discuss about what is the price of going to consider transparency. So we know that now, because of regulation, because of all these different stakeholders that are asking for transparency, we need transparency, but it comes with the price. And my talk will mainly focus on what are the privacy and security challenges that we have when we start considering transparency as a principal feature we need to have in this system. So from the trust point of view, there are different challenges. The first, and those challenges are with respect to different stakeholders. Those include the auditor. So someone from a regulatory agency, for example, that will try to assess whether a machine learning model is transparent. So we also have the end user that are requiring some explanation. And there are also different challenges that we can consider in this setting, where we have users asking for an explanation. We also have a practitioner, like let's say someone, a physician, for example, that is relying on the prediction of the black box models to make some diagnostic for the patient. In this case, he can also be affected by the explanation, and we will also discuss the challenge here. And the other challenge is with respect to a service provider that have built a machine learning models and is deploying it in to operate it. So here he may face different security challenges. So with respect to the trust challenge, the first one we have is we can have a black box models that have truly bad behavior that can be explained in a such a way that the explanation make it look nice. So in this case, the people that will be affected will be the auditor that were sent to say whether or not the model is interpretable or transparent. He may have a false conclusion that the model is effectively and behaving in a certain way, which may not be the case. And with respect to end user, we also have the same things where user can be giving false explanation to just rationalize some bad decisions that the black box model may have taken. And the second one, when we discussing trust, is with respect to practitioner that can, here we can have something that is disparate performance of the explanation when you consider different subgroups. What I mean here is that we can have the physician, actually the explanation can help the physician to make good informed decision for a group of users. But for another one, the explanation can mislead the practitioner into the decision that he's taking. So those are the trust issues that I will cover. And then with respect to security, I will discuss two different risks. The first one is here, it is the opposite of the first one. Here, your model is good. Your model is operating normally, but someone can accuse you of wrongdoing because of you need to provide explanation. Your explanation can be tempered in different ways. So here, as the service provider, you need to make sure that you have also covered this, consider this risk. The second risk is that now that you are somehow forced to provide explanation, you have to like release an additional API. So explanation API in terms of the prediction API that you used to provide. So here, what an adversary can do in terms of attacks when he's relying on both the prediction of your models and its explanation. So this will be the second challenge I will discuss. So with respect to the first risk with trust, the main family of attacks I will present are manipulation attacks, whose goal are to fool the auditor and the end user on what the model is actually doing, the model that is being explained is actually doing. So we call it fair washing, and the scenario of fair washing is just an instance of what can happen when you are doing manipulation. So we can generalize to something we can call property washing, where you have your models, your black box models that have some bad properties that you want to like wash. You want to fool everyone that your model is actually behaving correctly with respect to this property. So here we consider fairness as such property. So you take a model, a black box model that has a high risk of discrimination towards some subgroup, for example, and using explanation techniques, we can show that actually your model is not unfair. And you can use that to like rationalize the decision taken by your system. So you have this dishonest model producer that can now can give false perception that the model is following some ethical value. Here we just use fairness, but you can clearly, as long as you can encode the properties that you are measuring into some objective function that you can minimize, then you can potentially perform this manipulation on other properties. So we instantiate these attacks with an algorithm that we call laundry ML. And the goal of laundry ML is to take a black box model that have this bad behavior and design an interpretable model that will make it seem nice. So I will do an elevator speech to present the result of this work. So motivation, I think I already gave the motivation is that we need explanation for different kind of things. So the population, everyone is asking for explanation. So there is a real risk that people will try to wash these properties. So what we try to do with the laundry ML is we take a family of explanation and we want to say how easy it is to find explanation for a given model, explanation that can tell alternative story about what the model is doing. So to do that, we just give some penalty to the original objective function that you can use to search for explanation. We penalize this objective function with some unfairness. So unfairness here is the property that we are quantifying. So you first quantify the unfairness of your black box model. It ends up being quite unfair. Then you want to find explainer that have low unfairness, but keep a high fidelity, because fidelity is what we use to say, oh, this explanation is actually a good explanation. So you want the explanation to seem good with respect to establish a metric of good explanation in the community, while also making it less unfair than the original models. So those are the two metrics. The fidelity say how good the explanation is. The unfairness is the property we want to hide. We consider two variants of the attacks. The first one is we explain the models in the global. So as I said, we have two main family of explanation: global explanation and local explanation. So we want to find a global explanation that make the original model look better, right? When we are speaking globally, but we also do perform the same attacks for individual decision. So for each individual user that may say the decision is unfair, we can find an explanation for this particular user that make the black box also look nicer than what it is when we quantify the unfairness. So we tried the attack on different data sets, and we did find out that it's quite easy to perform the attack. At least the first time we performed it, we did find some proof for what the claim we are doing here, that it is easy, it is possible to find explanation that look good in terms of quality, but saying different things with respect to the model. We tested on different data sets that are used in the fairness and interpretability community, and we can find that we found out that it's possible to have high fidelity, which say how good the explanation is, while having lower unfairness as compared to the original models. In addition to that, we also compute the feature importance of the black box and the feature importance of the explanation to see how different those are. So because concretely, you can use the feature importance as proof of what the model is doing. So if you take this example where race, which is the sensitive attribute we are considering for the discrimination, the black box model is truly unfair. As you can see, the gender is like the second most important attribute in the decision. But after the attack, it was possible to make the interpretable or the explanation look way less. We make it such that anyone looking at the explanation will say, actually, gender is not used at all in the explanation. So it's clear here that you can rationalize the decision. We also do this. We also did the same thing for each individual decision. And here you have the CDF showing that basically you can rationalize every single decision, individual decision in the data set. So after these attacks, we want to investigate how easy it is to perform the attack. The first one was just, let's test the idea to see how it works. So we want to see if you have a bad model and you really want to cheat about what it's doing, how easy it is if you explore the whole set of possible explanation you can use to perform this attack. So here, instead of using a penalty in the search, we went to use a more formal constraint optimization to see if we want to have this lower bound on the fairness of the system while maximizing the fidelity. How far we can go in terms of the line we want to perform here. So this was the initial idea we have when we perform this series of work. So we end up seeing that it's actually quite possible to have very nice very high fidelity when you are, so we have fidelity close to 95, 96, for example, for different data sets in the system, while having unfairness that is really lower compared to that. But while doing this study, we also find out that surprisingly, we can also perform much powerful attacks in this scenario. That is, without even training your, because usually when you want to perform these attacks, you need to first, you have the black box, and then you have some users that are saying the prediction that they have is unfair. So actually, the initial attack was customized to this set of users. So it's quite easy to imagine that someone can detect this attack by just using another set of users and seeing how good the explanation are still, right? So we try to see how we can generalize the attack, if the attack actually can generalize beyond what we call the sewing set. That is the set that is receiving the prediction. So here we see that the attacks can generalize to unseen set of users. That was the first result, additional result we obtained. And the last one is the attack can actually transfer between black box models. So let's say you perform the attack, there is one company that performed the attack and it worked well, and there is another company in trouble. They can just use the same explanation that they use, providing they have some overlapping in the label agreement, right, of the black box. They can use the same explanation that worked well for the first black box models. They can use it for free for the unfair decision of another black box without performing the attack at all. So these are what we study here by comparing the transferability for different family of models, transferring from one black box to another. And the last result we have in this work was, now that we know that it's quite easy to have high fidelity, we want to see how can we quantify this risk. That is, if I know for this prediction task, I'm receiving some explanation, what can I say about any explanation models that I receive? Like, how likely any explanation it is to be a fair wash explanation or some good explanation. So to do that, we're trying to compute the range of unfairness of the models. Like for any fixed value for the fidelity, what range you have for the unfairness you may have for your explanation. This gives you the set of possible explanations you can use to lie about what the black box is doing. So if the set is big, that means you can't have the freedom to do whatever you want. So the attack is powerful. If the set is like really small, but also closer to the unfairness of the black box model, that means here you don't have that much freedom when you want to cheat. So we define the problem of evaluating this risk to just for any prediction task, you can do this work like beforehand to characterize the risk of fair washing for any prediction task. But what we observe in this work is that for almost all the data sets we consider, most of the time the range is big. That means you have in the space of explanation you can use for a particular level of fidelity, you don't have only one explanation. You have a wide range of explanations, so you can always cheat and do that quite easily. So hopefully, not hopefully, but when we are doing this work, there was other work that also studying the same kind of problem with respect to this multiplicity that you have in your model space. And we find some kind of connection between the two work. That's why we went to use this idea of characterizing the rational set, which is the set of all good models to do this evaluation. So the key takeaway here is that post of explanation can be used to underreport discrimination level of the black box model that they are explaining. And we show that this attack can work on either global or local explanation. We also, from what we observed so far, it's really difficult to detect this attack, right? If someone performs fair washing, it's quite difficult to say, giving an explanation, it's a good one or a manipulative one. So, for more information about this line of work we perform, we did several studies after the initial work about it, but more or less it was like do more characterization of the attack. So I put the information here for anyone interested. But there is also a very nice community that is studying all these adversarial explainability that you can also go and check. And the GitHub before was done by Uber. So now I only have about 5 minutes, so I will be fast for the second part. So how can we solve the problem? Or what we have done so far is we quantify the risk. So instead of saying we can make at least what we can do is to quantify the risk for any learning task, how easy it can be, because this depends on the learning task. So the data set you have for the learning task and the model you are using. So what you can do is for each such problem, you can quantify the risk of having this kind of attacks. And by just studying the range of the properties that you want to make sure that people are not cheating about, right? So if you find a way to do that, then it gives you at least some way to evaluate the risk of the attack. So from the good point of view, the good news about this way of doing is that at least you can quantify the manipulability of the explanation you are receiving. The bad news is that it's quite difficult to compute this set of all the possible explanations that you can have in order to learn what is the range of the property that your property of interest. So, but there is some promising direction that are trying to do it efficiently. So I put those that I'm aware of here for anyone. So basically, those work are about how to compute the rational set efficiently or how to enumerate model efficiently. So with respect to trust, the second problem we have is we may have subgroup performance disparity, which is you take your black box models, you have different it's providing explanation for the practitioner. The practitioner will rely to the explanation in order to make a diagnostic, for example, right? So it can be the case that for one group of the population, the explanation is actually helping the practitioner in making good decisions. But for others, it may be less beneficial to rely on the explanation. So what we did in this work is to conduct an empirical study to see what disparity we can observe for different explanation, for different explanation and for different quality metric for those explanation. So we consider a different list of explainability techniques. You may recognize most of them here. And we also consider different performance metric. And what we observe is that for the majority of these technique, we were able to observe disparity in respect to the quality. That means the explanation that you have for men, for example, are not the same that you're having for women, for example, right? For the same task. So the explanation can fool anyone that is relying on them to make decision in high-stake context. So the key takeaway here is that we observe this subgroup performance disparities. So the good thing you can do now is like do more study to know when we observe such disparity, and then develop also explanation techniques that are immune to those attacks. I think I will stop here to have time for questions.
Thank you. Thank you very much. Very interesting talk.
Any questions? So great work. I haven't read the paper, so probably I have to read the paper to understand everything. But my understanding, if I'm saying, you're trying to look at this local versus global explanations, and you're trying to take some of the examples and discuss some of the other examples, and that is how you're trying to understand whether or not those could be made.
Yes, exactly.
So then, I mean, there is a case. Say for example, I'm working at the bank, and I have these mortgage approval application where I can. There's gender race perfect groups over there, and I'm a data scientist, so I produce these, and now the regulatory agencies, they look at my model, they may try to apply their own explanation. You know what I mean?
Yes.
And how can I prove it? I mean, my explanation and their explanation could differ from each other, right?
Yeah.
How these approach?
So yeah, the goal is the problem is we need to consider the whole pipeline and to see what kind of attack is possible. So if you were the one that is providing a explanation, for example, you can fool them by using this kind of tricks, right? Like penalizing the search algorithm for using to find the explanation to do that. The bad news is this can happen even non-intentionally. Let's say you just do some random penalization, you can end up just picking up some explanation that may not be the best one, given the whole set of explanation that you could potentially select it for the task. So the first thing the bank can do, the regulator can do was to evaluate what is the range of possible unfairness or any kind of property they can have for any explanation. And then if you give them an explanation, they can say, oh, the explanation is in the low regime of quality, right? That try to do better, that you can, for some problem, they can have this range and require you to see, this is what your model is doing in terms of unfairness. If you want to explain it, we expect that this explanation to behave quite similar with respect to some property, then you can have this additional constraint on how the explanation will be. And it's not clear now what should be the set of property on which we should agree to say the explanation needs to match the black box model on those properties. So still a whole.
Thank you. Thank you very much again.
Thank you.
Now we have another very interesting comment joining us. I know where we live, very close to the first session, but I strongly encourage you to attend this talk. Pay attention to this. So our last speaker today is Pablo from Google Brand. And Pablo is very advocating on quality assurance when building machine learning models. So in this talk, he will give us an intersection of talk and mini tutorial on unit testing machine learning model. Nobody want to show this. Everything sure. So you need some time. Oh, okay. Okay. Okay, so Pablo will talk about unit testing. Right, perfect. So please.
Hello, everyone. Thank you for the introduction. As was said, my name is Pablo. I work at Google Brain here in Montreal, but I actually live in Ottawa. Okay, so let's get started. Hopefully, no more technical issues. Okay, so why am I giving this talk? So I'm a software engineer in Google Brain, but most of my day I actually spend as let's say, like doing more of a research scientist role. But I started at Google as a software engineer, so I still have a lot of the, you know, the rigor, I guess, or what you value when you develop software. And so I felt as a machine learning researcher that there wasn't enough emphasis in unit tests and software testing in general. So I proposed two tutorials, one at AAAI, one at NERVS, and they were both rejected. I don't know why. And so I tweeted about this the other day, and the power of Twitter, although we'll see now that Elon Musk bought it. But Foods responded and invited me to give this talk here. So thanks to the organizers for inviting me and giving me this chance to do this, because I do think it's an important topic for machine learning researchers and practitioners. So just very briefly, a little bit about myself. As I've already mentioned, I joined Google over 10 years ago, almost 11. And I joined in ads as a software engineer, working in machine learning, but as a software engineer, so heavy engineering. I did a little work at doing machine learning backend in Chrome. And then in 2017, I joined Brain. And now I mostly focus on research. But as you know, machine learning nowadays, even research is very engineering heavy. Okay, so now let's go back to the main topic, which is unit tests or testing in general for machine learning code. And so I want to come back a little bit to a more general question of why do we write code at all? So we, at a very coarse level, we write code to do a thing, right? So we want our piece of software to do something. And that could be obviously many different things. But obviously our software isn't operating in isolation. There's a whole ecosystem environment around it. It could be other pieces of code, it could be data sets, it could be users. Even some code is affected by things like the temperature in the room. So I don't know if you know this, but if you use confidence with GPUs, the NVIDIA GPUs, they have different algorithms for confidence. And the choice of algorithm that's used depends on which one runs faster at that point. And those things are affected by temperatures in the room. So that sort of non-determinism is outside of the control of the code that you write. And so you might write the code thinking it does the thing that you want it to do, but when these outside environments change, it does it differently, right? And so that's not good, because you wrote this code to do things a certain way, and if it doesn't do the things that you expected it to do, then your software is no longer reliable. And so how do we prevent or ensure that our code does the thing we want it to do? As a very simple motivating example, let's say we're trying to write a calculator piece of code. And so many of us probably did this during our undergrad as one of the projects in one of our classes. And so no, you have a calculator where you can type some numbers and some operations, and then you want it to produce the right output. And so just from this simple example, there's a few things that you can see can go wrong, right? The order of operations, whether it's parsing things correctly. Even though like the concept of a calculator is pretty simple, there's lots of little things that can go wrong in there. And so I don't know if the quality, can you read this? Okay. So this is an MNIST classifier. And actually let's switch over. I have a collab that I wrote for this. Oh yeah, this is, okay, great. So this. So I already ran the initial cells. This is based on an example given by the Flax repo. So anyway, this is just imports. This is the code that we use to load our data set or on this data set. And here, these are just helper functions to show the images. So we'll show like a grid of MNIST characters. I assume everybody's familiar with MNIST. Raise your hand if you're not familiar with MNIST. It's okay if you're not. Okay. Thanks for being honest. MNIST is this very classical task in computer vision, one of the first computer vision tasks. Who doesn't know who Yann LeCun is? Okay, Yann LeCun. He's one of the Turing Award winners, considered one of the pioneers of deep learning. He developed complex or these convolutional neural networks, and what he was testing it on was something like MNIST. Not quite MNIST, but it was of this ilk. And so what we have here is some characters, and the job of the algorithm of the network is to classify. So these are we know the labels. So this is a data set where we know what the answers are, and so this is the data set. So a bunch of these little characters that are hand drawn, and we have to be able to classify them. Okay, so we define the network here. You can see we're using a few convolutional layers and then some dense layers. I won't go into the details of that. So anyway, we can start a collab here. It doesn't have anything because it hasn't started training. And this is the code that I was showing you before. So we're going to load our image, and we're going to use this just to initialize our network. We define our loss function. I'm going very quickly through this, just for the interest of time. This is all using JAX, so we have to define a graph function, and then we can specify the batch size, the number of epochs to run. And this is just to sort of verify that we're permuting the data set, and so we're not always training things in the same order. We create our summary writer. I'll start running this already, just so it takes a little bit of time. And then this is our training loop, right? So in each epoch, we're going to take a permutation of our data set. We're going to get the batch of images and labels, and then compute the loss, the logits, by getting the gradients and getting the gradients of our loss function. This is how you do deep network training. And then we can compute our metrics like accuracy and the loss. And so we're going to keep track of this and log these down here. And so we also have a test data set where we'll evaluate using our network or the network that we've been training. We can evaluate how well our network performs on this held out test data set. Because if you only train on the training data set, you know that it might be overfitting, and that you only are able to detect that with a test data set. And here we're just going to write out our scalars. So we can see that it's a 28 by 28 image, and we can see that the batch size just for testing we used was 4. This is what we used here, and so things seem to be working okay. So let's check our metrics. Come over here to our tensor board, and we're just going to refresh this. Okay, so it's going to take a little while. Okay. Okay. So while this is running, let me see if you can you read this code, or is this too blurry? Okay, sorry about that. Let me see here. Is there anything wrong with this code? Aside from the title. Is there anything wrong with it? It could be. I mean, if it's fine, if you think it's fine, who thinks it's okay? Maybe this is a trick question. Who thinks it's not okay? Ignore the title. Maybe the bug is somewhere else. Maybe there's no bug. Sorry? Ah, very good. Yes. So this is a typo. There's a typo here. And so what is happening? What is the consequence of that? Right. So we assigned perm over here. Right. This was just to test and make sure we have the right permutation shape with this temp batch size. So what's the batch size we're using for training? 512? Who thinks 512? Who thinks 4? You have to raise your hand for one. It's written batch size, yeah. Who thinks it's 512? Who thinks it's 4? All right, you're undecided. That's okay. Playing it safe. Okay, let's refresh this and see how it's doing. So the accuracy, the training accuracy seems to be, the test loss seems to be going down quite a lot. The training loss seems to be going down quite a lot. Train accuracy seems to be going up. We're at like almost perfect accuracy. Test accuracy, not as much. So again, who thinks it's using 512?
But since you have mentioned variable name as that size could be 112, so anyone who's looking at this will say 112. But if you have worked with it, I don't think so 112 is the right size number because it's very big as well, and usually you need a lot of memory to run a bad size that big. So 4 looks more realistic.
So for what it's worth, you can run this on this GPU with 512. It works just fine. But you're right. Your intuition is correct in that it's probably 4, and it is. I can't remember who's part of the typo. The issue is that we were doing this temping here just to kind of verify that we're setting up the permutations correctly, and so we defined perm using this temp batch as a 4. And then when we come over here, we had this typo where we typed in perm instead of perms, but we're using perm here. This is the perm that was defined above with the batch size of 4. So this perm is never actually used. And so we're training with a batch size of 4 on the same, same 4 elements. And so that's why you can see you have the standard phenomenon where our training accuracy is basically perfect. Our test accuracy is terrible. And our test loss is really low, just like our train loss. Any guesses as to why that is? So let's go back over here. Actually, no, I'll use this here because it's hard to read that other one. Another typo. So even though we type the metric as test loss, we're actually printing out the same training loss. And so these are pretty, this is a fairly simple example of code that's not working. But as we saw, we had basically 3 problems. One is we're doing this kind of hacky way of verifying that we're doing the right thing, where we just write, do something with a different batch size, then write out the shape. And then we had this typo here that was catastrophic and basically meant we weren't training well at all. And we had this typo here, which was probably a standard copy paste error where we just copied the 2 lines and then forgot to change this from training to test. So when you look at this, I mean, it looks okay. And if you were to evaluate, for instance, print out, figure out how many of the test characters or what fraction of errors are in the test data set, we can see that we have 80% errors in the test data set. So you clearly know something's wrong. But I mean, this is a pretty short example. Like this is just probably less than 100 lines of code. So it's fairly simple to dig in and find that. But if you have a much longer code base, and when you're writing research code, I know a lot of researchers will just kind of write things in one big thing. And then when I review for papers, I look at the code and it's like one giant file. If you have a problem, it's really hard to find. It's like finding a needle in the haystack. And so this is where unit testing really comes in and can really become useful. And so I'll be covering some best practices. I'm a little worried about the blurriness of the images, so hopefully we'll be okay. But some of the topics I'll be talking about are, these are not comprehensive, so there's definitely way more things when you think about unit tests, but we'll talk about breaking things into units, mocks, checking failures, parameterization, documentation, integration tests, and then code help. So I'll be using some examples from 2 repos that I'm the lead for. One is dopamine. This is a library for doing reinforcement learning research. And the other is the balloon learning environment. This is a whole environment. We published a paper 2 years ago in Nature where we used reinforcement learning to fly balloons in the stratosphere to bring internet to the world. And the balloon closed, as probably many of you know, but we built a simulator that is a faithful simulator of what we were using, and so people can test it out. It's pretty neat, but complex simulator. And so for those of you who don't know even how do you even write unit tests, this is kind of the skeleton. So you can use, there's other libraries you can use for testing, but I like Absol testing. And so you can just import Absol test and parameterize. This is a useful tool that I'll talk about later. And so you create a class. Typically, the standard format is to, if you have your function is called sample, you would call this sample test, and then you define your tests here. And this is what causes it to run when you run it from the command line. And this is it. So you write your tests in here. Okay, so the first point is breaking things up into units. Coming back to this motivational example of the calculator, we talked about how you can have many different parts that can go wrong. And so if you have, again, one big file that tries to do everything, a whole bunch of if-else statements, it's likely going to be buggy and it's going to be very hard to find the bugs. And so what you can do instead is to break things up into units. There are units that can sort of operate on their own. So you can have a parser, which just converts this string into like the different tokens. You can have an adder, subtractor, etc. All the standard things you'll have in a calculator. And so what's nice about that is if you split these things into units, then you can test each of these in isolation. So we can look at, for instance, the adder. And the adder now doesn't have to worry about the string, doesn't have to worry about edge cases, doesn't have to worry about multiplication. All it cares about is that if it receives 2 inputs, it's going to output the sum of them. And so now this is a pretty simple thing to test relative to the whole calculator. And so we can then come up with some test cases just to sort of test it out. And obviously you can add some edge cases and things like that. But in general, this is a pretty simple function to test. And you can do this with all the other units. And so then if you verify that each of these in the individual units are working as expected, then you can be more confident that your whole calculator will work well. A natural question, we're talking about machine learning here, a natural question is, well, we're not dealing with simple adding 2 numbers. We're dealing with neural networks where you have these weights changing and you don't have a data set. And so think how the weights change are affected by learning rates and what optimizers you use and what batch size. How are you going to write unit tests for that? And so it's true that writing unit tests for the network dynamics, the learning dynamics is kind of tough. This network doesn't exist in isolation. It's not like somebody brings you a network and that's it. There's a whole bunch of stuff that happens around it. Like these little arrows are not just arrows. This is actually code that's taking in an image from a data set. It's figuring out its label. It's feeding it somehow. It might require reshaping, might require normalizing, might require grayscaling or something like that. And then we feed it through the network, and in the network we have to compare it against the label. So there's lots of code that goes around this network. Deep learning is not just the parameters in a deep network. This is the blurry example, so I'm going to skip this. But what I wanted to highlight here is that in this example we had from the Colab before, even though it was written as one long piece of text, there's clear things that we can sort of split out into isolated units. For instance, the loss function. This is its own function, and we can put it in a separate file and test it in isolation. We have this internal loop. This is where the bug was, but this is where we're taking a batch of data and actually computing the gradients on it, and then updating our optimizer with that. And so that we can do in isolation. We don't have to do it for multiple loops. We can do it in one loop, and we can verify things like shapes, and we can verify things like batch sizes and things like that. Then you have the outer loop, which is calling this inner thing. So if we've tested this inner loop, now we don't have to actually test that again once we test the outer loop. We can just test the functionality of the outer loop. And then you have things like writing out the metrics that you can also test in isolation. And you can write separate functions for these. So if you write these as modular isolated units, it makes it a lot easier to combine them and test them in isolation. And for instance, if you do it that way, you don't actually need this hacky thing where we want to sort of write a print statement that convinces us that we're doing the right thing when in fact it was actually introducing a bug. Oops. Okay. So again, to come back to this eminence classifier, as I said, the machine learning code is not just a network. So we have loading data, we have code to show images, in this eminence example, metrics, the loss function, etc. And all of these things you can write in isolation, you can test for them in isolation. This is an example from dopamine, where we have this logger object here. This is the object that we're testing. And so this logger is something I wrote that's just essentially like a souped up dictionary. And so we test this here with these asserts. We create an expected dictionary. So after we create this logger, we assign values, and we just kind of make sure that it's assigning values as you would expect. So this is a pretty simple test. It's a fairly simple object, but it just highlights what you're trying to do with these tests. You're trying to test for the functionality and make sure that when you give it something in, it returns something that you would expect. Okay. By the way, if you have any questions, feel free to interrupt me at any point. So something that's extremely useful when writing unit tests are mocks. And so when we write unit tests, as I said, we write something that kind of calls our code and then verifies that the code is doing what it's expecting to do. But the code, as I said before, doesn't work in isolation, and it'll likely call some other code. Some of this other code might be code that you wrote yourself, or might be some other library that you don't have control over. And especially in this case, when you don't have control over the library, it's really hard to write unit tests for that, because if they change something, it might change the functionality of your code. And so what you can do is you can write mocks that sort of intercept calls to the external libraries or function calls, and kind of fakes the output. And so then you can control how this other code behaves within the context of your unit test. Okay, so this is, for instance, a piece of code again from dopamine. This is just to initialize a checkpointer. And so we can see in this code, there's a few objects we're calling. We're calling this checkpointer library to create this checkpointer object. We're again calling the checkpointer library here to get the latest checkpoint number. And then we're loading this checkpoint, and then we're accessing this internal object called log. And so if we want to test this function, just the logic of this function, we shouldn't have to worry about what happens with the checkpointer object. This is a separate thing that should have its own unit test. So when we're testing this, we really don't need to be calling this. The other thing is sometimes these calls can be quite expensive, right? So if you're writing something to the network, or if you're writing reading a large file from disk, something like that, it'll cause your unit test to go really, really slowly. And that's something you want to avoid. Really what you want to check is things that are happening within that code. And this way, this unit, that's why they're called unit tests. So these are the kind of the things that are going externally and that we want to try to avoid. I think it's somewhat readable. So there's different ways you can create mocks. So for instance, here I created a mock checkpointer for that object, and it's using this library called mock. And so this basically creates that little purple rectangle that essentially just intercepts things. So now that I created this mock checkpointer, I can do things like when it calls the load checkpoint function within the mock object, you can specify what it's going to return. And this is nice because then when your function calls this external thing, you know what it's going to return, and then you can deterministically verify what your function will do. So that mock checkpointer is used here. So you can see I'm creating a mock checkpointer by calling this function. And then what I'm going to do is I'm going to assign the return value of the constructor to be this mock object I created here. And how did I get access to this constructor? Well, this is another way to create objects. You can use this mock.patch decorator, where what it's doing, it's saying, in this library, you might get a call to this function checkpointer, which is a constructor in this case. And so by using this decorator, you essentially are mocking that, and you can assign the return value. So again, we're assigning this new object we created. And you can use these mocks for any type of call to a library. And this allows you to control deterministically what's happening. And so once we do that, now we can really verify just the logic of our internal function to make sure that it's behaving as expected. You can even create your own totally mock objects. So this is not, you can see it's not actually using the mock library. It's a completely new class, but it has the same signature as the object we're trying to mock, this logger. And so this, what we can do here is when we create the mock call to the logger constructor, we can say that the object it will return will be this totally custom mock object here. So this is actually not the best way to do things. I just put it here as an example of what you can do. There's better ways using the mock library itself, where you can create mock objects automatically just from the signature of the object you're trying to mock. So the idea again of mocks is really to try to intercept any external call from your function. You just want to test your function in isolation. Okay, any questions regarding mocks? If not, I'll go on to the general failures. Okay, so all the examples I've been showing you so far have been testing, if I give it 2 plus 3, it should give me 5. If I give it 7 plus 0, it should give me 7. So these are like positive outcomes or the expected outcomes of your function. But you also want to check failures of your function. So for instance, in this create agent function here, you can see that I have to pass in a session and an environment. And then the agent name is actually optional because it has a default value of none. So if you just look at this, I mean, the doctrine does tell you that agent name needs to be provided, otherwise it will raise a value error. And so we can test this in our unit tests to make sure that if we call this function create agent without an agent name, it's going to raise an assertion error. And why do you need to do this? Some of the hardest bugs I think to find are when things work too well. So if you have your machine learning model and it has perfect accuracy, like we saw with the test accuracy or the test loss, that can sometimes be a sign that something's not working. So you want to make sure that when you explicitly send in something incorrect or wrong, that it actually raises an error or returns some indication that things are not as expected. So those are quite important to check, just to make sure that your code only accepts what it should accept, and when it does it properly. So again, another way to do this is for instance, this call to runner inside this constructor. It's going to try to get the latest checkpoint number here. It's going to try to call this. And if this, we know that if this returns a -1, it's a sign of an error. And so by mocking this, we can sort of check that it is actually raising a permission denied error when we don't find the latest checkpoint to load. And again, this is just checking these failures to make sure that your code does what it should be doing, but also doesn't do what it should be doing. Okay. Now on to parameterization. Again, this is another really useful tool they use for testing. So we had this example here with the adder, where we can come up with a few examples to verify that it works well. And so one way you can write this test is to just write out those examples explicitly. So just make different calls to the adder and make sure that it's equal to what you'd expect it to be equal to. But that's kind of verbose, and every time you want to add an example, you have to sort of duplicate that code. So there's quite a bit of code duplication here, which is also always a sign of smelly code. So another way you can do it is to just write a for loop. And then we're only calling this assert equal, and we're only calling the constructor or writing the code for the constructor once. And then it's going through this loop. But this is also kind of onerous to, like, if you want to write a new triple to test for, you know, it's kind of annoying to write it at the end of each list. And again, it's kind of error prone if you write it not at the end of the list or something like that. So a better way to do this is using these parameterized decorator. So this is from absolute test again. So here we add this these parameterized parameters, and we can pass in these triples that we have here, and these correspond to these parameters in our test function. And so now we just have one line is our test function is just one line. And when we want to add new values to test, it's really easy to do this just from this one line here. So this example is pretty small. It doesn't seem like it helps all that much. But it's also useful for, you know, you can use parameterized name parameters. And here you can give it your different test cases names. And this is extremely useful when you want to indicate what it is you're doing, right? If we just passed in pressure ratio and then did this power table.lookup, for somebody that's not familiar with this code, this kind of doesn't mean anything. But by adding these test case names, we know, okay, so this corresponds to a low pressure ratio, this corresponds to a high pressure ratio. Now you start to get a better sense for how the code actually works, not just the test, but the code itself. This is from the balloon learning environment, which is simulating physical systems. So a lot of the code is actually they're hard-coded lookup tables or interpolating tables that can get pretty complex and hairy, and they're very difficult to sort of get a handle on. And we'll come back to this in a little bit about how we can use these to understand the code better, not just test that the code is doing the right thing. Another, as I mentioned, this balloon learning environment is simulating physical systems, and we have these lookup tables that have been developed over decades by engineers. And so testing for them can be kind of difficult because we want to test different shapes at different intervals. So it's basically a combination of different linear functions. And this, you don't just want to test one point, because then you're not testing the whole shape of your curve. And so we can do this fairly easily with this parameterized. You can see these are a lot of parameters that if you were to write this in a for loop or using zip or something like that, it'd be pretty ugly code. But doing something like this, it's a lot of lines because there are a lot of parameters, but the test itself, you can see it's really just one line. And we're just testing the values that we have. And now we can kind of get a sense somewhat of, you know, what the relationship between pressure ratio, the charge, and how much power is expected to be used, which are parts of the simulation. We can get a better sense for how they work. Okay, so I'm going pretty fast because I know we're way over time, and we want to get to the poster session. Now I want to talk. I briefly mentioned that unit tests can serve as documentation for your code, not just to verify that your code is correct. So again, coming back to the balloon learning environment, can anyone, if somebody looks at this higher code, does anyone understand what this is doing? Can anyone explain what this is doing? Yeah, I couldn't. It took me a long time to stare at this code, and I mean, I wrote this code, but it took me a very long time to understand what I was trying to do. And it took us a while to get it right, and we had to communicate with a lot of aeronautical engineers to make sure we actually had it right. But this is the function. So this get fan efficiency. This is the fan of the stratospheric balloon. It's calling this lookup table. It's kind of a table that's doing this interpolation, and it's passing in pressure ratio and the power, and then that gives us the efficiency, whatever efficiency means. I didn't know what this was when I started working on this thing. So if you look at this code, it's pretty mysterious. And if you're coming new to this code, you can look at this and you know, you can try to run some tests and see what happens manually. But again, that's not the best way to do this. Because we have unit tests, we can look at these and they're named. This gives us a little bit of a documentation for what's happening. So we can know that, okay, the min efficiency, at the min pressure ratio, which is 1.05, we can see the efficiency we're going to get is 0.4. And at the max pressure ratio of 1.35, we can see that the efficiency is lower. Now we can start to get some sense of what these relationships are. We can see that if we're below min, we're still sort of clipping the values at 0.4 and at 0.3. So this makes understanding the code a little bit easier. And I think unit tests they're not always thought of in this way, but I actually like to think of them as documentation for your code. Often when I look at a new piece of code, if I don't understand it, I'll go to the unit tests to get a better sense for what's actually happening. Okay, so yeah.
It makes sense for this integrate the database, for example, instead of just standardizing here. Connect the database and pull data from the test. Is that the standard practice, or every standard practice goes in that direction of this document side?
There are some cases where we'll have, for instance, a separate file that contains data. I wouldn't say database is probably pretty heavy-handed. Again, because these unit tests you want them to run fast, and I'll get to why we want them to run fast in a little bit. But sometimes you do want to test, for instance, these shapes. If they're very long, like we had that long parameter list. So you could think of putting that in a separate file and loading that file. I tend to prefer not to, because I like my unit test to be sort of self-contained, where everything you need to understand what's happening is in that file. If there's an extra step where you have to load a different file, that's error prone in itself. And so maybe you need a unit test for that loading function. So it adds extra dependencies that might introduce. Exactly. So this is where I'm coming to with integration testing. So what I've talked about so far is unit testing, where everything we're trying to do things in isolation. So we have our calculator here. We know that each of our units is working well, but obviously they don't operate in isolation. We need to combine them somehow. And so this is where integration tests come in, where once you sort of convince yourself that the units are okay, you can write a test for testing the unit as a whole, or the piece of software as a whole. And so these are, for instance, from Dopamine, some very simple integration tests where we have unit tests for these individual components, but you see we're calling the main function, the main training function. And we're doing these quick DQM flags. I don't show the code here, but what we're doing is essentially setting flags in a way that it just runs very few number of iterations with a tiny network, just so things run quickly. And really what we're doing here is tiny containment types. We've already tested our unit tests, and what we're trying to do here is make sure that we can actually execute things and things don't break. This is also really useful. I talked about these external dependencies. We've added these models for the unit tests. If the external dependencies change their API, for instance, or change the type of the return value, this will affect your code. And the unit tests won't catch them because you've mocked everything out. But when you have a simple integration test like this, even though it doesn't seem like it's testing much, it's just kind of making sure it runs. When they change that API, this integration test will fail because now your code won't be able to execute well. And so it could be very simple, but it's really complementary to the unit test that you've already written. And there are obviously more in-depth and robust ways of doing these integration tests. At Google, for instance, we'll have some integration tests that are more comprehensive. They take longer to run, and so we'll, for instance, run them overnight, like once a day. They don't run every time. The unit tests, on the other hand, and I'll get to this in a little bit, they'll run every time you want to, in GitHub lingo, every time you want to, for instance, commit something to the master branch. All the unit tests that are affected are running. And if you broke a test, you won't be allowed to commit. And that's how we one of the ways we try to maintain code health. And this brings me nicely into code health. So at Google, we have a separate way of doing things, but there is a way of doing things in GitHub. This is, for instance, from Gymnasium, which is sort of the successor of Gym. If anybody here has used reinforcement learning algorithms, you've probably used Gym environments. And so whenever you create a pull request for them, you have this checklist. And you have to run this pre-commit checks, which are essentially running your unit tests. And you have to add any tests for any logic that you changed or any new functionality that you added. And this is how you try to maintain code health, especially if you have something where lots of people are contributing to that code. You want to make sure that all the old tests still remain healthy, and that if you're adding new functionality, that you have new tests that will make sure that that new functionality remains healthy as new changes come in. Okay, so part of the reason why we want to add this code health is, again, we have this code that's not operating in isolation, that's doing a thing. If, for instance, the other pieces of code turn from blue to red, we want to make sure that when that happens, our integration tests or our checks are raising an error and telling us, alerting us about this. either not allowing the other person to submit or telling you that something just broke and you should look into it. And that will avoid your code from doing this other thing that you want it to do. Okay, and just to end off, sorry, we're quite late. Some final considerations that I wasn't able to really cover here. But there are these tools that allow you to do test coverage. And what this does is it kind of goes through your source code and highlights lines in your source code that aren't covered by tests. And so the goal is to have 100% coverage, which means that every single line in your code is tested by some unit test or integration test. And this is really useful to make sure that your code remains sane and healthy. Again, this is sort of summarizing what we did. We look at behavior-driven tests. So the point of unit tests is really to make sure that your code does the thing that it does, right? So it's easy to get lost sort of in the nitty-gritty of the values and the code and all that, but really at a high level, what you want to do is make sure that the behavior of your code is behaving as expected. What you want to test are public APIs. So you might have internal functions that are not externalized. These are, some people like to test them. I mean, I think if they're internal, they're meant to not be externalized. So I think what you want to focus on is testing those things that other libraries or other users will be using. You want to test edge cases. Obviously, this is kind of standard in unit testing. But coming back to machine learning specific issues, shape issues are very, very common in machine learning, as I'm sure many of you have encountered. And this is something we can actually test pretty easily. You don't have to worry about gradients. You don't have to worry about optimizers. You can just make sure that the way your code is setting up the data and feeding it into the network is doing it correctly. So where the batch is the first dimension and things like that. Sources of randomness, we do use a lot of randomness in machine learning, and this can always be kind of difficult to test because it's random. So, you have to either run 1,000 times and say, okay, roughly about 10% of the time it did something. This is less robust. I've been using JAX. I don't know if many of you use JAX here. I think it's really elegant and really well done. One of the things I love, which actually is something that people find a little hard to get used to at the beginning, but you actually have the user is in charge of a pseudo-random number generator. And you pass the pseudo-random number generator around, and you have to sort of split it to create new random number generators. This is really useful because it allows you to deterministically check for randomness. So if you pass in the same pseudo-random number generator to two functions, they will operate the same way. And so this is extremely useful for writing machine learning unit tests because now you can kind of get rid of the randomness. In your code, you can do things like initialize the random number generator with something like time or a hash function or something like that. But if you pass in the same value, same 0 every time, it'll always produce the same thing with JAX. Modulo the GPU non-determinism that I mentioned earlier. And you can also make sure that metric logging is happening correctly because ultimately when we're training these models, we want to see those lines going up. If we're talking about accuracy, or going down if we're talking about loss. And if they're not reporting the actual thing, then we might be deluding ourselves that our model is working correctly. Okay, and that's it. I know I'm way over time, so thank you for inviting me. Sorry for taking so long. Thank you very much.
We close. I know everyone's tired. We close the process session, but is there any question? Any last question?
Thank you so much. That was super interesting. One question I had regarding would be, how would this apply to checking like model health as well? So for example, let's say a user passes something that's out of domain, like a cat image to our MNES, something that's out of the distribution or out of the domain. Is this something you could catch with this kind of framework?
Yeah, that's a very interesting question. So I think this would likely correspond a bit more towards something like an integration test. So what you can do is, for instance, if you have a trained MNIST classifier that's already been trained to classify MNIST images, so we can have a threshold that any MNIST image that will pass to it will be able to classify it with certain accuracy, right? Above, let's say, 80% or something like that. And so you can have a test where you read in a cat image, for instance. One thing like unit tests will be able to catch are things like if the cat image is a much larger image, it'll immediately detect that. But let's say it's a 24 by 24. If you feed it through the network and I guess one thing you need is a label for that. So if it has a label and the accuracy will likely be much lower than the threshold, that's something where you might be able to catch this. But again, this is a bit more like an integration test where you can reload previous checkpoints and make sure that they're operating correctly. So it is a challenging thing to do because every time you train a network, it'll be a bit different because the initialization is different. So for instance, in reinforcement learning, not my team, but there's some other teams at Google that have these integration tests that run nightly. And so for instance, they'll train DQN on Pong. For those that know, it's an Atari game, it's a standard benchmark. Pong is the easiest Atari game, so you can get to like pretty good score within an hour. So they'll run like one of the algorithms for an hour. And if it hasn't passed, 0, if it's still at like the negative scores, then you know something's wrong. And so then that raises an alarm. So you can do things like that.
I'm wondering if you use this type of testing for evaluating different models, but also for verifying the prediction results. If you have like a reference prediction results that you can compare them, but also if multiple models are giving you results.
Yeah, that's a good question. So I guess if I understand correctly, what you're asking is how reliable each different run of the algorithm is with respect to accuracy. So it depends on how large your model is. So it's something like an MNIST classifier. You can probably write like a smallish integration test that just runs nightly, initializes it a whole bunch of times, and just kind of make sure that every time it trains correctly. That's like a feasible thing. But if you're, for instance, training, I don't know, GPT-3, like that takes weeks to train. And so you're not going to write a test like that's trained once. And so that's a very large model that, as long as you get that one model that does really well, that's your target. If you want something that you can retrain multiple times and you can do that really quickly, that's something that you can test for. But again, if you want to train from 0, it depends on how long it takes to train a model. Something that you could do is do something like fine-tuning verification. So if you have a trained checkpoint and you fine-tune from that checkpoint, make sure that every time it's able to increase accuracy.
You change the model, let's say something for either or the data that you can model. Have you verified for regression of the system? So does this check for regression also?
So if you have already trained your model and then you change the data, I mean, that's kind of an open research question in itself. It's more like a multitask setting. So that I doubt there's tests for that because it's kind of an open research question. A lot of the training dynamics are really hard to test for, like just does it train or does it train well? Because it depends on a lot of things like learning rates and what optimizer you use and different things like that are more of a design choice. So whether you can get your model to train depends on that type of thing. What you can do though is if you find these hyperparameters that work well, you can store them somewhere, let's say in some config file, or you can set them as default parameters for your functions. And what you can do is add tests that make sure that those are still the default values, that somebody didn't come in and by mistake, remove the decimal point or something like that, because that would essentially break the training for everybody. So you can do things like this, like not necessarily having to train the model directly, but now that you've written your unit tests to make sure that your system works well, and you found these hyperparameters that work well, you've already tested the system with unit tests, and you have other tests that make sure that your hyperparameters are same, and that you can do that without necessarily having to train the model from scratch.
Thank you very much.
Top 10 of appreciated. It's are you staying?
No, I have to go make dinner.
So we have the pause session.